All right, people. I believe everybody's doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. Okay. I would want you guys to smash the like button if you have not liked the session yet, because liking the session is marking the attendance, and marking the attendance is extremely mandatory in our sessions. Okay. And let the people come, let the people join. We will be starting accordingly. Okay. And tell me, how is it going? How is it going? Is it going good? Let me know in the chats with the fire emojis. Everybody out there, are you guys excited for the today's session? Because when it comes to the today's session, we will be talking about the kinematics 1D as well as 2D. Now, what are the topics that we are going to discuss in the today's session? Let me just tell you. We will be starting with distance and displacement, all the question patterns of distance and displacement. Then we will be moving on to the velocity and speed, average velocity, instantaneous speed, average speed, every single thing. Then we will be moving on to the acceleration, average acceleration, instantaneous acceleration, positive acceleration, negative acceleration, retardation, every single thing we'll be talking about in detail. Then we will be moving on to the equations of motion. Okay. And then some of the beautiful concepts and important concepts also I have put up over there. And then afterwards, we'll be talking about the graphs. Okay. Position time graph. We say velocity time graph, acceleration time graph, and the graph convergence. And then we will move on to the projectile motion, kinematics 2D. Okay. And in kinematics 2D, we'll be talking about the ground to ground projectile, horizontal projectile. Okay. And we have relative motion also, relative velocity concept, relative displacement concept, relative motion in 1D, relative motion in 2D. You have got this rain man problem, river swimmer problem. Every single thing will be done and dusted. Okay. Quickly, guys, if you have not liked the session yet, I would want you guys to smash the like button as soon as possible, as quickly as possible. Okay. And then we will be starting with the session. Then we'll be starting the session with high Josh. Okay. Now, my dear friends, listen to me very carefully. Listen to me very carefully. Let's first talk about kinematics 1D. Since what does 1D actually mean? What does 1D actually mean? Okay. 1D means one dimension. 1D means one dimension. And most importantly, my dear friends, just a second. Okay. Now, my dear friends, listen to me very carefully. Listen to me very carefully. Everybody out there. When it comes to the kinematics 1D, what we are supposed to study in this particular chapter, that is, we will be talking about after some time. Let's suppose you have got a car over here. This car is moving. Okay, this car is moving. I will ask you, what is the displacement of the car? Tell me the displacement of the car. How fast the car is moving? What is the velocity? What is the speed? What is the acceleration? Okay, all of these terms are discussed in kinematics 1D. And this is what we call motion in a straight line. Body will be moving in a straight line only. And that is what we will be discussing in this particular chapter. That is what we will be discussing in this particular chapter. Now, guys, first and the foremost thing that I want you guys to understand over here. What is kinematics? It is study of motion. We are supposed to study the motion. Okay, if the car is moving, okay, with what velocity it is moving, what is the acceleration of the car, all of these things. Okay. Now, first topic that we need to discuss over here is that is frame of reference and observer. Frame of reference and observer. Let's suppose, my dear friends, listen to me very carefully. Let's suppose, my dear friends, there is a person over here. There is a person over here. And this is, let's suppose, point A. Let's suppose point A, or you call this a tree over here. I'm saying this person is at 10-meter distance with respect to this tree, From this tree, this person is at what distance? 10-meter distance. So I would say, in this particular case, this A is considered as the frame of reference. Okay. A is considered as the frame of reference. So means when we consider A as frame of reference, we say this person is at 10-meter distance. Let's suppose this is point B. Sir, with respect to point B, it is at 15-meter distance. Means when you consider B as frame of reference, this person is at a distance of 15 meters. So frame of reference simply means with respect to what you are talking about. Like. In this particular case, listen to me very carefully. Let's suppose this car is moving. This car reached over here. It's at 10-meter distance from this particular point A. Similarly, with respect to the point B, it is at 12-meter distance. So it is mentioned over here, with respect to the point A, car is at 10 meters. With respect to the point B, car is at 12 meters. So here we take A and B as frame of references with respect to what you are talking about. And I would want you guys to basically take the notes with me only, and afterwards I'll be sharing the PDF also. The PDF will be shared in this Telegram channel, that is t.me/YAWARMANZOOR. This is the Telegram channel you guys are supposed to join. Every single notification, whatever the important notification is there, I send it in this Telegram channel. So I would want you guys to join this also. You can search it in the Google and you'll land onto this channel. Okay. And frame of reference can be anything. You can consider the tree also as a frame of reference. So with respect to that tree, I'm at 50-meter distance. Okay. That is what we call the frame of reference. With respect to what you are exactly talking about. Okay. Now, my dear friends, one more important thing. Let's take an example. Let's suppose there's a car over here. And this car is actually in motion. It's in motion. And inside this car, you have two persons. We have A and you have got B. This person A, person B. And there is another person over here which is at rest on the ground. Listen to me very, very, very carefully. My dear friends, if I ask this person B, could you please tell me, is this A in motion or this A is at rest? This person B will say simply this A is at rest. Why? Because he is just sitting next to me. I can speak to him. I can share anything I want with him. So according to person B, A is at rest. Yes, sir. Then, my dear friends, if I ask this person C, is A at rest or in motion? Person C is saying this A is in the car. If car is moving, means A is also moving. So according to C, we say A is in motion. Now, who is correct over here? We say both. Who is correct over here? We say both. We say here, C and B are considered as observers. The one who observes the situation, is what we call the observer. When you ask this person, when this observes the situation, when this says A is at rest, means this is considered as observer. When this is observing the situation, means this is the observer. Okay. The one who observes the situation is called the observer. Like, I can give you one more example. Let's suppose, my dear friends, if I say, there is a tree over here. And this is the car. We say this person A is saying, sir, this car is at 10-meter distance with respect to the tree. Means this person is observer. And this is frame of reference. Okay. So the one who observes the situation is called the observer. And with respect to what you are talking, that is what we call the frame of reference in that particular case, my dear friends. I hope this is crystalline clear. Let me know in the chats if this is crystalline clear. Guys, session is going to be long. Please concentrate because I will be teaching each and every single topic. Doesn't matter if you have studied this before. JEE students can also watch this lecture. That is for sure. Let me know in the chats if this is crystalline clear. Everybody with the fire emojis. And if you have not liked the session yet, I would want you guys to smash the like button as soon as possible. Everybody out there. Everyone means everyone. You can get the PDF of the session in this Telegram channel. Okay. T.me/Yawar Manzoor. You can search it in the Google and you'll land onto this particular channel. Okay. That's great. That's great. Now, my dear NEET aspirants, listen to me very carefully. Position. Let's talk about position. We say it is the location of an object with respect to the frame of reference. Location. What does location mean? You say coordinates of that person. Where that person actually is. That is what we call the location. Like. We say, where is this car? We say with respect to the tree, if I am considering this as frame of reference, this car is at 10 meters. So this 10 meter is the location right now with respect to this, with respect to the frame of reference. So we say here position of the car is 10 meters. Car is at 10 meters. This is the position of the car. In simple words, you can remember it like this. I have told you the position vector in vectors also. We have discussed it over there, basic maths also. Okay. So with respect to the frame of reference, we say car is at 10 meter distance. So this is the position of the car. Now listen to me very carefully. We say if the position is changing with respect to time, if I say position is not changing, means this car will be here only. It will be at rest. It will not be moving. Now if the position is changing, means after some time car reaches here. After some time car reaches here. So if the position is changing with respect to time, we say object is in motion. And if the position of an object is not changing with respect to time, we say object is at rest. If this is the position of the car at t is equal to 1 second, after 5 seconds only, it has got the same position. We say object is at rest. Now, if the position is changing, it is moving. So we say car is in motion. We say car is in motion. Yes. Now, types of motion. Types of motion. First, we'll be talking about one-dimensional motion. One-dimensional motion. What is one-dimensional motion? One-dimensional motion means it is a motion along straight line. If I say there is a car over here, it is moving along a straight line, it is one-dimensional motion. Like this along x-axis only. We say here, only one of the coordinate is changing. Only one of the coordinate of the object is changing. Like. Guys, see, let's suppose this is y-axis and this is x-axis. This is x and this is y. And let's suppose there is a car which is moving something like this horizontally along x-axis only. It does not go like this. No, horizontally only. We say here only x coordinate is changing. We say when the car reaches here, value of x is 1, value of x is 2, value of x is 3, value of x is 4. But y remains the same. We say only x coordinate is changing. It is one-dimensional motion. So if I release this object, it will fall down. It will fall down along this vertical direction. So this is also one-dimensional motion. Why? Because only y coordinate is changing. Here y is 5, here y is 4, here y is 3, here y is 2, here y is 0. But x remains the same. X remains the same. When only one of the coordinates of the body is changing in the motion, it is called one-dimensional motion. It is called one-dimensional motion, 1D motion. Then you have two-dimensional motion. It is called motion in a plane. What does two-dimensional motion mean? We say here two of the coordinates of a body are changing. Listen, if I throw an object something like this in a parabolic path. If I throw an object something like this in a parabolic path, okay, like projectile motion, this is y-axis, this is x-axis. If you throw an object something like this, when the object reaches here, we say in x it has moved this much. This is the we say displacement in x direction. This much it has moved along horizontal direction. And this much is the displacement along vertical direction. So means when the object is moving along this path, it is moving in x, it is moving in y also. we say two of the coordinates are changing, x as well as y. So example is projectile motion and circular motion over here. Okay, we say here object is going up also and object is moving forward also. Object is moving forward also. That's why we say it's a two-dimensional motion. Please tell me in the chats if this is clear. Please tell me in the chats if this is crystal and clear. Then you have got three-dimensional motion. Guys, I would want you guys to tell me in the chats if this is crystal and clear. Everybody, and smash the like button if you have not liked the session yet. Everyone means everyone. Is it clear? Ah, that's great. That's great. Now, three-dimensional motion. What is a three-dimensional motion? See guys. Listen carefully. This is x-axis. This is x-axis. This is y-axis. This is y-axis. And this is z-axis towards you guys. If I say, listen to me very carefully. If I say object is moving along x-axis only, something like this, it is one-dimensional motion. If I say object is moving along y-axis only, it is one-dimensional motion. Even if it is falling down, it is one-dimensional motion. If I say object is moving something like this, it is moving along x as well as in y. It is going forward as well as upward. So it is two-dimensional motion. Okay. Now if I say the object moves something like this, it is moving in x, okay? It is moving in y, it is going up also, okay? And it is coming out also, it is going out also, okay? It is going out also. So means object is moving in x, in y, as well as in z. That's what we call three-dimensional motion. We say here, that motion in which all the three coordinates are changing, okay? Please take the feel of this particular example. Object is moving something like this. It is moving in x, it is going up as well as it is coming out. So example is flying kite, we say flying bird. Okay, you can say these are the examples of three-dimensional motion. Okay, example of the plane also. That's the example of three-dimensional motion. Now, my dear friends, the first topic that we have over here, that is distance and displacement. Let me just give you the feel of distance and displacement in this. Listen carefully. Let's suppose this is your house, this is point A, and this is your friend's house, point B. You are supposed to go from your house to your friend's house, okay? Let's suppose you are moving along this particular path. Something like this. This is the road which government has constructed. From A to B. If I'm saying you are moving from A to B, okay, and you finally reached over here, then while you reached B, then you started saying your friend, what if we construct a path something like this, which is directly from A to B, something like this? Don't you think this is going to be the shortest path? But right now, actually you covered this path. You were traveling through this path. This is path, let's suppose X, and this is path, let's suppose Y. You are actually traveling through the path X. But what if you construct a path from A to B, something like this? This path that you actually covered, this is what we call distance. And this path, which is the shortest one that you are thinking that you will make it in the upcoming time. So this is called displacement. That's why we say distance is the actual path that you have traveled. If you travel from A to B along this path, then this is the distance and this is going to be the displacement. So what if we What if we travel from A to B along the straight path only? In that case, this is going to be distance. In that case, this is going to be displacement. As simple as that. We say, in that case, this distance will be equals to the displacement. In that case, distance and displacement is going to be the same. Okay. Okay. Yes. So this is how we define distance and displacement. This is how we define distance and displacement. Now, guys, take a look. Let's suppose if I'm traveling from A point to B point along this path, this is 15 meters. Okay. Now, I can say, is there any shortest path which you can make from A point to B point? You say, yes, that is this 10 meters. This is distance and this will be displacement. So what is distance? It is how far you have moved, this much. Okay, it is the actual path covered. This is the proper definition. It is the actual path covered. Okay, don't say it is how far you have moved. This will create confusion. So simply say it is the actual path covered. You were actually traveling through this path. Okay, and it is how much you have displaced, or we say it is the shortest path between the 2 points. It is the shortest path between the 2 points, because this can be only the shortest path between A and B. Okay. And it does not have a proper direction. You see this distance? Here direction is upward. Here direction is this. Here direction is downward. Here direction is downward, upward. So it does not have a proper direction. When it comes to the displacement, it has a proper direction. It is pointing towards B. It is pointing towards B. It is the shortest path between the 2 points. It has a proper direction. Okay. We say it is a scalar quantity, and this is a vector quantity because it has a proper direction. So we say it is a vector quantity. Okay. And when it comes to the distance, we say distance cannot decrease with time. Let me show you how. Guys, see. Let's suppose this is point A and this is point B. This is point A, this is point B, and this is point C. Listen to me very carefully. I'm saying this is, let's suppose, 2 meters, and this is, let's suppose, 2 meters. Let's suppose you traveled from A to B. This is, you traveled from A to B. Then you traveled to C. Then you were moving back and traveled to C. This is your journey. In this particular case, while you were moving from A to B, how much path you have covered? Sir, that is 2 plus 2 is 4. From A to B, 2 plus 2 is 4. While you were coming back, how much distance you added to this? Sir, this 2, this 2, this 2. Means total path, actual path that you have covered, that is total 6 meters. This 2 plus 2 plus 2 is 6. And when I say displacement, my dear friends, displacement is this much only. Displacement is this much only. It is the distance between initial point, that is this, and the final point, that is this 2 meters only. We say in this particular case, displacement is 2 meters. Now you see, while traveling from A to B, how much is the distance? We say, sir, 2 plus 2 is 4. A to B. And how much is the displacement? 2 plus 2 is 4. Yes. Listen carefully. While traveling from A to B, how much is the distance? Only A to B. Distance is 2 plus 2 is 4. How much is displacement? 4. Shortest path between A and B is 4. While you were moving back to C, how much is the distance? 2 plus 2 plus 2, that is 6. And how much is the displacement? Shortest path, that is only 2. Now you see, from traveling A to B, B to C, displacement decreased and distance increased. That's what is mentioned over here. Cannot decrease with time. It can decrease with time. Please tell me in the chats if this is crystalline clear. Please tell me in the chats if this is crystalline clear. Is this clear? With the fire emojis, everybody out there. Distance cannot decrease with time, but displacement can decrease with time. Okay, that's great. That's great. Now guys, we say this distance cannot be negative. Distance cannot be negative. But when it comes to the displacement, it can be negative, it can be positive, it can be 0 also. It can be negative, it can be positive, it can be zero also. Negative, positive, as well as zero. Let me just tell you. Let me just tell you how displacement is zero, positive, as well as negative. Before that, listen carefully. We said this displacement is also called change in position. Displacement is how we can find displacement, change in position. Change in position means final position minus initial position. Listen carefully. Let's suppose this is the question. Initially, the particle was at point A at x is equal to 1, 1. Here, x is equal to 1 meters. Then particle traveled from x is equal to 1 to x is equal to 4. And I am asking you how much is the displacement. You say, sir, this is the displacement between the two. Yes. Now, how can we calculate the displacement? Final position minus initial position. Position means where the object is, location with respect to the origin. This is the origin. So it is x is equal to 4. It is x is equal to 1. So we say final position over here is 4 minus initial position is 1. So 4 minus 1, that is going to be 3. So it is plus 3. Displacement is positive plus 3. Now let's suppose this is yx. From this side, it is minus 1. And over here, it is, we say, minus 5. If I say what is going to be the displacement in this particular case? So displacement is final position minus initial position. Initially it was here, finally it is here. So you'll be saying, sir, final position is minus 5 minus initial position is minus 1, because here position is minus 1. From this side it is positive, from this side it is negative. So it is going to be minus 5 plus 1, that is going to be minus 5. Now, if you ask me, sir, what is going to be the distance in this particular case? My dear friends, distance is going to be 3 here, because distance is how much it has traveled, how much is the actual path it has covered. That is this 3 only, because it's a straight line. And in this particular case, if I say distance, that is going to be 4 only. That is going to be 4. Because distance you cannot consider negative. Distance is positive. Distance is positive only. Okay? Okay? Distance is positive only. So that's what I'm saying. So this distance cannot be negative, but when it comes to the displacement, it can be negative, it can be positive. How it can be 0? Listen to me how it can be 0. Listen to me how it can be 0. See guys, let's suppose you are starting from point A. Okay? Okay? This is point A. This is point B. And from here it is 20 meters. From here to here. A to B, this distance is 20 meters. Let's suppose, my dear friends, in this particular case, if you travel from A to B, then from B to A. Okay? If you travel from A to B, then B to A. Could you please tell me how much is the distance? Sir, distance is this 20 plus this 20. Total actual path length. How much you have traveled? That is 40. 40 meters. And if I ask you how much is the displacement? Displacement is the distance between initial point and final point. Your initial point is same, your final point is same. It is the same point from which you actually started. So displacement in this case is 0. So displacement can be 0, displacement can be positive, displacement can be negative. I hope this is crystal clear to each and every single student. Okay, yes. Now guys, let's suppose the question is something like this. Let's suppose the question is it clear till over here, all of these points? Guys, tell me in the charts, is this crystal clear till over here? Tell me guys. Smash the like button if you have not liked the session yet. Liking the session is mandatory, everybody out there. Now guys, let's take a look. A particle moves from a point A to B. A particle moves from a point A to B. Find its displacement in the following cases. This is the initial point. And these are the coordinates of initial point. These are the coordinates of final point. Now guys, see. If you remember the lecture vectors, in lectures, I have told you how can you find the position vector if the coordinates are given. Means how can you write the position, initial position vector of this? How can you write the initial position? It is 2i cap plus 3j cap plus we say 4k cap. This is how we can write the position vector. Position vector means where is the location of the particle. Where is the location? That is, this is the initial location, initial position. In vector form, we can write it like this. And final position, you can write x final, because this is x coordinate, y coordinate, z coordinate, I, j, and k. So here it is going to be 7i cap plus 5j cap plus we say 9k cap. Okay, this initial position, this is final position. If you ask me, sir, displacement, I have told you displacement is simply final position minus initial position. This is the displacement. Now, what is final position vector? So that is going to be 7i cap. Now tell me, guys, see, how do you subtract the two vectors? We say 7i cap minus 2i cap. Because this is 7 minus 2, that is going to be 5i cap. Plus 5 minus 3, that is going to be 2j cap. Then 9 minus 4, that is going to be 5k cap. This is the displacement vector in this particular case. And if you find the magnitude of this displacement, you can find it, that is under root of, I would say, this 5 square. Now, don't ask me, sir, how can we find the magnitude? Because we have studied this previously. So whatever is the coefficient of I cap, whatever is the coefficient of j cap, whatever is the coefficient of k cap, under root of this square plus this square plus this square. This is how we can find the magnitude of any vector. I hope this is crystal and clear to each and every single student. Let's suppose you have questions, something like this. Find the displacement in each case. If the particle travels from A to B, then B to C. So this is 4 meters, this is 3 meters. Could you please tell me how much is going to be the distance? Distance is 4 plus 3, that is going to be 7 meters. How much is going to be the displacement? Displacement in this case is also 7 meters. If the particle travels along the straight line without changing the direction, if the particle travels along the straight line without changing the direction, we say distance and displacement will be the same. In that case, distance and displacement will be the same. And if you ask me, what is the distance over here? Guys, from A to B, it is 4 meters. From B to C, it is 3 meters. Total is 7 meters. And if you ask me, what is the displacement? Displacement will be distance between initial point and the final point. Now tell me, guys, if this is 4, this is 3. 4 minus 3, that is 1. So this is going to be 1 meters. This is going to be 1 meter. And if I ask you, how much is the distance over here? Body travels from A to B, B to C. So A to B, it is 4, B to C, it is 3. That is going to be 7 meters. And if I say, what is the displacement? Displacement is join this initial point with the final point, that is this displacement. Now this is base, this is perpendicular, this is hypotenuse. So what is going to be the value of hypotenuse? It is under root of base square plus we say perpendicular square. Base square plus perpendicular square. Now tell me, under root of 4 square plus 3 square. 4 square is 16, 3 square is 9. So it is going to be under root of 25. That is going to be 5 meters. Okay. Okay. I'll give you the break exactly at 9 o'clock. Okay. Because we have to finish a lot. There are a lot of questions that I have put up over here. Now guys, take a look. Now take a look. Now take a look. A particle moves 5 meters along east. Now guys, see. You can say it something like this, or you can understand it like this. Guys, see. A particle is moving 5 meters along east. This is east. Okay. This is east, this is west, this is north, and this is south. A particle is moving 5 meters along east. 5 meters along east. So east means plus x. Okay, something like this. This is east, this is west, this is north, this is south. So 5 meter east means 5 I cap. Because if a vector is along x direction, you can mention I cap with that, because that I cap tells you the vector is along positive x axis. Okay. We say 5 meters along east. Okay. So it means 5 I cap. Then it says, then 6 meters along north. 6 meters along north. Okay. So means north means upward, means 6 J cap. And 10 meters upward. Guys, see. Listen. You can, if you guys see this in 3D, this will be east, this will be west, this will be north, this will be south, and this is upward and this is downward. You can consider it like, wait. No. Wait. See. This is east, this is west, this is north, this is south, and this is upward and this is downward. You can understand it like that. So means then it says 10 meters upward. So means this is 10 K cap. If I say 10 meters downward, yeah, it's in 3D. If I say 10 meters downward, then it is minus 10 K cap. Then find the distance and displacement in this particular case. Could you please tell me in this particular case, what is going to be the distance and what is going to be the displacement? Quick. Everybody out there, tell me, what is going to be the distance and what is going to be the displacement? Guys, distance is simply 5 meters plus 6 meters. Sorry, 5 meters plus 6 meters plus 10 meters. 5 plus 6 plus 10. 5 plus 6 plus 10. Okay. Now that is 21. Okay. Then, my dear friends, when it comes to the displacement means this 5 I cap, because displacement is a vector quantity, plus we say 6 J cap. Okay. Then plus we say 10 K cap. This is the displacement. Now you can find the magnitude of the displacement also. How can you find the magnitude of displacement? Under root of this square plus this square plus this square. That is 5 square plus 6 square plus we say 10 square. This is how you can find the displacement magnitude. I hope this is crystal and clear. Take a look at this question. See guys, find distance and displacement. This is the particle is moving along x-axis. This is x is equal to 0. Here x is equal to 3. Here x is equal to 7, minus 2, minus 7. Something like that. Sir, x is equal to minus 1 would be over here. Yes. X is equal to minus 3 would be over here. Yes. Minus 4, something like that. Now particle travels from minus 7 till minus 3. Then it comes back. Then it goes here. Then it goes here. First and the foremost thing, you tell me, my dear friends, in this particular case, if I say what is displacement? Displacement means final position minus initial position. See, what is the initial position? Initially, it is at x is equal to minus 7. What is the final position? X is equal to minus 2. Done and dusted. So final position is minus 2 minus initial position is minus 7. Now tell me, minus 2, minus into minus is plus, so plus 7. So plus 7 minus 2, it is going to be plus 5. Okay. It is going to be plus 5. And if I ask you distance, sir, distance is also simple. Distance means this path plus this path plus this path plus this path. Now tell me, from here to here it is 7. It is 7. And this is plus 3. 7 plus 3 is 10. So we say this 10 plus. How much is this? Sir, from here to here, 3 to 0, it is 3. Plus. Then from 0 to 7, once again, it is 7. Plus. Then from 7 to 0, it is 7. Then we say plus 2, that is 9. That is 9. Now tell me, 10 plus 7 plus 3 is 10. 10 plus 10 is 20, 29. 29. 29. Okay. Yes. Now guys, take a look. Distance and displacement in a circular path. Distance and displacement in a circular path. Listen carefully. Let's suppose, my dear friends, a particle is moving in a circular path. A particle is moving in a circular path. Let's suppose this is the radius of the circle R, this is the radius of the circle R. This particle started from this point to this point, from point A to point B. Can I say, sir, when the particle started from point A to point B, this is the actual path it has covered, this is called distance. And what is displacement? Join initial point and final point. This is the shortest path between the two, it is called displacement. Okay. If an object moves from A to B in a circular path, distance in that particular case means this arc. And could you please tell me how we use the formula, that is angle? Angle is equal to arc upon radius, arc upon radius. What is angle? Angle is theta. From A to B, how much angle it has created? Theta. And this is arc, that is distance. And radius is r. Now take this over here. So this distance is going to be r theta. So distance in that particular case is going to be r theta. Distance in that particular case is going to be r theta. Okay. Okay. Yes. And if you ask me displacement, sir, how do we find the displacement? We are not supposed to derive over here. Just remember directly. Displacement will be if you have two vectors r and this is also r, similar vectors. If we have two equal vectors having theta angle between them is theta, then the resultant of that vector is going to be 2r sine theta by 2. If we have this r, okay, and angle between this r and r is theta, then the resultant of these two vectors, it is going to be 2r sine of theta by 2. 2r sine of theta by 2. Okay, this is going to be the displacement, that is 2r sine theta by 2. Directly remember. Sir, like. Let's suppose if you have a question something like this. A particle travels from A to B. Could you please tell me in this particular case, what is going to be the displacement? Okay. What is going to be the displacement? Sir, what is distance? Distance is r into theta. This r into this 120. What is the displacement? Sir, that is 2r sine of theta by 2. 2r sine of theta by 2. What is theta over here? 120. So this is 2r sine of 120 divided by 2. And then if you ask me, sir, we can write it 2r sine of, I would say this is 60 over here. What is the value of sine 60? That is root 3 by 2. So this is going to be 2r and this is root 3 divided by 2. 2 and 2 will cancel. So this will be root 3r. This is the answer. This is the displacement in this particular case. Okay. I hope this is crystalline clear. Let's suppose a similar question if I give you over here. Let's suppose if an object moves from this point to this point. If an object moves from, this is radius r, this is point A, till point B, something like this. And this angle theta is equal to 90 degrees over here. Okay. So how can we find displacement from A to B? If you say, sir, displacement in this case, that is going to be 2r sine of theta by 2. That is 90 divided by 2. That is 45. So this will be 2r sine of 45. What is the value of sine 45? That is 1 by root 2. So this is going to be 2r sine 45 is 1 divided by root 2. Now guys, what I want you guys to do in this particular case is, we say multiply with root 2 and divide with root 2 over here. Now root 2 into root 2 becomes 2, because root 2 into root 2 is root 2 whole square. Square and root will cancel, it will come out to be 2. Now this 2 and this 2 will be cancelled. What remains? A root 2r. Let me know in the chats with the fire emojis if this is crystalline clear. Everybody, let me know in the chats if this is crystalline clear. Tell me if this is crystalline clear. Smash the like button if you have not liked the session yet. Let's take a look at this question. An object moves on a circular path by an angle of 60 degrees. An object moves on a circular path by an angle of 60 degrees. Okay. There is an object which moves on a circular path by an angle of 60 degrees. This is point A and this is over here point B. Find the ratio of distance to displacement. Okay. We are supposed to find how much is the distance upon displacement ratio. First and the foremost thing, could you please tell me how much is the distance? Guys. We say distance is simply that is r theta. Radius multiplied by theta. Theta is 60. 60 means pi by 3. So what you can write over here, this distance is going to be that is r and this is pi by 3. Yes. Or pi by 3. And if I ask you what is the displacement in this case, displacement will be 2r sine of 60 by 2. 2r sine of theta by 2. Sine 60 by 2 is sine 30. So in this particular case, this is going to be 2r sine of 30. Sine 30 is 1 by 2. Okay. Sine 30 is 1 by 2. So this 2 and this 2 will be cancelled. So this is basically r. Okay. Now guys, tell me, in this particular case, what is going to be distance upon displacement? That is going to be, that is pi r divided by 3 and divided by this r. This and this will cancel, so it will be pi by 3. Is this clear? Oh, tell me in the chats, everybody out there with the fire emojis, if this is crystalline clear. Everyone means everyone. Everyone means everyone. Another pattern of question. See, if the position of the particle is something like this. Now, I am not telling you the position of the particle is x is equal to 10 meters. What does it mean? Particle is at 10 meters. X is equal to 20 meters. What does it mean? Particle is at 20 meters. I am saying the position of the particle is something like this. It depends upon time. Like if I say position of the particle is x is equal to t square. So means when time is 1, position of the particle is 1 square is 1. When time is 2, its position is 2 square is 4. It is at 4 meters. When time is 3 seconds, position is 3 square is 9. Okay. Yes. Now guys, in this particular case, if the position of an object is x is equal to, this is the position, x is equal to t square plus 2t plus we say 4. This is the position of an object. Then find the displacement in 4 seconds. Okay, we have to find the displacement in 4 seconds. First, we say displacement in 4 seconds. Guys, how do we find the displacement? So displacement means simply final position minus initial position. Sir, what is the final position? Final position in this case is when time is 4 seconds. When time is 4, what is going to be the position? We say at guys, at t is equal to 4 seconds. What is the final position? Listen carefully. Put the value of t is equal to 4 over here. Okay, so this is 4 square is 16 plus 2 into 4 is 8 plus 4. Now 16 plus 4 is 20, 20 plus 4 is 24, 28. This is going to be 28 meters. So when time is 4 seconds, particle is at 28 meters. And one more important thing. What is that? We say at t is equal to 0 seconds. When time is 0, what is the position of the object? Where is the object actually? Sir, 0, 0, and this is 4. We say initial position is 4. Now tell me what is the displacement? So displacement is going to be final position minus initial position, 28 minus 4. That is 28 minus 4. That is going to be 24. This is the position. This is the displacement. Then it says displacement in fourth second. Listen carefully. I'll make you understand. Second, displacement in fourth second. See guys, if I say the body is traveling from this point to this point, so t is equal to 0 seconds. After 1 second it is here, after 2 seconds it is here, after 3 seconds it is here, after 4 seconds it is here. If I say how much is the displacement, total displacement in 4 seconds, you say, sir, from 0 to 4, this is the total displacement. If I say what is the displacement in first second, this is the displacement in first second, this much. What is the displacement in second second? This is the displacement in second second. What is the displacement in third second? This is the displacement in third second. Okay. And this is the displacement in fourth second. So we are supposed to find this. We are supposed to find this. We are supposed to find this. This is displacement in, we say, fourth second. Displacement in first, second, third, and this is fourth. Now, how can you find this displacement? Sir, it is simple. We will find this displacement. We'll find the position at t is equal to 3. And we'll find the position at t is equal to 4. Okay. So this position minus this position, it will give you this displacement. Or if I say particle is here, then finally particle is here, you can say this final position minus initial position, that will be this. Now, how can you find displacement? Guys, at t is equal to 3 seconds. Let's find position. Let's find position. Call that initial position. Put t is equal to 3 over here. So 3 square is 9 plus 2 into 3 is 6 plus this is 4. Now tell me, 9 plus 16 is 15, and this is going to be 19 meters. And we say at t is equal to 4 seconds. When time t is equal to 4 seconds, sir, what is the position that we have already calculated? 28. So we say final position is going to be 28 meters. Now, when time t is equal to 3 seconds, it is at what position? 19 meters. When position t is equal to 4 seconds, it's at what position? 28. And if I ask you what is the displacement over here, you say that is final position minus initial position. That is 28 minus 19. That is going to be. How many of you understood this? Let me know in the chats. Everybody out there. Sir, will you teach motion and gravity today? Yes, obviously. Obviously. Do you think I'll leave something? What kind of question is this? Smash the like button if you are not liked the session, and guys. Quick. Okay. Now, guys, listen to me very carefully. This is my car. Okay. And I'm traveling from A to B. I'm traveling from A to B. Okay, with my car. And listen carefully. Listen carefully. While I'm traveling from A point to B point, while I'm traveling from A point to B point, I'm asking you how fast I'm traveling. How fast I'm traveling from A point to B point. Sir, 20 kilometers per hour. This is how fast you were traveling from A to B. Yes. From A to B. In general. Now. Next question. If I'm saying, while traveling from A to B, how fast you were traveling and what was your direction? How fast you were traveling and what was your direction? And duration is going to be 9 to 10 hours. 9 to 10 hours. Or 8 to 10 hours. I would say 8 to 10 hours. Between 8 to 10 hours. Okay. So if I'm traveling from A to B, I'm saying how fast you are traveling along with the direction. I say, sir, 20 kilometer per hour towards east, towards east. Tell me, what is the difference between the two? What is the difference between the two? This example is only telling you how fast you are moving. This is only giving you the magnitude, how faster you are. This example tells you how fast you are moving from A point to B point along with the direction. So here this will be considered as velocity and this will be considered as speed. This is the difference between the two. Speed only tells you how fast you are going. Velocity tells you how fast you are going along with the direction. And if you say from sir A to B in general, it means average speed. Because you are not asking me the speed at a particular instant, that is instantaneous speed. So you are saying me from A to B, that is average speed. This is average velocity. This is average speed and average velocity. Now take a look. Average speed. If you are moving from A to B, let's suppose, what does it say? How fast an object is moving in an interval from A to B. How fast you are moving, that is speed. How fast an object is moving in an interval along with the direction, that is average velocity. Now guys, if you find average speed, you say, sir, it is total distance traveled. How do we find speed? Sir, how much distance you have covered? How much time you have taken? So here we take distance because speed is a scalar quantity. So we take a scalar quantity distance. So we say total distance traveled upon total time taken. And here we say total displacement traveled upon total time taken. Okay. And we say this total distance traveled, okay, means if you travel from A to B along this path, this will be the distance, this will be the displacement. Total distance traveled you can write as delta D also. Even you can say, sir, this delta D will be, sir, we say final, no, don't say position. We say final distance minus initial distance. Okay, average speed, delta D divided by delta T. It is a scalar quantity. Okay, and its SI unit is meter per second. Why? Because we measure this distance in meters and time in seconds. That's why meter per second. And here it is total displacement traveled. How we mentioned, we denote displacement with S, delta S by delta T. You can write it like this. Okay. Now guys, take a look at this example. Yes, game of NEET is going to go smooth. It will go smooth till the last lecture. Okay, chill. You can trust. Now guys, see, this is a car. This car is moving with 20 meters per second. This car is moving with 20 meters per second. Now guys, tell me, in this particular example, what I can say over here, speed of the car is same. Speed means how fast the car is moving. 20 meters per second, 20 meters per second. That's speed. Okay. Every second it is covering 20 meters. Every second it is covering 20 meters. So means 20 meters per second, 20 meters per second. So speed of both the cars is same, how fast it's moving. But when you talk about velocity, velocity of A is not equal to velocity of B. Why? Because direction is different. This is moving towards east. This is moving towards west. So direction is different. So velocity is different. So velocity is a vector quantity. It depends upon magnitude as well as direction. If both cars have same magnitude, same direction, then I can say velocity is. Let's take a look. A particle moves from the origin to point A. A particle moves from origin to point A and took 2 seconds. From 0 to A, it took 2 seconds. Then it moves to point B and took 3 seconds. It took 3 seconds to point B in the following figure. Find displacement, average velocity, average speed. Okay, sir. From A to B, B to C. Sir, this is the displacement. Join this initial point, join this final point. So when I say displacement, it is going to be, guys, this is base, this is perpendicular. So it is under root of base square plus perpendicular square. This is going to be 5. Okay, because this is 3 meters, this is 4 meters. 3 square is 9, 4 square is 16, 16 plus 9 is 25, root 25 is 5. So displacement is 5. displacement is 5. And when I say distance, distance is 3 plus 4, that is 7. 7 meters. Now, my dear friends, if you ask me the average speed, first we'll talk about the average speed. Average speed. What does average speed say? Sir, that is total distance traveled upon total time taken. Now, what is the total distance traveled? Distance traveled is 7. What is total time? Guys, this is 2 seconds. This is 3 seconds. 2 plus 3 is 5. 7 by 5. 7 by 5. Okay, this is meter per second. And if you ask me, what is the average velocity? If you ask me what is the average velocity, you'll say, sir, total displacement traveled upon total time taken. So what is the total displacement? That is 5. Time is, sir, this 2, 3. If it is taking from here to here, here to here, 5 seconds. Okay. So from here to here, this distance is covering in the same time, 5 seconds. So 5, it is 1 meter per second. I hope you got the feel of average velocity and average. Now take a look at this question. Very important. I would want you guys to listen to me very, very, very carefully. Yes. Yes. Now take a look. See, guys. What does the question say? An object is moving in a straight line without change in direction. An object is moving in a straight line without change in direction. Okay, something like this. Moves x1 distance in time t1. It has traveled this x1 distance in time t1. And it has traveled this x2 distance in time t2. x1 and x2 in time t1 and t2. Okay. Then find the average speed and average velocity. Guys, in this particular case, if the particle travels along the straight line, don't you think distance is equal to displacement? Array, sir, yes. So whatever is the average speed, same as the average velocity, because distance and displacement are same. So average velocity and average speed will be same. So let's talk about VAVG over here, average velocity. Guys, the basic formula you will need to remember in order to find the average speed, average velocity, that is total displacement traveled upon total time taken. That's it. This you guys need to keep in your mind. Total distance traveled upon total time taken. Now see, what can I say total distance in this case? Sir, this is x1, this is x2, x1 plus x2, that is total distance. So this is x1 plus, I would say, x2 upon, what is time? T1. What is time? T2. So this will be T1 plus, I would say, T2. Done and dusted. Done and dusted. Take a look at this. Important. An object moves with a speed v1 for time t1. Now see. Distance in this particular case is not given. In this particular case, what is given over here? Velocity. v1. An object moves with the speed v1 for time t1. Then it moves with the speed v2 for time t2. An object moves with the speed v1 for time t1. And then moves with the speed v2. This is v2. This is v1 for time t2. Find the average speed. This object is moving the speed of v1 for time t1. Then it is moving the speed v2 for time t2. Okay. We are supposed to find average speed, average velocity. How do you say? Total displacement traveled. Guys, this is the basic formula. Every time you guys are supposed to use this. Then you have total time taken. Now you tell me one thing. See. Total distance traveled. Let's suppose, sir, but distance in this case is not given. Na? See. Velocity is given, time is given. Can you find distance over here? Guys, we say, listen. We say velocity is equal to displacement upon time. How do you find distance? Distance is equal to velocity into time. Yes, sir. So if I say x1 over here, that is v1 into t1. If I say this distance x2 over here, that is v2 into t2. Hey, sir, yes, sir. So what I can say total distance traveled, that is v1 into t1 upon then plus V2 into T2, then upon T1 plus T2. I hope this is clear. Hey, bro, if V1 and T1 are given, V1, T1. If V2 and T2 are given, V2, T2. Okay. Now tell me, this is going to be the average velocity in this particular case. This is going to be the average velocity in this particular case. Now tell me. I would want you guys to tell me one thing. What is that? See. We say if this V1 and this V2 are equal, if V1 and V2 are equal, no. If T1 and T2 are equal, if T1 is equal to T2 is equal to T, means, if I say a body has a velocity of V1 for time T, and then it has a velocity V2 for time T. If I say this T1 and this T2 are same, please don't confuse yourself over here. So means for this much of time, like for first 10 seconds, its velocity is V1. Then for next 10 seconds, its velocity is V2. Can I say in that particular case, V average, how can we say that? That is over here, instead of this is going to be V1 into VCT plus, we say this is V1 into T plus V2 into T upon this T plus T is 2T. This T will cancel. It will be V1 plus V2 divided. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Is this clear? So what I'm trying to say is that if an object has velocity V1 for time T, like an object has velocity V1 for 10 seconds, then V2 for next 10 seconds, average velocity will be directly writing V1 plus V2 divided by 2. V1 plus V2 divided by 2. Okay? V1 plus V2 divided by 2. Yes. Oh, is this clear? Please tell me in the chats. Okay. And this is for 2 intervals. If I say for 3 intervals, 3 intervals means if an object has velocity V1 for time T, then V2 for time T, then V3 for time T. Like for first 10 seconds velocity is V1, for next 10 seconds velocity is V2, for next 10 seconds velocity is V3. In this particular case, average velocity is going to be V1 plus V2 plus V3 divided by 3. For 2 intervals, it is V1 plus V2 by 2. For 3 intervals, it's V1 plus V2 plus V3 by 3. I hope this is crystalline clear. Okay. Let's suppose if I give you the question, something like this. An object has a velocity of 20 meter per second for first 10 seconds, then 30 meter per second for next 10 seconds. Find VAVG. Find VAVG. See, I'm saying an object has, for first 10 seconds, its velocity V1 is 20 meter per second. For next 10 seconds, its velocity V2 is 30 meter per second. Now, directly I'm asking you, what is going to be the average velocity in this particular case? What will you say? That is V1 plus V2 divided by 2. Because when you see time and velocity is given, and when you see equal time is given, you simply say V1 plus V2 by 3. Now, if I say for next 10 seconds, its velocity is 40 meter per second, you will add V3 by 3. So this is going to be 20 plus 30 divided by 2. That is 50 by 2. That is 25 meter per second. Oh, I hope this is crystal and clear. Questions have been asked from this pattern in your JEE. Please tell me in the chats with the fire emojis if this is crystal and clear. I need the signal in the chats, then only I'm moving forward. then only I'm moving forward. That's great. That's great. Now, guys, take a look. An object moves x1 distance with speed v1. Now, object is moving x1 distance with speed v1 and x2 distance with speed v2. And this x2 distance with speed v2. Let's suppose an object is moving 50 meters with 20 meter per second, 30 meters with 25 meter per second. Then find the average velocity, average speed, average VAVG. How do you find VAVG? Total displacement traveled upon total time taken. How much is total displacement? That is x1 plus x2. x1 plus x2. How much is total time? Time is not given. Guys, velocity is displacement upon time. So we can say time is displacement upon velocity. Could you please tell me what is going to be the time in this particular case? Displacement is x1, velocity is v1. So that is displacement upon velocity. That is x1 divided by v1. And if I say t2 over here, that is x2 divided by v2. So what I can say over here, this is t1 plus I would say t2. Then you can write over here x1 plus x2 upon t1 plus t2. That is going to be x1 divided by v1 plus x2 divided by v2. This is going to be the average velocity in this particular case. This is going to be the average velocity in this particular case. Now take a look. If x1 is equal to x2 is equal to x. If I say this x1 is equal to this x2 is equal to x. Let's suppose the body is covering first 30 meters with v1. Body is covering next 30 meters with v2. In that case, what is going to be the average velocity? Guys, put over here, this is x plus x. This is going to be 2x upon. Now here, x by v1, x divided by v1 plus x divided by v2. We can write it like this. Now you tell me this x will cancel. So average velocity in this particular case will be 2 upon 1 divided by v1 plus 1 divided by v2. You can keep this in your box, something like this. This is going to be the average velocity. Let's suppose if I say for three intervals, means if an object moves from this point to this point. So first x it is covering with v1. Next x it is covering with v2. Next x it is covering with v3. In this particular case, if I say what is going to be the average velocity, you say 3 upon 1 by v1 plus 1 by v2 plus 1 by v3. This is going to be the average in that particular case. This is going to be the average in that particular case. Okay. For two intervals, this one. For three intervals, this one. Let's take a look at this question. A bus traveling first 1/3 of the distance with a speed of 10 meters per second. See guys, A bus is traveling first one third. Let's suppose this distance is S, this is S, and this is S. Total is 3S. First one third it is covering with V1 is equal to 10 km per hour. Next one third means next one third it is covering with V2 is equal to 20 km per hour. Next one third and last one third with 60 km per hour. So this V3 is 60 km per hour. The average speed of the bus will be, in this particular case, average speed is going to be, guys, equal distances. Equal distances. When you have equal distances with velocity V1, V2 and V3, in that particular case, you guys will be simply saying this is 3 upon 1 by V1 plus 1 by V2 plus 1 by V3. So this average velocity over here will come out to be 3 upon 1 divided by V1 is 10 plus V2 is 20 plus 1 upon V3 is 60. Oh, is this clear? Oh, is this clear? And this will come out to be 18 km per hour. I hope this is crystalline clear. So basically, there are only two formulas. There are only two. The basic formula is this: total distance divided upon total time taken. If the body covers in equal intervals means in equal time. In that case, V1 plus V2 plus V3 by 3. If the body covers in equal distances, in that case, 3 upon 1 by V1, 1 by V2, 1 by V3. Oh, I hope this is crystal. I hope you are loving this session. I hope you are loving this session. NEET 2023. If a vehicle travels half the distance with V1, see, let's suppose if a vehicle travels half the distance with V1 is equal to V, and remaining half with V2 is equal to 2V, means half of the distance, call this X, half of the distance with V, half of the distance with V2. Now, is this the case of equal distances or equal time? So this is the case of equal distances. And how many intervals are there? Only 2, sir. So in this particular case, V average is going to be 2 upon 1 by V1 plus 1 by V2. 1 by V1 plus 1 by V2. Now you tell me, this will be 2 upon 1 by V1, 1 by V plus 1 by V2, 1 by 2V. Now do the cross, 2 upon 2V plus V, that is 3V upon 2V into V, that is 2V square. Take this in the numerator, this is going to be, this 2 into 2 is 4V square divided by 3V square, and V, this is going to be 4 by 3. Hey, you will kill these questions because I have told you the concept in a very tricky manner, in a very crisp manner. Okay. Is that clear? Let me know in the chats with the fire emojis if this is crystalline clear. Everybody out there. And if you are not like this session yet, I would want you guys to smash the like button. Quick. That's great. Okay. Guys, listen to me very carefully. Let's suppose you are traveling from A point to B point. If I ask you what is the speed of the car from A to B, this is the first question. What is the speed of the car when the car is exactly at this point, at this instant? This is what we call the instantaneous speed. If a person is traveling from Delhi to Mumbai, sir, what's his speed from Delhi to Mumbai? That is average speed in general. Sir, what is the speed when the car is exactly at the toll post? Okay. When the car reached the toll post, what is the speed of the car? At that instant, we say that is called the instantaneous speed. It is the speed at a particular instant. At a particular instant. Okay. Now, guys, see. If I say from A to B, listen to me very carefully. I'm traveling from A to B. Sir, the speed of the car at this instant, at t is equal to 10 seconds. Its speed is how fast it is moving. It is 10 meters per second. Sir, when the car was traveling from A to B at t is equal to 10 seconds, its speed is 10 meters per second towards east. What is the difference between the two? This is what we call instantaneous speed, and this is what we call instantaneous velocity. Because when I mention velocity, this magnitude and direction, it means I'm talking about the velocity. When I say how fast the car is moving at this instant along with the direction, then I'm talking about the velocity. When I say how fast the car is moving at a particular instant, then I'm talking about the speed only. Now take a look. We say if the object is moving from A point to B point, how fast an object is moving at a particular instant. That is instantaneous speed. Now instantaneous velocity. How fast an object is moving at a particular instant along with the direction. So it means velocity, instantaneous velocity. Okay. Or you say it is the rate of change of distance at a particular instant with time. So what I can say, this instantaneous speed is dx by dt. And when I say it is the rate of change of displacement at a particular instant, we say it is dx by dt. Guys. If I say, how do you write average velocity? Sir, it is delta x divided by delta t. Sir, how do you write instantaneous velocity? It is dx divided by dt. It is like, let me just give you the feel. If an object travels from A point to B point, listen carefully. What is the total distance traveled? That is delta x. What is the total time taken? That is delta t. If I say what is the average velocity, you say, sir, total displacement traveled, that is delta x, total time taken, that is delta t. This is average velocity. But if you have to find the velocity at a particular instant here, so at this instant, displacement covered will be very small, and that is dx. At this instant, time will be small, that is dt. So we define at this instant, instantaneous velocity will be this small displacement dx upon small time dt. This is how we do. Okay. So this is large displacement upon large time, small displacement upon small time. Similarly, when you talk about the speed, this is average. In this case, you say delta d, large distance upon large time. When you talk about the speed, instantaneous, it is small distance, that is dd divided by, you can say dt. You can write it like this also. Here I have mentioned dx by dt. Here I have mentioned dx by dt, but I'm putting the vector sign over here. Vector sign means I'm talking about the velocity. Please tell me in the chats if this is crystalline clear. I need the signal. Quick. I need the signal. Quick. Now, guys, an important point. We say direction of motion is decided by the direction of velocity. Direction of motion is decided by the direction of velocity. We said direction of motion is decided by the direction of velocity. See guys, if I say an object is moving towards right, we consider its velocity positive. Velocity is towards right, it means body is moving towards right. If I say this car is moving towards right, consider its velocity positive. Okay. If I say an object is moving towards left, body is moving towards left, we take its negative velocity as negative. Velocity is towards left. So whatever is the direction of motion, that is decided by the direction of velocity. If I say velocity is positive, means body is moving towards right. If I say velocity is negative, body is moving towards left. As simple as that. As simple as that. Okay. Okay. Now guys, one important thing I just want to say over here. What is that? What is that? See. If I say, guys, from this point to this point, body is traveling. There is a car which is traveling from this point to this point. Okay. Yes. Sir, it has some displacement. It has time. So basically, if you want to find the instantaneous velocity, you say, sir, small displacement upon small time. What is this actually? ds by dt. It is the differentiation of displacement with respect to time. It is the differentiation of displacement with respect to time. Means if displacement is given, you are supposed to find velocity, you'll do what? You'll do the differentiation. You'll do differentiation. That's what you guys are supposed to do. Now, take a look. Let's suppose an object travels from A to B. It covers displacement S and time it is taking, let's suppose T. Okay. Now, could you please tell me, how can you find instantaneous velocity? Sir, in velocity at any instant, that is ds by dt. Yes, sir. Cool. Now, I want you guys to take this dt over here. What you will get, ds is equal to v dt. Now, integrate both sides. Do the integration from both sides. What does integration actually mean? Integration means adding the small infinite things. Sir, what is ds? ds means small displacement. Now, if you put integration in front, that means you are adding all the small displacements from A to B. So you'll get the total displacement. Yes, sir, yes. Integration of ds is s is equal to integration of v dt. So what I am trying to say in this particular case, listen carefully. If velocity is given, you are supposed to find displacement. You'll do what? You'll do the integration. If displacement is given, you are supposed to find velocity. You'll do what? Differentiation. You'll do differentiation. Now take a look. If an object is moving from A point to B point, small displacement at any instant is ds. Time is dt. What's instantaneous velocity? ds by dt. If displacement is given, to find velocity, we differentiate. So this. And if you have to find, if velocity is given, to find displacement, we do integration. That I proved. Okay. Let's first take a look. Okay, let's first take a look at this question. Take a look. What I'm trying to say, guys, listen carefully. We say if displacement of the particle is s is equal to t square plus t plus 1, find velocity at t is equal to 2 seconds. This is the displacement of the particle. You are supposed to find velocity at t is equal to 2 seconds. Velocity at t is equal to 2 seconds means instantaneous velocity. So, sir, instantaneous velocity is simply going to be ds by dt. Means differentiation of this. What is differentiation of t square? That is 2t. What is differentiation of t? That is 1. Now you have to find velocity at t is equal to 2 seconds. We say at t is equal to 2 seconds. Velocity is going to be 2 into 2 is 4. 4 plus 1 is 5 meters per second. Yes, sir. Now See the reverse question. If velocity of the object is v is equal to t plus 1, find displacement from 0 to 2 seconds. Now in this case, velocity is given. You are supposed to find displacement, just the reverse. So we say this displacement is integration of v dt. Just a second, guys. Okay. See, in this case, I can say S is equal to integration of v dt. What is velocity? That is t plus 1 and then dt. And because when velocity is given, displacement, you guys are supposed to do the integration. From where to where? From 0 to 2 seconds. This is 0 and this is 2. So displacement in this case will be, now guys, what is the integration of t? It will be t square by 2. Power plus 1 upon power plus 1. Plus, what is the integration of 1? It will be t from 0 to 2. Now put the upper limit minus lower limit. Put this upper limit over here. That is 2 square divided by 2. Minus lower limit is minus 0. Remove that. Plus, put the upper limit in this 2. That is 2. Now 4 by 2 is 2 plus 2 is 4. 4 meters. Is this clear? Is this clear? Oh, tell me in the chats, everybody out there. This is an English channel. We are not supposed to speak in Hindi. हिंदी आता है भाई हमको, लेकिन नहीं बोलना है. अंग्रेजी चैनल है. Great, 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 great. What else can I show you in this one? Okay. Take a look at this. Constant speed. What does constant speed actually mean? When a body covers equal distances in equal intervals of time, that is constant speed. What does that mean? What does that mean? Let's suppose a body travels from A point to B point. Let's suppose in first second, it has covered 2-meter distance. In next second, it has covered 2 meter. In next second, this 1 second, it has covered 2-meter distance. In next 1 second, it has covered 2-meter distance. In next 1 second, it has covered 2-meter distance. This body is covering equal distances in equal intervals of time. Here, velocity of the body is constant. Constant means same. If I say, what was the velocity here? What is the velocity here? What is the velocity here? 2 meter per second. What is the velocity over here? 2 meter per second. What does that mean? Every second it is covering 2 meters. Every second it is covering 2 meters. Every second it is covering 2 meters. 2 meter per second, 2 meter per second. Okay. Okay. Constant velocity means uniform motion. When a body covers equal distances in equal intervals of time without change in direction, it is called constant velocity. It is called constant velocity. Okay, guys, constant speed means when body covers equal distances in equal intervals of time, it doesn't matter whether the direction is same or not. But when you talk about the constant velocity, when body covers equal distances in equal intervals of time without change in direction, like this example is constant velocity also, because here body is not changing the direction. Okay, like here. Body is moving in a circle. Its speed here is 20. Here it is 20, here it is 20. Can I say in this particular case speed is constant? But in this case, velocity is not constant, because velocity is upward, here velocity is backward, here velocity is downward. Okay, because direction is changing. Direction is changing. Okay, take a look. I'll show you something. See, guys, we say, listen carefully. Average velocity, we say total displacement traveled. Okay, total displacement traveled upon total time taken. Yes, this is average velocity. Listen carefully. Let's suppose a body travels from A point to B point. A point to B point. So it has covered a displacement of S. S is the total displacement. How can we find, and its velocity is V. How can we find this? This is integration of V dt. Recently we studied. Displacement is integration of velocity into time. Okay? Yes. And if I say the body has traveled displacement of S from here to here, we can write it like this. And body has traveled a time, it has taken a time t. So we say total time total in this particular case, we can write integration of dt. Sir, why? Because what does integration of dt mean? Integration of dt means integrating the small time intervals. Dt plus dt plus dt plus dt is equal to total time. Now put it over here. So can I say this average velocity in this case will be, instead of this, integration of v dt upon integration of dt. Instead of total time, we can write integration of this. This is another equation. Okay, so this is the average velocity. This average velocity you can find. This average velocity you can find when velocity is given and you guys are supposed to find this average velocity. Like. Let me show you the question on this. Let me show you the question on this. First, see, as v is equal delta x by delta t. Delta x means total displacement. It is integration of v dt. Delta t is integration of dt. Put it over here. Put it over here. You'll get this. Okay, let me show you this question. Take a look. If an object is moving with a speed v is equal to 3t square, an object has a velocity of 3t square, then find the average speed in 2 seconds. To find VAVG in 2 seconds. So velocity is given and you guys are supposed to find the average velocity. So you'll be saying, sir, average velocity will be integration of v dt upon integration of v. So you'll be writing integration of v dt, that is 3t square dt upon integration of dt. Now in what time? In 2 seconds. So this will be 0, this will be 2. This will be 0, this will be 2. Now guys, here it is 3. What is t square? What is the integration of t square? It is going to be t cube divided by 3 upon. What is integration of dt? It is going to be t. So limits are from 0 and this is 2. This and this will cancel. Limits are from 0 and this is 2. Okay. Now guys, t cube, that is 2 cube, that is 8 divided by 2. That will be 4 meters per second. Is this clear? Let's take a look at this pattern of question. Let's take a look at this pattern of question. If the position is, okay, Okay, let's solve this first. If the position of an object is 10t minus 2t square, find the time when object comes to rest. Guys. This is the position of the object, that is 10t minus 2t square. We have to find time. We have to find time when object comes to rest. When object comes to rest means when object has zero velocity. Because what does rest mean? Rest means zero velocity. So here velocity is going to be simply dx divided by dt. That is differentiation of this. What is the differentiation of 10t? That is 10 minus. What is the differentiation of 2t square? That is 4t. So this is the velocity. And put this velocity equal to 0. Because when body comes to rest, its velocity will be 0. So this is going to be 10 minus 4t is equal to 0. Take it over there. 10 will be equals to 4t. So t will be 10 divided by 4. That is 2.5 seconds. So when time is 2.5 seconds, we say body will come to rest. It will have zero velocity. Clear? Oh, tell me. Is it clear? This question. Is this clear? Tell me in the chats, everybody. Now see, if the position of an object is t square minus 4t plus 5, if the position of an object is t square minus 4t plus 5, so x is equal to t square minus 4t plus 5. This is the position of an object. Find the instant when velocity is 0 and displacement when object comes to rest. We said to find the time. Instant means time. To find the time when velocity is 0 and also find displacement. Also find displacement at that time. Now guys, see, this is the position. Could you please tell me what is the velocity? Let's first find velocity. Velocity is going to be dx by dt, differentiation of this position. So that is, what is the differentiation of t square? That is 2t. Minus, what is the differentiation of 4t? That is 4. What is the differentiation of 5? That is 0. Now put this velocity equal to 0. Because we have to find the time when velocity becomes 0. Okay, put this velocity equal to 0. So 2t will be equals to, take this minus 4 over here. So 2 1s are 2 2s are. So t will be equals to 2. So velocity is 0 when time is 2. Velocity is equal to 0 when time t is equal to 2 seconds. Even you can basically check it also. What is the value of velocity? 2t minus 4. Put t is equal to 2. 2 into 2 is 4. 4 minus 4 is 0. Okay. Yes. Now guys, listen to me very carefully. We say velocity is 0 when time is 2. Now you have to find the displacement when object comes to rest. Now find displacement at t is equal to 2 seconds. Because when object comes to rest, that is time t is equal to 2 seconds. Now you have to find the displacement at this one. Now guys, tell me. When it comes to the displacement, listen carefully. It is going to be We say final position minus initial position. So displacement in 2 seconds, we have to say. Okay, we have to find displacement in 2 seconds. Now take this over here. Take this over here. We say at t is equal to 0. Could you please tell me the initial position? Initial position. Okay. So that is going to be 0 minus 4 into 0 plus 5. So initial position in this case is 5. Now, what is the final time when object comes to rest? That is 2 seconds. So at t is equal to 2 seconds, what is going to be the final position? So put t is equal to 2 square is 4. 4 minus 4 into 2 is 8. So that is 4 minus 8 plus 5. Now 5 plus 4 is 9 minus 8 is 1. Now guys, when you say displacement, it is final position minus initial. Final is 1 minus initial is 5. So that is going to be minus 4 meters. Is this clear? Please tell me in the chats. Guys, tell me in the chats if this is crystalline clear. Now, let's suppose you have this question. You have this question. A particle is moving on x-axis such that its coordinate with respect to time change x is equal to t square minus 6t plus 10. Find the velocity at t is equal to 0, t is equal to 6. Now guys, see. Listen to me very carefully. We say position of the particle is given as x is equal to t square minus 6t plus 10. We are supposed to find velocity at t is equal to 0. How do you find? At t is equal to 0 means instantaneous velocity at this instant. Okay. So what I can say in this particular case, that is going to be dx by dt. Differentiation of this. So that is going to be 2t minus 6. Differentiation of t square is 2t. Differentiation of 6t is 6. Now it says at t is equal to 0, t is equal to 3, t is equal to 6. We say at t is equal to 0. If you put t is equal to 0, what is the velocity? Put t is equal to 0. 2 into 0, it is going to be minus 6 meters per second. At t is equal to, we say, how much? 3. What is going to be the velocity? Put t is equal to 2 into 3 is 6. 6 minus 6 is 0. At t is equal to 6, what is going to be the velocity? Put t is equal to 6. 2 into 6 is 12 minus 6 is 6 meters per second. Then it says find average velocity between t is equal to 0 to t is equal to 3. Now guys, take a look. When I say average velocity, that is going to be delta x divided by delta t. What is delta x? Total displacement traveled upon total time taken. How can you write this? This is final displacement, final position minus initial position upon We say final time minus initial. Something like this. Now guys, take a look. What is final position? Listen carefully. Final position when time is 3. At t is equal to 3 seconds, we say final position will be, put t is equal to 3 over here. 3 square is 9, minus 6 into 3 is 18, plus we say 10. So this is 10, 19 minus 18, that is going to be 1. Then we say at t is equal to 0 seconds. What is the initial position? Initial position is, put t is equal to 0 over here. This is 0. This will be also 0. This is going to be 10. Now, put this final position over here. That is 1 minus initial position over here. That is 0 upon, sorry, that is 10. Final time minus initial time. Final time is 3. Initial time is 0. Okay. So this is going to be minus 9 divided by 3. So this is going to be minus 3 meter per second. Is it clear? Oh? Yes. That's great. That's great. Okay. This I'll give you as homework. This I'll give you as homework. This you can do by yourself also. Okay. And okay, take a look at this question. There's an amazing question that I have put up over here. Guys, listen to me very carefully. A particle moves from A to B, B to C, C to D, and D to A. A to B, B to C, C to D, D to A. This is the particle. Now, in this particular case, if the particle moves from A to B, you are supposed to tell me from A to B what is average speed, what is average velocity. Let me just show you. Guys, from A to B, if I talk about average speed, average velocity, let's talk about. Guys, this is radius R, this is radius R, this is radius R, this is radius R. Can I say from A to B, this is the displacement? From A to B, this is the displacement. And recently I told you this is root 2R. If you remember, how can you find this displacement? Guys. If you remember, I have told you over here. This is R, this is R. So displacement between A and B, when theta is 90, that is root 2R. That is root 2R. That is root 2R. So from A to B, total displacement traveled is root 2R upon. What does the question say? A particle is performing uniform circular motion with a constant speed. Uniform circular motion means every second it is covering the same distance. Okay. Having velocity v1, having speed v1, having time period t. Now guys, please listen carefully. Listen. Let's suppose an object travels from this point till this point, then this point, then this point, then this point. Uniform circular motion. If it is taking, let's suppose, time t, we say from here to here it will take time t by 4. If I say it is taking time period of 10 seconds, so this will be 10 by 4, that is 2.5 seconds. In this case also 10 by 4, 2.5 seconds. In this case also 10 by 4. Here also t by 4. T by 4 plus t by 4 plus t by 4 plus t by 4, total time is t. One complete time period. And if you ask me, sir, what is the displacement over here? That is root 2R from this point to this point. If you ask me what is the displacement from this point to this point, this is R, R plus R is 2R. Okay. If you ask me what is the displacement from this point to this point, that is also root 2R. Oh yes, sir. When finally particle reaches over here, what is the displacement? That is 0. Yes, sir. Crystal clear, sir. Now, come here. So, we say from A to B, total displacement traveled is root 2R. Time is how much? T divided by 4. Ah, sir. Take this. So, done. Average velocity. average velocity. R root 2 upon t by 4. When it comes to the average speed, what is average speed? Total distance traveled upon total time taken. So total distance traveled. Now guys, see. Listen carefully. In a circle with radius r, what is the complete circumference? Complete circumference, that is 2 pi r. That is 2 pi r. What is the complete circumference? Let me show you over here. So we say, sir, what is the complete circumference? 2 pi r. So how much will be this from here to here? That is going to be 2 pi r by 2. That is pi r. Oh, sir. Now, how much is going to be this? That is going to be 2 pi r divided by 4. Whatever is divided by 4, yes. So this is 2 pi r divided by 2. Okay. And similarly, when you say, sir, complete till over here, that is 2 pi r. Sir, when you say till over here, how much is this distance? This. That is 3 by 4 into 2 pi r. 3 by 4 into 2 pi r. Now come over here. So while moving from this point to this point, so how much is the distance? Distance is that is 2 pi r divided by 4 from here to here, because complete is 2 pi r. So from here to here, 2 pi r by 4. And how much is the time? That is t by 4. Done. This and this will cancel. So this is 2 pi r divided by t. That is mentioned over here. 2 pi r by 4 divided by t by 4. Oh, yes or no? Yes or no? Yes or no? Let me explain this over here. Let me show you, ladies and gentlemen. See. I'll make you understand. This is a circle. Okay. This point, this is R. If I say this point A, from point A to point B, this is going to be a root 2r. Okay, this displacement from point A to point B, this is r, this is going to be 2r, A to B. Now when the particle reaches here, this is the displacement. This is going to be root 2r. This is the displacement. This is A, B, this is C, this is D. Displacement from AB is root 2r. Displacement from A to C is 2r. Displacement from A to D is root 2r. And displacement from A to A is 0. Now, and time. How much time it is going to take from here to here? That is t by 4. From here to here, that is t by 2. From A to C, it is going to be t by 2, because t by 4 plus t by 4 is t by 2. Now from A to D, this is going to be 3t by 4. So t by 4 plus t by 4 plus t by 4, that is 3t by 4. And this t by 4 plus t by 4 plus t by 4 plus t by 4, here complete time period t. Now guys, take a look. This is point A. When you reach point B, how much is going to be this distance? This distance in this particular case is going to be 2 pi r divided by 4. Distance from A to C till here. This. So this total, this is going to be 2 pi r divided by 2. This and this will cancel, so it will be pi r. Okay. Then from A to C, okay, this is C. So it is going to be 3 by 4 into 2 pi r, 3 by 4 into 2 pi r, something like this. Okay. Then from A to A, here it is going to be 2 pi into r. Please tell me in the chats if this is crystalline clear. Tell me in the chats if this is crystalline clear. Everyone means everyone. Is this crystalline clear? Okay. So I'll mention also over here, this is distance of AB. Okay. This is distance of AC. Okay. Sorry, displacement, and this is displacement of this is AD over here. Oh, I need the signal from every single student. Please, 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 please. Let me know in the chats if this is clear. Whosoever is watching, I need the signal. Whosoever is watching, I need the signal. Now, by using the same logic, you can find, see, you can simply say average speed, total distance traveled upon total time taken. From A to B, B to C, total distance traveled upon total time taken. From A to B, B to C, C to D. You can exactly, this is your homework now. Now you guys will figure out from your end. I'll give you the break exactly at 9 o'clock, okay? So please don't ask in the chats now because we have to finish a lot, I would say. Now, guys, take a look. Listen to me very carefully. Let's suppose I have got a car over here. There is a car, and this car travels from this point to this point, this point to this point. Let's suppose here its speed is 10 meter per second, and here its speed is 20 meter per second. And time is total, let's suppose, from here to here, let's suppose time it is taking 10 seconds. Now, if I ask you from A to B, is the speed of car same or it is changing? What about the velocity of car from A to B? Is it same or is it changing? Tell me in the chats. From A to B, what about the velocity of the car? Is it same or is it changing? So it is changing. So could you please tell me what is the change in velocity in this case? Change in velocity will be final velocity minus initial velocity upon how much is the total time, that is t. So final velocity in this case is 20, initial velocity is 10, total time is 10. So that is going to be 10 divided by 10. This one, what is this one? This one is called acceleration. Sir, means acceleration is change in velocity. Yes. So whenever the velocity of the body change, we say body is accelerating. Whenever the velocity of the body change, body is accelerating. So from A to B, velocity of the body is changing. So means body is accelerating. What is acceleration? Like if you know driving, you know that when we put our foot on the accelerator, the car starts accelerating. The speed of the car starts changing. So whenever the speed of the car change, whenever the velocity of the car change, we say car is accelerating. Hey, accelerate the car. That's how we define acceleration. That is change in velocity. Simply. Okay. Now, if we talk about, it is defined as the rate of change in velocity. Whenever the velocity of the body change, it is accelerating. So acceleration is change in velocity upon change in time. Change in velocity, you can write delta V. Change in time, you can write delta T. Like here, velocity of the car is 10 meter per second. Here, velocity of the car is 20 meter per second. Time is 1 second. If I say how much is the acceleration over here, you say, sir, change in velocity, that is final velocity minus initial velocity. 20 minus 10 divided by 1. So it is 10 meter per second square. Okay. And sir, how do you write the unit of acceleration? Acceleration is velocity upon time. What is the unit of velocity? It is meter per second. What is the velocity unit of time? It is second. So it will be meter per second into second is second square. Okay. How faster the velocity is changing, that is called acceleration. Now, if I say velocity is constant, means velocity is not changing. What is going to be acceleration? In that case, acceleration will be 0. Okay. And SI unit is meter per second square. Simply you remember, acceleration is change in velocity. Let's talk about positive acceleration and negative acceleration. See guys. If acceleration is forward, means acceleration is positive. Sir, if acceleration is forward, does that mean the body is moving in a forward direction along positive x-axis towards right? No, that does not mean that. It does not mean that. Okay. Sir, if velocity is positive, does that mean body is moving towards right? Yes. Because I told you previously, direction of motion is decided by velocity, not acceleration. So if I say acceleration is positive, means acceleration is forward. Like example, here velocity of the car is 10, here velocity of the car is 20. So what will you say? 20 minus 10 divided by time is 1. So this is 10 meter per second square. It is positive 10. So here acceleration does not tell you the direction of motion. Acceleration does not tell you the direction of motion. Even if the car is moving in a backward direction. See guys. Let's suppose car is moving in a backward direction. This is the car. Okay. This is the car. It is moving in a backward direction. Something like this. Okay. Okay. Yes. Like here. Let's suppose velocity of the car, initial velocity here is, okay, that is 20 meter per second. And I would say minus 20. Why? Because it is backward. So here velocity of the car is, let's suppose, final velocity, it is 10 meter per second. Okay, it is minus 10. Could you please tell me acceleration in this case? Final velocity minus initial velocity upon time. Let's suppose time is 1 second. Final velocity is minus 10 minus initial velocity is minus 20 upon time is 1. So minus 10, minus into minus is plus, plus 20 upon 1. So plus 20 minus 10, that is plus 10. So plus 10 meter per second square. In this case, acceleration is positive, but car is moving in a backward direction. That's what I was saying. If acceleration is positive, it does not mean car is moving towards right. It can be moving towards right. It can move towards left. But if I say velocity is positive, it is 100% certain that car is moving towards the right. If I say velocity is negative, it is 100% certain car is moving towards left. Please tell me in the chats if this point is crystalline clear. Everybody out there, tell me, oh, if this is crystalline clear, tell me out. I need the signal in the chats. Is this crystalline clear? Smash the like button if you are not like this session. Everybody out there. Now, negative acceleration. Negative acceleration means acceleration is backward. So does that mean car is moving in a backward direction? Absolutely no. So acceleration is negative. Like example, car is moving with 20 meter per second forward. Here velocity of the car is 10 meter per second forward. Okay. So means velocity of the car is decreasing in this case. So acceleration is final minus initial, that is 10 minus 20. So we say that is minus 10 meter per second square. So here acceleration is negative. So direction of acceleration is backward, but it does not mean car is moving backward. You can clearly see car is moving forward. Retardation. One of the biggest misconceptions, retardation means negative acceleration. Retardation does not mean negative acceleration. First point. Second point, retardation can be positive as well as negative. What does retardation mean then? Retardation means, it simply means slowing down. It simply means slowing down. Like that. What is the velocity of the car here? 20 meter per second. Let's suppose car is applying brakes. So what is going to be the velocity of the car over here? 10 meter per second. It is applying brakes. Now it will move slowly. Okay. Now in this case, time is 1 second. So could you please tell me what is the acceleration over here? Sir, final velocity minus initial velocity. That is 10 minus 20 divided by time is 1. So this is minus 10 meter per second square. So acceleration in this case will be considered as retardation. Why? Because the speed of the car is decreasing, it is slowing down, but it came out to be negative, sir. Yes, it can be negative, it can be positive also. Take a look at this example. This car is moving in a backward direction with minus 20. Now it is applying brakes. Now speed becomes minus 10. Time is 1 second. Now acceleration, here body is slowing down. Now acceleration will be final velocity minus 10, initial velocity minus 20. This is minus into minus is plus. Here acceleration came out to be positive, but this acceleration is considered as retardation. Retardation is simply the slowing down. Whenever the velocity of the body is decreasing, we consider it retardation. It can be positive, it can be negative. Then average acceleration. If a body moves from A point to B point, if I say in general, from A to B, what is the change in velocity? You say delta V. From A to B, what is change in time? You say delta T. So from A to B in general, what is acceleration? That is delta V by delta T. That is called average acceleration. Sir, what is instantaneous acceleration? It is the acceleration at a particular instant. Sir, what is acceleration over here? Like, it is the change in velocity in an interval. It is the change in velocity at a particular instant. Like here, at this instant, what is change in velocity? dv. What is change in time? That is dt. So dv by dt is the instantaneous acceleration. From A to B, whatever is the acceleration, that is average. At a particular instant, whatever is the acceleration, that is instantaneous. Tell me in the chats, is this clear? Is this clear? Or tell me, is this clear? Everybody out there? Chalo. Now, one more important thing, my dear friends. What is that? What is that? Listen carefully. Listen carefully. We say acceleration is simply that is dv by dt. Acceleration at a particular instant is dv by dt. Change in velocity upon change in time. Now, if I say take this over here, what will you get? dv is equal to a dt. Now, integrate both sides. When you do the integration on both sides, integration of small change in velocity, dv is what change in velocity. It will give you large change in velocity, that is delta v is equal. And it is going to give you a dt. Integration of dv, integration of acceleration into t, integration of a dt, it is going to give you change in velocity. Now guys, take a look at this equation. If velocity is given, you are supposed to find acceleration. What will you do? You'll differentiate. And if acceleration is given, you are supposed to find change in velocity. What will you do? You will integrate. One more important thing. What is average? What is average acceleration? Acceleration average. Sir, average acceleration is simply change in velocity upon change in time. What is this change in velocity? That is integration of a dt. Yes, sir. Upon. Sir, what is this? What is this delta t? Total time. We can write it integration of dt also. Yes. Integration of small time is equal to large time. So average acceleration we can write like this also. Integration of a dt upon integration of dt. It is like average velocity which you have recently studied. Integration of v dt upon integration of dt. This. Okay, one more important thing. Acceleration in terms of position. Acceleration in terms of position. I'm showing you all the relations, whatever the relations are there in kinematics. See, if I say what is the acceleration, you say, sir, it is dv by dt. This is acceleration in terms of time. This is the acceleration in terms of time. But I want you guys to multiply with over here dx and divide with dx. That is position. Dx. Now interchange. Take it over here. Take this over here. So this acceleration is going to be dv divided by dx into this dx divided by dt. Now you tell me one thing. What is this dx by dt? Rate of change of displacement with respect to time. It is velocity. So acceleration, instead of this, it is velocity. Then you have dv by dx. This is one more formula of acceleration, that is in terms of position. This is in terms of time. This is in terms of position. I hope this is crystalline clear. This is what is mentioned over here. I have derived all of these. So integration of delta v is equal to integration of a dt is equal to change in velocity. Then acceleration position relation. A is equal to v dv by dx. Then average acceleration, you can write it like this. Integration of a dt upon integration of dt. Please tell me in the chats if this is clear. Please tell me in the chats all of these formulas are clear. Tell me guys, everybody out there. Tell me. Oh, I need the signal from every single student. Whenever teacher says give me the signal, you guys are supposed to do it. Okay, because this gives the indication to the teacher that whosoever is watching, they are understanding each and every single thing, so that the teacher moves forward. That's why. That's great. Now take a look. Let's suppose you have position and you are supposed to find velocity, or displacement, you are supposed to find velocity. What will you do? Sir, you'll do the differentiation. See, dx divided by dt, it will give you velocity. Now if velocity is given, you are supposed to find position or displacement. What will you say? Integration of v dt. Integration of v dt. Reverse. Now if velocity is given, you are supposed to find acceleration. What will you do? Differentiation dv by dt. Now if acceleration is given, you are supposed to find change in velocity. Integration a dt. This slide is very important. Now we have some questions. The question is, the position x of a particle with respect to time is given as this. Okay. This is the position of the particle. That is given over here. X is equal to 9t square minus t cube. What will be the position of this particle when it achieves the maximum speed? Okay, let's find the maximum speed first. Let's find the Vmax. Let's find the maximum speed. Okay, let's find the maximum speed first. Okay, let's find the maximum speed. See, guys, how do we find the velocity? Sir, that is going to be dx by dt, rate of change of displacement with respect to time. Now, guys, what is the differentiation of this? 9 into 2 is, we say, 18t, minus, what is the differentiation of t cube? That is 3t square. Now, guys, this is the velocity. We know that if you want to find the maximum value of any quantity, if you want to find the maximum value of any quantity, its differentiation will be 0. We say velocity is maximum when dv divided by dt is 0. If you remember, in maxima and minima concept, I have told you, if we have quantity y, if you want to find its maximum or minimum value, if you want to find its maximum or minimum value, we say its maximum value will be and minimum value will be when dy by dx will be 0, when its differentiation is 0. This is the concept of maximum and minimum. So if you have velocity, if you want to find its maximum value or minimum value, you find its dv by dt and put it equal to 0. Now do the differentiation. So dv divided by dt is going to be, now what is the differentiation of 18t? That is 18 minus, for 3t square, 2 into 3 is 6t. Put it equal to 0. Now take it equal, 18 is equal to 60. 6 ones are, 6 threes are. So t in this case is 3 seconds. So t in this case is 3 seconds. Okay. Now, my dear friends, at t is equal to 3 seconds, we say velocity is either maximum or minimum, because we know dv by dt will be 0 when this velocity is maxima or minima. This is the concept. Now, if you have not studied maxima and minima, sir, please leave this question. That's what I can recommend right now. Now tell me one thing. How do you figure out if a quantity is maximum or minimum? You find double differentiation. d2v divided by dt square. If double differentiation came out to be negative, then it is maxima. If double differentiation came out to be positive, then it is minima. What I'm trying to say is that if you have not studied maxima and minima concept with me in basic mathematics, then I would recommend you to leave this question. So double differentiation of this, it is going to, for 18. Now do the differentiation once again for this. For 18 it is 0 and for 60 it is minus 6. So it is negative. So it is negative means, so velocity is maximum. So at t is equal to 3 seconds, velocity is maximum at t is equal to 3 seconds. So at t is equal to 3 seconds, velocity is maximum. Now you have to find what will be the position of the particle when it achieves maximum speed. It achieves maximum speed at t is equal to 3. Now you have to tell me position of the particle. So at t is equal to 3 seconds, let's talk about the position. Guys, x is equal to 9 into t square. Instead of, I will write 3 square minus, I would write 3 cube. Now tell me, 3 into 3 is 9. 9 into 9 is 81. Minus, this is 3 into 3 is, this is 27. So yes or no? Is this clear? Oh? Tell me in the chats, everybody out there. Is this clear? Everybody out there? Tell me. And this is 54 meters. You have to tell me the position at t is equal to 3 seconds. At t is equal to 3 seconds, it's 54 meters. See. I'll explain once again. What is the position? X is equal to 90 square minus t cube. 90 square minus t cube. This is the position. You have to tell me the position. You have to tell me the value of x when velocity is maximum. This is the question. You have to tell me the value of x when velocity is maximum. Let's find velocity is maximum. First find velocity. That is dx by dt. 9 twos are 18t minus 3t square. Now this is the velocity. We know this velocity will be maximum. This velocity will be maximum. Or we say minimum. When? Its differentiation dv by dt is equal to 0. When its differentiation is 0. Yes, sir. Now its differentiation. Find its differentiation dv divided by dt. That is, for 18t it will be 18 minus. For 3t square, that is going to be 60. And put it equal to 0. Now take it over here. 18 will be equals to 60. 6 ones are, 6 threes are. So t is equal to 3 seconds. So at t is equal to 3 seconds, dv by dt is actually 0. Yes. So at t is equal to 3 seconds, velocity is either maxima or minima. Now you have to find out, is it maxima or minima? You do double differentiation. d2v divided by dt square. When you do double differentiation for this, it's double differentiation. For 18 it is 0. For minus 60 it is minus 6. So it came out to be negative. So it is maxima. Because if double differentiation comes out to be negative, then the quantity is maximum. Okay. Now, at t is equal to 3, velocity is maximum for sure. Now at t is equal to 3, let's find the value of position. So this is the position, that is 9t square minus t cube. Put t is equal to 3 over here. 9 into 3 square minus 3 cube. So this is going to be 81 minus 54 minus 27. That is going to be 54. Oh, tell me, oh, is this clear? Is this clear? Is this clear? I need the signal in the chats. I need the signal in the chats, everybody out there. let's talk about this. If initial velocity of a particle, if initial velocity of a particle is u at t is equal to 0, and acceleration is given by, acceleration of the particle is alpha t raised power 3 by 2. Which of the following relation is valid? Okay, which of the following relation is valid? In the relation, if you check over here, what is given? Velocity, 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 velocity. Means we are supposed to find velocity. And what is given? Acceleration. Oh, sir. Guys, tell me. When acceleration is given, you are supposed to find velocity or change in velocity. Will you prefer to do integration or differentiation? Sir, obviously integration. Obviously integration. So what I can say over here as delta V is equal to integration of A dt. As simple as that. As simple as that. So this delta V is equal to integration of A. So this is alpha t raised power 3 by 2 into dt. Okay, now it is from 0 to t, because it says if the initial position of the particle is u at t is equal to 0, then the acceleration is given by alpha t raised power 3 by 2. Which of the following relation is valid? Now what is this? This is final velocity minus initial velocity. Delta u means final minus initial, v minus u, is equal to, take this alpha out, then integration of t raised power 3 by 2 and then dt. Now tell me, this is v minus u is equal to alpha, integration of 3 by 2. Guys, this is t raised power 3 by 2 plus 1 upon t by 2 plus 1, because integration means power plus 1 upon power plus 1. So this is v minus u is equal to, so alpha t raised power 5 by 2 upon 5 by 2. You can write it like this also. This is v minus u is equal to, this you can take in the numerator, 2 by 5, then alpha t raised power 5 by 2. Then v will be equals to, take u over here, u plus 2 by 5 alpha t raised power 5 by 2. Which option is matching? I think option this is matching. Yes, option C. Option C. And simply, guys, when acceleration is given, it says which of the relation is matching. You see in the relation velocity, you guys are supposed to find out. So obviously you'll use this equation. Na? If the concepts are clear, you'll smash all of these questions. You'll smash all of these questions. Now see, the acceleration of a particle is increasing linearly with time as bt. This is the acceleration of the particle. Okay. The particle starts from the origin with an initial velocity v0, means at t is equal to 0, initial velocity is v0, v initial is v0. The distance traveled by the particle in time t is, we are supposed to find what is the displacement traveled. Tell me, what kind of logic you guys can use over here? What kind of logic you guys can use over here? See. Sir, acceleration is given. You have to find displacement. This is displacement. So before acceleration, you can find velocity. So then from velocity, you can find displacement. From acceleration, you can find velocity. From velocity, you can find position displacement. I hope every single thing is crystal and clear. Oh, tell me, now tell me, we say as. Can I say delta V is equal to integration of A dt? First find velocity, then we'll find displacement. So we say delta V will be equals to integration of, what is the acceleration? That is B into T, and then we say dt. Now guys, this is final velocity minus initial velocity. Okay, or you can say v minus u. Now tell me, this b is constant, take it out. Integration of t, it is t square divided by 2. T square by 2. Okay. Now guys, this initial velocity vi, or you can say initial velocity u, it is given as v0. So put it over here. This is final velocity. Okay. Or you can say this is v minus, this is v0 is equal to bt square divided by 2. Now take it over there. V will be equals to plus v naught plus bt square divided by 2. Now you got velocity. Now if velocity you got, you are supposed to find displacement. How can you find displacement? Integration of v dt. As simple as that. Now guys, S is equal to integration of v dt. What is the value of velocity? That is v naught plus bt square divided by 2 into dt. Now tell me, I can write over here, what is the integration of v naught? If I say what is the integration of 4, you say sir 4t. Integration of 5, it is 5t. What is the integration of v naught? It is v naught into t plus. What is the integration of this b divided by 2? What is the integration of t square? It is t cube divided by 3. So this displacement will be v naught into t plus 3 into 2 is 6, 1 by 6 bt raised power 3. This is the answer to the question. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Everybody out there. Tell me, oh, and what is the logic we used over here? Okay, from acceleration we calculated velocity. From velocity we calculated displacement. Let's take a look at this. If the velocity of a particle is v is equal to at plus bt square, okay, velocity of the particle is given as at plus bt square, where a and b are constants. The distance traveled by it between 1 and 2 seconds is, guys, velocity is given to find distance traveled. Now tell me, oh, can I not say integration of v dt? This will help us to find the displacement. Yes or no? Yes. So we are supposed to find distance, integration of v. What is the velocity? That is at plus we say bt square, and then we say dt. Limits are from 1 to 2. 1 to 2 seconds. So can I say over here this displacement will be, what is the integration of at? So it is going to be at square by 2 plus, what is the integration of bt? It is going to be bt cube divided by 3, and limit in this case is from 1 to 2. So this displacement will be, put the upper limit minus lower limit. So this is going to be a divided by 2. Now in this t you will be putting the upper limit, that is 2 square minus 1 plus. Then here b divided by 3 common. In this t you will be putting the upper limit, that is 2 cube minus 1. Now this displacement will be 2 square is 4, 4 minus 1 is 3, 3a divided by 2 plus 2 cube is 8, 8 minus 1 is 7, 7b divided by 3. This is the answer. Now is this clear? Please tell me in the chats, everybody out there. Now, guys, let's take a look. See. Let me just tell you something. See. Guys. Take a look. We studied velocity. Listen carefully. We studied velocity is equal to ds by dt. Change in displacement upon change in time, or dx by dt. We studied acceleration is equal to dv by dt. Yes. We studied displacement is equal to integration of v dt. We studied change in velocity is equal to integration of a dt. We studied acceleration is equal to v dv divided by dx. Yes. Sir, we also studied this. Average velocity is equal to integration of v dt upon integration of dt. We also studied, sir, average acceleration. It is integration of a dt upon integration of dt. Okay. These equations. Now, guys, we say these are the equations that you can use even if the acceleration is not constant. Sir, what does constant acceleration mean? If I say acceleration is constant, what does that mean? Acceleration is, if I say 10 meter per second square, it will remain 10 only. It cannot be 11. It cannot be 11. Sir, if I say acceleration is a is equal to t square, is it constant or variable? It is variable. Why? Because acceleration depends upon time. When t is 1, acceleration is 1. When t is 2, acceleration is 4. When t is 3, acceleration is 3 square is 9. When t is 4, acceleration is 16. Acceleration is changing. So constant means when acceleration remains the same. Like. Take a look. Please. Take a look in this question. Acceleration is variable or constant? Variable. Then you use this equation to find the velocity. See. You use delta v is equal to integration a dt. In this question, acceleration is constant or variable? Variable. You use the equation over here to find the velocity and displacement. Yes. So means I'll write over here all these equations can be used when acceleration is either constant or variable. Doesn't matter. These are the equations you can use even if the acceleration is constant or variable. Doesn't matter. Now, if I say acceleration of the body is constant, see. Sir, a car started from this point. There is a car which started from this point. Initial velocity is u. And this car is traveling from this point to this point. Here, final velocity is you guys are supposed to find out. And here time is 0, here time is t. And in this case, we say acceleration is constant. Acceleration is constant. Means acceleration, if I say 10, it will remain 10 meter per second square only. It will not change. Sir, is there any equation I can use to find the velocity here? We say v is equal to u plus a. Okay. Sir, in this case, acceleration is constant means then only I can use this. Yes. If acceleration is variable, can I use this equation to find the velocity? No. Sir, in that case, you can use this equation to find velocity. You can use this equation to find velocity. So this is only used, only valid. I'll mention over here, only valid when acceleration is constant. So these equations can be used even if the acceleration is constant or variable, doesn't matter. They can be used to find the answer. Okay, yes. So this is the equation by which you can find velocity of this car after time t. V is equal to u plus at. U is the initial velocity, a is the acceleration, t is the time. Now if I say this car, it is having initial velocity u. At time t is equal to 0, it is here. Now it is traveling from this point to this point. It is taking time t. Acceleration is constant. If I say what is the displacement covered by the car after time t? How much is the displacement You say displacement is ut plus 1 by 2 at square. Sir, can I use this if acceleration is variable? No. This is only used if acceleration is constant. Ut plus 1 by 2 at square. Next. Sir, car started from this point. After covering displacement s, the car reached this point. So acceleration is constant. If I say what is the velocity of this car after displacement s? Sir, what is the difference between this and this? This is the velocity of the car after time t. After this time t. Sir, after 10 seconds, how much is the velocity? V is equal to u plus at. Sir, after 10 meters, how much is the velocity? So that is v square minus u square is equal to as. This is the third equation of motion. Okay. Next. V is equal to u plus at. That can be used to find the velocity of the car after time t. S is equal to ut plus 1 by 2 at square. That can be used to find the displacement of the car after time t. V square minus u square is equal to as. That can be used to find the velocity of the car after displacement s. Displacement in nth second. Let's suppose the car started from this point and it reached this point. So after t is equal to 1 second, car is here. After t is equal to 2 seconds, car is here. After t is equal to 3 seconds, car is here. After t is equal to 4 seconds, car is here. 5 seconds, car is here. After t is equal to n seconds, car is here. If I say what is the displacement in nth second means this. See. This is the displacement in first second. This is the displacement in second. This is the displacement in third second, fourth second, fifth second, nth second. So this displacement is u plus a by 2 to n minus 1. U is the initial velocity, a is acceleration, n is the second. Let's suppose we have to find the displacement in third second, this displacement. You'll be putting n is equal to 3. So u plus a by 2, 2n, 2 into 3 minus 1, 6 minus 1, that is 5. So 5a by 2. Oh, yes or no? And sir, what is this equation? What is this equation? This equation tells you displacement, total displacement in time t. Total displacement in time. Total displacement in time. Okay. Now, guys, average velocity when acceleration is constant. Average velocity when acceleration is constant. Now, if I say there is a car, its initial velocity is u, final velocity is v. What is the and acceleration is constant? It is like this. A car started from this point with initial velocity u, then it has traveled, it reached this point. Here final velocity is v and acceleration is constant. In this case, average velocity will be u plus v divided by 2. Okay. And if you ask me, what is the displacement covered during this? What is the displacement covered during this? You'll say, sir, displacement is velocity into time, average velocity into time. That is u plus v by 2 into t, because average velocity is u plus v by 2 into t. I hope this is crystal and clear. Midpoint velocity. Let's suppose there is a car which started from this point and the car reached this point. Here initial velocity is u, here final velocity is v, and displacement it is covering s. What is the velocity at this midpoint? In this case also acceleration is constant. So you'll be saying midpoint velocity is, we say under root of v square plus u square divided by 2. Now I would want you guys to tell me in the chats if all of these equations are crystalline clear. Tell me guys quickly in the chats, everybody, if all of these equations are crystalline clear. Is this clear? That's great. Smash the like button, guys, if you are not liked this session yet. Let's talk about this question. A particle moves in a straight line with a constant acceleration. See, acceleration is constant. It changes its velocity from 10 meter to 20 meter per second. Now, guys, see, a particle moves in a straight line. Its velocity here is 10 meter per second, and velocity here is 20 meter per second. Initial velocity is 10, final velocity is 20. While passing a distance of 135 meters, this distance is 135 meters. In time t. So this time t, we are supposed to find the value of time t is. Okay, now tell me, guys, don't you think displacement covered with this velocity, we can use this particular equation? We say as s is equal to u plus v divided by 2 into t. Now take it over here. This will be 2 into s upon u plus v. Take this u plus, and it is going to be t. Oh, yes or no? Is this clear? Now time is going to be 2 into 135 divided by 10 plus 20. Is this clear? Tell me. Yes, that's great. 9. So it is going to be 9 seconds. It is going to be 9 seconds. Let's take a look at this. A body moving with some initial velocity having a uniform acceleration. Having a uniform acceleration means in this case acceleration is constant. Okay. Attains a final velocity v. So there is a body which is moving. It has constant acceleration and it attains the velocity v, traveling x meters if the final velocity v is equal to this. So final velocity is given as under root of 180 minus 7x. This is the velocity. Find the acceleration of the body. We have to find the acceleration. Okay. Yes. So there is a body, there is a car which is moving with constant acceleration, and this is the velocity. Now take this root over here. It will become v square is equal to 180 minus 7x. Now guys, what I want you guys to do it, if acceleration is constant, can we use the equation v square minus u square is equal to as? Yes, sir. Because that is used when acceleration is constant. So we say compare with. We say v square is equal to u square plus 2ax. You can write it like this, or v square minus u square is equal to ax. Yes, sir. Now here. Take a look. You have got v square, you have got v square. And this is 180, this is 180. This is 180. In this case, you have got 180, you have got u square. Here you have x, you have x. Here you have 2a, here you have minus 7. So can I say in this particular case, we say here, I can say this 2a will be equals to minus 7. Yes. Sir, why did you use this equation over here? Because it says acceleration is constant. So what I can say, acceleration will be minus 7 by 2. That is minus 3.5 meter per second square. How many of you understood this? Please tell me in the chats. How many of you understood this? Please tell me in the chats. Everybody out there, give me the signal in the chats if you understood this question. Tell me, guys. Tell me, guys. Great, great. An object starts from rest with constant acceleration. There is an object which started from rest. Initial velocity is 0 with constant acceleration. Acceleration is constant. What does it say? It moves 80 meters in 6 seconds. So it has covered a displacement of 80 meters and time is 6 seconds. So it is moving at displacement of 80 meters in 6 seconds. Okay, cool. Let's do one thing. Ignore this part. Let's first find acceleration using this. Can I say use S is equal to ut plus 1 by 2 at square. I can use this equation. Okay. Now guys, how much is the displacement over here? 80 is equal. Initial velocity is 0. So this term will become 0. 1 by 2 acceleration. Time it is saying 6 square. 6 square. That is 36. So this is 80 is equal to 36 divided by 2. That is 18. 18a. So acceleration came out to be 80 divided by 18 meter per second square. Yes. Then what does it say? Find the displacement in 12 seconds. So with the help of this, we got acceleration. Now it says that we have to find displacement in 12 seconds. Don't you think it is easy now? Guys, again use S is equal to ut plus 1 by 2 at square. Because it says the same car, which is covering the distance of 80 meters in 6 seconds. By using this data, we got the acceleration. Then it says the same car will cover how much displacement in 12 seconds. So this displacement is initial velocity is 0, 1 by 2. Acceleration is 80 by 18. Okay, 80 by 18 into t square. And time is 12 square. 12 into 12. Oh, yes or no? Is this clear? So 2 ones are 2, 6 are 12. 6 ones are 6, 3s are 18. 3 ones are 3, 4s are 12. So 4 into 0 is 0. This is 4 into 8 is 32. So displacement is ho 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 ho. Tell me, oh. Is it clear? Oh, tell me in the chats, please. Everybody. Whosoever is watching, please tell me in the chats if this is crystal and clear. Whosoever is watching, tell me in the chats if this is crystal and clear. Tell me. We'll take the break exactly at 9 o'clock. Take a look at this. Now guys, see. Ratio of displacement in 1 second, 2 second, and 3 second. Listen carefully. Listen carefully. Listen carefully. Let's suppose if I say I have got a car over here. This car is moving from this point to this point. This car is moving from this point to this point. At t is equal to 0 here, at t is equal to 1 second it's here, t is equal to 2 seconds here, t is equal to 3 seconds it's here, t is equal to 4 seconds it's here, t is equal to 5 seconds it's here. Okay. If I say how much is this displacement covered in 1 second, you say sir displacement covered in 1 second is ut plus 1 by 2 at square. Initial velocity is 0, acceleration is constant. This is the condition. Sir, initial velocity is 0, so this will be 0. So displacement in 1 second will be 1 by 2 acceleration. Time is 1 square because we have to find displacement in 1 second. So this will be a divided by 2. Consider this x. Yes, sir. Yes. Now. Then, if I say what is the displacement in 2 seconds, this S2, this is S1. From here to here, how much the displacement in 2 seconds? You said displacement in 2 seconds is same equation, ut plus 1 by 2 at square. Initial velocity is 0. It is going to be 1 by 2 a. T is 2 square. So can I not write 2 square is 4. 4a by 2. So what is a by 2? X. So this will be 4x. Displacement in 2 seconds is 4x. Cool. So if I say what is the displacement in 3 seconds, means from here to here, S3. Sir, it is simple. 1 by 2 at square. Now ut will be cancelled. Why? Because initial velocity is 0. So this is 1 by 2. Acceleration is a only. T is 3 square. Because time is 3 seconds. That is 9. So 9a by 2. What is a by 2? That is x. So this is 9x. So this distance is x. Okay. This distance is 4x. This distance is 9x. Similarly, 4 square is 16. So this distance S4 will be 16x. This distance S5 will be 25x. Oh, sir. So can I not say, my dear friends, if an object has initial velocity 0, acceleration constant, what is the displacement covered in first 1 second? That is x. What is the displacement covered in 2 seconds? That is 4x. What is the displacement covered in 3 seconds? That is 9x. What is the displacement covered in 4 seconds? 16x. 5 seconds, 25x. Here is the logic that I have used. And my dear NEET aspirants, can I not say displacement in 1 second is to displacement in 2 seconds, is to displacement in 3 seconds, is to 4 seconds, is x is to 4x, is to 9x, is to 6x, is to 25x. Is this clear? Tell me in the chats, is this clear? Is this clear? Tell me in the chats. Tell me in the chats. That's great. That's great. Now, guys, see. If this distance is x, this distance is 4x. Could you please tell me how much is this? Sir, total is 4. This is x. So 4 minus x, 4x minus x is 3x. This will be 3x. What is this? Sir, this is 9x. This is 4x. So this will be how much? 5x. Okay. This is 16x. This is 9x. So this will be 16 minus 9, 7x. This will be 9x. This is what we call ratio of displacement in first second, second second, third second, fourth second. Now see. Sir, displacement in first second, this one. Displacement in second second, this one. Displacement in third second, this one. Displacement in fourth second, this one. Displacement in fifth second, this one. So what is the difference between this ratio and the previous ratio? This is the total displacement in 1 second, total displacement in 2 seconds, total displacement in 3 seconds, total displacement in 4 seconds. But here, displacement in first second, displacement in second second, displacement in third second, fourth second, fifth second, x, 3x, 5x, 7x, 9x. Even you can use the formula also. How to find displacement in nth second? U plus a by 2 into 2n minus 1. For this, what is the value of n? That is 1. What is the value of n? That is 1. Put 1 over here. A divided by 2, 2 into 1 minus 1. So 2 minus 1, that is 1. So this will be 1. So a by 2, it will be x. Okay. Let's suppose, see. If I say displacement in second second, what can I use? S is equal to u plus a by 2 into 2n minus 1. For second second, I need to find the displacement. U is initial velocity is 0. A divided by 2. 2 into 2. Value of n is 2. So 4 minus 1. So this is going to be 4 minus 1 is 3. A by 2. What is a by 2? That is x. So that is 3x. So similarly, you can get this 5x also. So what I want you guys to remember directly, ignore this. You can directly remember this displacement in first second, displacement in second second, displacement in third second, displacement in fourth second, x, 3x, 5x, 7x, 9x. This is only valid when initial velocity is 0, acceleration is constant. Otherwise, it is not valid. Displacement in first second, second second, third second, fourth second, x, 3x, 5x, 7x, 9x. NEET 2015. See. A particle starts from rest. Initial velocity is 0. Under the action of constant force, when force is constant, we say acceleration is constant. If the distance covered in the first 10 seconds, take a look. Particle started from this point. Okay. If the distance covered in first 10 seconds means here it is 0 seconds, it is 10 seconds, is S1. This is S1. And in the first 20 seconds means here it is 20 seconds. Guys. In first 10 seconds, this is the displacement S1. In first 20 seconds, first 20 means, sir, from here to here. That means this displacement is S2. We are supposed to find what is the value of S1 divided by S2. We are supposed to find what is the value of S1 by S2. Take a look. See, if I say, sir, an object has initial velocity 0, acceleration constant. After 1 second it is here, after 2 seconds it's here, after 3 seconds it's here, 4 seconds it's here, 5 seconds it's here. Okay, and everybody knows that, sir, from here to here this is x, from here to here this is 4x, from here to here this is 9x, from here to here this is 16x, and so on, 25x. And everybody knows that this, sir, this is x, and this is 3x, this one is 5x, this one is 7x, this one is 9x, and so on. Everybody knows this. Now guys, this statement is true even if you put over here 1 second, or if you put over here, this is 10 seconds, here 20 seconds, here 30 seconds, here 40 seconds, here 50 seconds, then also it is true. Because it is one and the same thing. Gap is same. Gap is same. If I say 100 seconds, 200 seconds, 300 seconds, 400 seconds, 500 seconds, then also it is same. How many of you understood this? Please tell me in the chats. How many of you understood this? Please tell me in the chats. Tell me, everybody out there. That's great. That's great. Now, guys, take a look. See, see. Now tell me, what is the value of S1 by S2? Even if it is 10 seconds, 20 seconds. So clearly I can say S1 divided by S2, it will be X divided by 4X. So this and this will cancel. It is 1:4. So you can say S1 will be, or simply you can say multiply this over here. So 4 times of S1 will be equals to S2. You can say it like this also. Take a look at this. A body starts its journey from rest with a constant acceleration. Okay. So means in this particular case, initial velocity is 0, acceleration is constant. And guys, see, NEET 2017. It moves a distance S1, S2, S3 in first, second, and third. Now, guys, see. So in 2 seconds, 3 seconds. In first second, it moves S1. In second S2. In third second, S3. Now, clearly in this particular case, we can say S1 is to S2 is to S3. It is going to be X is to 3X is to, we say, 5X. Because displacement in first, second, third second. Yes. Now, which of the following options is correct? See. Let's do one thing. Let's divide first and second. So S1 divided by S2. So this is going to be X divided by 3X. This and this will cancel. Take it over there. So S1 will be equals to S2 divided by 3. Call this equation first. Now divide S1 and S3. S1 divided by S3. This is going to be X divided by 5X. This and this will cancel. So here S1 will come out to be S3 divided by 5. Call this equation second. Now, in this particular case, can I say from first and second, this S1 will be equals to S2 divided by 3. Okay. And this S1 is also equal to, that is S3 divided by 5. See, how many of you understood this? Please tell me in the chats. Everybody out there. We have finished, I would say, 70% of kinematics 1D. %. Okay, let me explain once again. Tell me, I hope this ratio is clear. Displacement in first second is S1. Displacement in second is S2. Displacement in third second is S3. Yes. Now, first, second, third second displacement is x is to 3x is to 5x. It is not displacement in 1 second, 2 seconds, 3 seconds. No. Now, if I say divide first and second, you say S1 divided by S2. It will be, sir, S1 by S2 means x is to 3x. X divided by 3x. Because S1 is x, S2 is 3x. So, this and this will cancel. So, this is S1 divided by S2 is equal to 1 by 3. Take this over here. So S1 will be S2 divided by 3. Call this equation first. Then I am saying divide S1 and S3. S1 and S3. What is S1? That is x. What is S3? That is 5x. This and this will cancel. Take it over there. So S1 is equal to S3 divided by 5. Call this equation second. Now see, S1 is equal to this also. S1 is equal to this also. So can I say from first and second, S1 is equal to S2 by 3. S1 is equal to S2 by 3, which is further equal to this S1 is equal to this also. It is equal to this also. So you can say S3 divided by 5 also. Now I hope this is clear. Now I hope this is clear. Stopping distance. What does stopping distance actually mean? What does stopping distance actually mean? Let's suppose there is a car over here. Okay. This car is moving with initial velocity. Car is moving with some velocity. Then you apply the brakes. Do you think that when you apply the brakes, the car stops immediately, or it stops after covering some distance, a little bit of distance? Tell me. Does the car stop immediately, or it stops after covering some distance? Does the car stop immediately, or it stops after covering some distance? Sir, it stops after covering some distance. That distance is what we call the stopping distance. A car moves with some velocity. After applying brakes, it will stop covering some distance called stopping distance. Okay. And this stopping distance, directly you can remember, this stopping distance is u square by 2a. U is the initial velocity it is moving. Here it is derived. And divided by 2a, a is the acceleration. A is the acceleration. You can use this equation. V square minus u square is equal to as. Final velocity, because finally it stops. That is 0 minus u square is equal to minus 2as. Why minus? Because acceleration here will be negative. It is stopping. Negative, negative cancel. So acceleration will be u square by 2a. Directly, that stopping distance is u square by 2a. Now see the question. See the question. The question says, a car moves with a speed of 40 km per hour. There is a car we have. It moves with a speed, let's suppose it is 40 km per hour. Can be stopped by applying brakes after at least 2 meters. This car can be stopped after applying brakes, means its stopping distance is 2 meters. When you apply brakes on this car, it will stop after 2 meters. Stopping distance is 2 meters. If the same car moving with a speed of 20 km per hour, if the same car moving with a speed of 20 km per hour, okay, the same car is moving with a speed of 20 km per hour, what is the minimum stopping distance? What is going to be the stopping distance in this case? S2 we are supposed to find. Now tell me guys, we say stopping distance is u square divided by 2a. Okay. We say acceleration is constant, 2 is constant. So can I not say stopping distance is proportional to u square? Yes. So can I say S1 divided by S2? S is proportional to u square. So S1 will be proportional to u1 square. S2 will be proportional to u2 square. Yes, sir. Now see. So this S1 over here that is S1 is 2 meters upon S2, it will be U1 by U2 whole square. U1 is 40 divided by U2 is 20, its whole square. 0 and 0, 2 ones are 2, 2s are 4. Now 2 square is 4. 2 divided by S2 will be 2 square is 4. Now take it over there. So S2 will come out to be 2 divided by 4. That is 1 by 2. That is 0.5 meters. Is this question clear? Is this question clear? Is this question clear? Is this question clear? Now you have rest to rest motion. Now you have rest to rest motion. Rest to rest motion. What does rest to rest motion mean? See, let's suppose you have a car over here. Its initial velocity is how much? 0. Okay, it started from rest. And then this car started accelerating with alpha. It has acceleration alpha for time t1. So from here to here, it has acceleration alpha. An object starts from rest. I'm telling you each and every single thing in a crisp manner. An object starts from rest with a constant acceleration alpha. Object starts from rest with a constant acceleration alpha for time t1. Its acceleration is for time t1. And then retards. Then its acceleration, okay? Then it achieves the maximum speed. Maximum speed. Car starts from rest, accelerating, achieves the maximum speed. Then it retards. Retards means it is slowing down. Retardation means slowing down. Okay, then speed is decreasing. Then it retards with beta. Then from here to here, it is retarding with beta. And then stops. Final velocity 0. See, car is at rest. Increasing speed, maximum. Acceleration is alpha when it achieves maximum speed. Then speed decreases, and becomes 0. Retardation is beta. Okay. For time t2. In this case, they will ask you to find the total displacement traveled in this journey. And what is the maximum speed achieved? What is the maximum speed achieved? They'll ask you these two questions. First of all, you'll say, sir, maximum velocity will be alpha into beta upon alpha plus beta into t. Alpha is the acceleration from here to here. Beta is the retardation from here to here. T is the total time, that is t1 plus t2. And displacement from here to here, you can say Vmax square by 2 into alpha plus beta divided by alpha into beta. Or you can write this as this something like this: displacement 1 by 2 alpha beta plus upon alpha plus beta into t square. Because when you put the value of Vmax over here, so you'll get this equation. This is the displacement. Let's take a look at the question. See, a body starts from rest with an acceleration of 2 meter per second square. There is a body. See. Initial velocity is 0. It starts from rest with an acceleration of 2 meter per second square. Okay. And it attains the maximum velocity. Here velocity is maximum. Then it retards. So means then its acceleration retardation is 3 meter per second square. Okay. And final velocity comes to 0. Its total time is 10 seconds in this journey. Then Vmax is, in this particular case, they are asking you to tell me the Vmax, rest to rest. Alpha beta upon alpha plus beta into t. So we'll be saying alpha beta upon alpha plus beta into we say t. Now tell me what is the value of alpha? That is 2 into 3 upon 2 plus 3 into we say 10. 2 into 3 is 6. So 6 divided by 5 into 10. So 5 ones are 5 twos are 2 6 are we say sir 12 meter per second. Even if they ask you to find the displacement also in this particular case, what will you say? Sir, displacement will be 1 by 2 alpha beta alpha plus beta upon alpha beta into we say t square. Okay, alpha beta upon alpha plus beta into we say t square. So displacement will be 1 by 2 alpha into beta. So that is 2 into 3, that is 6. 2 plus 3, that is 5 into t square, that is 10 square is 100. Okay, 2 ones are 2, 3s are 6, 5 ones are 5, 20s are. Now displacement is 3 into 20 is, we say sir, 60 meters. Oh, is this clear? Oh, tell me in the chats, everybody out there. Is this clear? I need the signal in the chats. Everybody. Great. Now, guys, let's take a look. Let's take a look. See, let's suppose there is an object over here. Okay, its mass is m. Okay, there's an object over here, its mass is m. If I release this object, what is going to happen? You say it will fall down. Why it will fall down? Because, sir, in the downward direction, there is a force that is acting, that is called mg. That is called mg. Okay, everybody knows that. If you have an object of mass m, if you release it, it will fall down. Due to what? Due to mg. Say force is mg. Now, if I say, and this, what kind of motion is this? This is what we call motion under gravity. Sir, why do you call motion under gravity? Because this is the motion under gravity. Due to the gravity, it is falling. So that's what we call motion under gravity. And everybody knows that. Listen, everybody knows that. We say, sir, force is equal to mass into acceleration. This is a basic formula. Everybody knows that. So from here, acceleration will be equals to force divided by mass. Let's find the acceleration of this. You say acceleration is, what is the force? That is mg. What is mass? That is m. M and m will cancel. So acceleration will come out to be g. And this g is what we call acceleration due to gravity. So this is the acceleration of this mass, which came out to be due to this gravitational force. That's why we call this acceleration due to gravity. And value of this g is 9.8 meter per second square. So from now onwards, my dear friends, you'll remember one thing. If you have an object, if you release it, it will fall down due to this gravitational force, and it will achieve a gravitation, it will achieve an acceleration of 9.8 meter per second square. If somebody says from now onwards, if I release this, it will fall down, what will be its acceleration? To say 9.8 meter per second square. That is acceleration due to gravity. And this concept is what we call motion under gravity. This concept is what we call motion under gravity. Okay, like it is mentioned over here. motion under gravity. Suppose if a ball is dropped from certain height, what will be its acceleration? That is force by mass. Force is mg by m and m will cancel, so acceleration is g, that is 9.8 meter per second square. Take this acceleration always downward and take this always negative. So we say this acceleration is 9 minus 9.8 meter per second square. Or yes or no? If from now onwards, ladies and gentlemen, I say if I release this object, it falls down. Due to what? Due to gravity. It will have an acceleration of 9.8 meter per second square. Okay. Let's suppose if I ask you, what if I ask you, see, there is an object. This is at height h. If I say, if you release this object, release means initial velocity is 0. See. If you release this, initial velocity is 0. So if you throw this, in that case, initial velocity is not 0. Releasing means initial velocity is 0. Throwing does not mean initial velocity is 0. So if initial velocity is 0, how much time it is going to take in falling down? Sir, I can use this equation. S is equal to ut plus 1 by 2 at square. Use this equation. Now guys, see, if this is falling down, you say, sir, how much displacement it is coming down? That is h is equal to initial velocity is 0, 1 by 2. Take this acceleration as minus g. Acceleration you will be taking as minus g, 9.8 meter per second square. So this is minus g into, we say, t square. Now guys, remember one thing. So guys, see. If you say body is moving towards right, you take velocity as positive. Body is moving towards left, you take velocity as negative. Body is going up, you take velocity as positive. Let me write these sign conventions. See. If body is moving towards right, you consider velocity positive. If body is moving towards left, you consider velocity negative. Okay, if body is moving upward, you consider velocity positive. If body is moving downward, you consider velocity negative. As simple as that. Same in case of displacement. If you say body is going up, so this displacement you consider positive. If you say body is going down, you consider this displacement as negative. And when it comes to the acceleration you always take negative. Even if the body is going up, let me write this also. Even if the body is going up, acceleration is minus g. Or if the body is going down, acceleration is always minus g, because acceleration is always downwards. So keep these sign conventions in your mind, please. Now tell me, body is coming down, so displacement in that case will be negative, so minus. This and this will cancel, so and then take this 2h will be equals to gt square. So take this g over here, so t square will be equals to 2h divided by g, and time will be under root of 2h divided by g. So this is the time in which it will fall down. How many of you understood this? Please tell me in the chats. Tell me, guys. How many of you understood this? This is the time in which it will fall down, and this is called time of flight. This is called time of flight. This is called time of flight. Yo. Okay, this is called time of flight. Now see, time of flight is, this is the derivation over here, under root of 2h divided by g. Okay, this is the time, and this time does not depend upon the shape, mass, size of the object. Okay. Guys, one more important thing. If you release an object, it falls down. If I say with what velocity it will strike with the ground, what is the velocity over here? We say use v square minus u square is equal to 2as. As final velocity you have to find. Initially you are releasing. Initial velocity is 0. So v square is equal to 2. Acceleration in this particular case you will be considering over here. That is minus g. Okay. We'll be considering minus g. And in this particular case, listen to me, my dear friends, we say this h, while it is falling down, this 2a is minus g. S means how much it is coming down, that is h. So this will be minus h. So minus into minus is plus. So v square is 2gh. So take this over here. V will be under root of 2gh. Tell me in the chats, is this clear? This is what we call velocity of hit. Velocity of hit means that velocity with which it will strike the ground. I'll write over here that velocity with which it strikes the ground. That velocity with which it strikes the ground is what we call the velocity of hit. Okay. Yes, take a look over here. Now guys, one more important thing. If I say object is over here, initially its velocity is 0 at time t is equal to 0. And what is the value of acceleration? Acceleration is g, and that you approximately can consider 10 meter per second square. Now if I say what is the velocity after 1 second, you say sir v is equal to u plus at. V is equal to initial velocity is 0, acceleration is 10 and time is 1. So velocity will be 10 meter per second. So after 1 second velocity is 10. After 2 seconds, what is the velocity? V is equal to g into t. Instead of a, it is g into t. G is 10, 10 and 2 is 20. After 3 seconds, what is the velocity? 30. After 4 seconds, what is the velocity? 40. Yes. So means acceleration is 10 meter per second square. Okay. What does that mean? Means, see. Here velocity is 10. Here velocity is 20. Here velocity is 30. Can I not say every second velocity is increasing by 10 meter per second, 10 meter per second, 10 meter per second? And that is what we call acceleration. So velocity is increasing linearly in this particular case. Velocity increases 10 meter per second every second, every second. One more important thing. See guys. Let's suppose ratio of heights. You have already studied this. If I say you have released an object at t is equal to 0, can I not say its initial velocity is 0 because you are releasing this object? Can I not say its acceleration is constant because that is g and that is 10 meter per second square, that is constant? Yes. Now what is this one thing that you have studied? If acceleration is constant, initial velocity is 0, you have studied one thing. What? You have studied this. Ratio of displacement in 1 second, 2 seconds, 3 seconds, 4 seconds, and this ratio. First second, second second, third second, fourth second, yes. So means this can be applied over here also. Ratio of displacements in 1 second, in 2 seconds, in 3 seconds, in 4 seconds, in 5 seconds. So if you release an object, what is the height it will cover in 1 second? That is x. Same. What is the height it will cover in 2 seconds? Same, 4x. What is the height it will cover in 3 seconds? 9x. 4 seconds, 16x, 25x. And guys, how much is the height covered in first second? X. Height covered in second, 3x. Height covered in third second, 5x, 7x, 9x. How many of you understood this? Please tell me in the chats. Even you can write it like this. Height covered in 1 second is 2. Height covered in 2 seconds is 2. height covered in 3 seconds is to height covered in 4 seconds is to height covered in 5 seconds, it will be x is to 4x is to 9x is to 16x is to 25x. Okay, this. And if I say height in the first second is to height in the second, okay, and is to height in the third second is to height in the fourth second, it will be x is to 3x is to 5x is to, we say, 7x, and so on. How many of you understood this? Or tell me in the chat, so I'm seeing the chats over here. I need to know in the chats if this is crystalline clear. Everybody out there. Everybody. It's mentioned over here. NEET 2022, you see the question? See? The ratio of distance traveled by a freely falling body. A freely falling body means initial velocity is 0, acceleration is constant. Okay? In first second, second, third second, 1 is to 3 is to 5 is to 7. Oh, yes or no? In a freely falling body, this is x is to 3x is to 5x is to 7x. So 1 is to 3 is to 5 is to 7. This is the ratio. This is the ratio. Take a look at this. A stone falls freely under gravity. There is a stone which falls freely under gravity. Okay. It covers distance h1, h2, and h3. This is already done. This question is already done. This is your homework. Because this question is the replica of this question. This question is the replica of this question. This question is the replica of this question. 100% replica. So this you guys are supposed to do it from your own. Let's talk about next one. A body dropped from a top of a tower falls a height of 40 meters. Okay. There is a tower over here. Okay. There is a tower over here. Its height is 40 meters. And a body is dropped. And a body is dropped from the top of the tower. It falls down. It falls down. Okay. And it says during the last 2 seconds, it falls. During the last 2 seconds of its fall. Okay. A body dropped from the top of a tower falls through 40 meters. Falls through 40 meters. No. This is not the height. This is not the height. Falls through 40 meters. During the last 2 seconds. Okay. A body dropped from the top of a tower. Falls through 40 meters during the last 2 seconds. Okay. Guys, let's suppose after 1 second the body is here. After 2 seconds the body is here. After 3 seconds the body is here. Okay. Let's make it like this. After 1 second body is here. After 2 seconds the body is here. After 3 seconds the body is here. Yes. And 4 seconds body is here. 5 seconds and it is going down. The question says that in the last 2 seconds, it is covering 40 meters. In last 2 seconds of its fall, it covers 40 meters. Yes. Now tell me, guys. If I say how much is this distance, this is x. How much is this distance? This is 4x. If I say how much is this distance? This is 3x. And how much is this distance? This is 5x. Now guys, see. Let's find the value of x. See. We say, guys. Displacement in first second. First second. You say S is equal to ut plus 1 by 2 at square. So this displacement in first second, initial velocity is 0. 1 divided by 2. Acceleration is 10 because we're taking acceleration 10. Time in this case is 1 square. So this is 10 by 2. So S1 will be equals to 5. So this displacement is 5. So value of x is 5. Now what is the value of 3x? 3 into 5 is 15. What is the value of 5x? That is 5 into 5 is 25. 25 meters. Now see the question. Question says in the last 2 seconds of its fall, it covers 40 meters. In the last 2 seconds of its fall, it covers 40 meters. Now last 2 seconds, if you consider this and this, so 25 plus 15 is 40, means its total time is 3 seconds. See. How much is this? This is 5 meters. How much is this? 15. How much is this? 25. How much is this? 35. 75, 35. Okay. How much is this? 45. If I say, guys, see, please. If I say, I'll repeat it. If I say, sir, during the last 2 seconds, it has covered, I would say 80 meters. It has covered 80 meters. What are those last 2 seconds? These two, because 25 plus 15 is 40. No. These two, 15 plus 5 is 20. No. These two, 35 plus 25. So 30 plus 20, 50. This is 60. No. These two, yes. 45 plus 35 is 80. 45 plus 35 is 80. So what I'm trying to say, if I say during the last 2 seconds of the fall, it is covering 80 meters, means last 2 seconds is this second and this second. Oh, yes or no? Similarly, my dear NEET aspirants, if I say during the last 2 seconds of its fall, if it is 40 meters, means that is this second and this second, because this is 35 plus 15, total is 40. So in the last 2 seconds of its fall, we say that is this 35 meter, this 25 meter plus 15 meters. Okay. So last 2 seconds are, we say 2 and 3. So now what is the height of the tower? Now guys, this is this much is 25, this is 15, this is 45. So height of the tower is 45. Height of the tower is 45 meters. How many of you understood this? Please tell me in the chats. How many of you understood this? Tell me, everybody out there. Tell me, oh. Tell me, is this clear? Sir, lugsaya lolas. Adlag ilzayud shokshi. Tell me, oh. Is this clear? Yes, we'll take the break. Okay, I hope this is clear. Now, this one, the water drops fall at a regular intervals from a tap 5 meters above the ground. The third drop is leaving the tap at the instant when first drop touches the ground. See guys, what does the question say? See, this is a tap, okay? From this tap, water droplets are coming out and falling at regular intervals. This is the surface. This is the surface. It says that when third droplet comes out of the tap, first is about to touch the ground. This is the first droplet, and second would be somewhere around over here, and this is the third droplet. Okay, yes. Can I not say, and it is falling in the regular intervals of time. So means in the first second, this comes out, then this, then this. So you can say time over here is 1 second, time over here is 2 seconds, and time over here is 3 seconds. So 3 seconds has gone till over here. Okay. So when this first droplet comes out, third is about to touch. Okay. So this third droplet is taking 3 seconds from reaching top to the bottom. Okay. And this is at a height of, okay, it says the tap is 5 meters above the ground. So this tap is 5 meters above the ground. This height is 5 meters. And what we are supposed to say? What is the height of the second drop from the ground at that instant? We are supposed to find what is the height of the second drop. What is the height of the second drop? Guys, see. We say this is the tap. Let me just give you the feel of this question. This is the tap. So first drop is coming out, so it is falling. When first drop reaches here, then second drop comes out. Okay. And then again, see, I'll show you like this. This is the first drop. When it reaches here, we say second drop comes out. Okay. And then, my dear friends, when, and this is the surface over here. When this first drop touches the ground, second drop reaches here, third drop is coming out. So how much time it is taking in total? So 1 second, 2 second, it is taking 3 seconds. Okay. So I hope this is crystal and clear. Okay. Yes. Now, my dear friends, it says that the water droplets fall at a regular intervals from a tap 5 meters above the ground. The third droplet leaving the tap at that instant when first drop touches the ground. What is the height of the second droplet? Now, guys, listen to me very carefully. Can I not say in this particular case, listen. How much is going to be this distance? This is x. And how much is going to be this distance? This is 3x. Everybody knows that this distance is x and this distance is 3x. Yes. Now, what we are supposed to say, what is the height of this second droplet? Height of the second droplet from the ground is 3x. Height of second droplet from the ground is 3x. Now, first of all, let's find x. See. What is the total height? We say we say x plus 3x will be equals to 5 meters. So we say 4x will be equals to 5 meters. So x will be equals to 5 divided by 4. X came out to be 5 by 4. Now, what is the value of 3x? So 3x is going to be 3 into 5 divided by 4. That is going to be 15 divided by 4. Oh, is this clear? Is this clear? Okay, that's great. 3.75, yes, 3.75 meters above the ground. Is this clear? Please give me the signal in the chats. Everybody out there, please give me the signal in the chats. Okay, or let's take the break till 10. Okay, long break. Chalo, guys. Let's get back to business. Now we need to talk about motion under gravity ground to ground. Means. Let's suppose, let's suppose if you throw an object, if you have an object which you throw from the ground, it will reach the top, okay, and then it starts falling back. This is what we call motion under gravity from ground to ground. You are throwing an object with some velocity, let's suppose u, from the ground. At topmost point, its velocity will become 0. Then it falls back. Then it falls back. This is what we call motion under gravity from ground to ground case. Okay. And in this particular case, my dear friends, the very first thing that we need to talk about over here is the maximum height attained, how high it can go. What is going to be the maximum height in this particular case? That is what we are supposed to calculate. How high it can go. What I want you guys to use is v square minus u square is equal to 2as. So from bottom to top, you use this equation. So final velocity is 0 because at topmost point it stops. Then only it starts falling back. Minus initial velocity is u square is equal to acceleration is g and this is h. And I would say minus g. Now guys, this minus and minus will cancel. So h is u square divided by 2g. Sorry, this is u square divided by 2g. U square by 2g. Okay. Similarly, my dear NEET aspirants, if I say time of flight, how much time it is going to take while going up and while coming back? When I say time of flight, I'll use this equation. S is equal to ut plus 1 by 2 at square. S is equal to ut plus 1 by 2 at square. Guys, if you are applying this equation from bottom, it will go till top and then falls back. What is the displacement? 0. So displacement is 0. Initial velocity is u and time is t plus 1 by 2. Acceleration is minus g into we say t square. Now take it over there. This is minus ut is equal to 1 by 2 gt square minus gt square. Minus and minus will cancel. T and square will cancel. T will be 2u divided by g. So how much time this object is going to take? How much time this object is going to take? Okay, while going up and while coming back. That is 2u by g. Means. Guys, while going up, it is going to take time u divided by g. While coming back, it is going to take time u divided by g. So total time is 2u by g. Total time is 2u by g. Total time is 2u by g. So if you are launching an object from ground, it goes till top. At topmost point velocity is 0, then it falls back. We say maximum height attained is u square by 2g. Okay. And maximum height attained is u square by 2g. Okay. And then, my dear friends, time of flight is 2u divided by g. 2u divided by g. And upward and downward time individually is u by g. Total time is 2u by g. Okay. Yes. Now, guys, see. There is a master concept that I want you guys to understand over here. What is that? What is that? See, guys. Let's suppose if you are launching an object from the ground. We say it will go, and it will reach the top. At topmost point, its velocity is 0. Now, guys, now you consider the downward journey. Ignore this upward journey. Ignore the upward journey. Consider downward journey. Listen to me very carefully. Listen to me very carefully. In this particular case, I would say at topmost point, what is the velocity? 0. So when it starts falling back, what is the velocity at the topmost point? That is 0. Now, my dear friends, we say after 1 second, it is 1 second over here. After 1 second means when it starts falling, after 1 second. Could you please tell me how much is going to be this distance? Sir, 5 meters, we have studied already. Displacement covered in first second, second second, third second, fourth second. So this will be 15, this 25, this will be 35. Now guys, see, what I'm trying to say is that, if let's suppose you throw an object in the upward direction, at topmost point velocity is 0. Now it starts falling back. Listen carefully. Don't you think that in this particular case, let's suppose after 1 second it is here, after 2 seconds it's here, after 3 seconds it's here, after 4 seconds it's here. So this is 5 seconds, this is 6 seconds, this is 7 seconds, this is 8 seconds. Okay. Now guys, in this particular case, we say this distance is x, this is 3x, this is 5x, this is 7x. Now if this is 7x, how much this is going to be 7x? If this is 5x, how much this is going to be 5x? If this is 3x, how much this is going to be 3x? If this is x, how much this is going to be x? As simple as that. You can copy it exactly like this. So what I'm trying to say is that means consider downward journey, because in the downward journey initial velocity is 0, acceleration is constant. Use the displacement ratio. Let's suppose if the time is 8 seconds, first, second, third, fourth, fifth, sixth, 7, 8, total is 8 seconds. If the time is 8 seconds, so whatever is the displacement in first second, same as in 8 seconds. So this is the first second displacement, this is the 8th second displacement. So both are equal. Okay. Whatever is the displacement in third second, same will be the displacement in, we say this third second and this second displacement is equal. This displacement and this displacement will be equal. I hope this is crystal and clear. One more important thing. If let's suppose you are throwing an object with a velocity u, 20 meters per second. If somebody says, is there any issue with the voice or it is clear? Okay. Let's suppose if initial velocity over here is 20 meters per second. If I say what is the upward time of journey, that is u by g, that is 20 by 10, that is 2. So total time is 4 seconds. What is the maximum height? U square by 2g. That is 20 into 20 divided by 20. This will come out to be 20 meters. Okay. If let's suppose u is 30. So we say upward journey is 33 seconds and total time is 6 seconds. So maximum height is going to be 45 meters. As simple as that. Okay. Now guys, take a look. Because this see, in this particular case, let's take a look at this particular. See, this question is an amazing question and this is going to take all the confusions out. A ball is projected upward with a speed of 40 meters per second, then find. First of all, you have to find the total time of flight. Upward journey, downward journey time. So this is going to be 2 into u. What is the value of u? That is 40 divided by g. What is the value of g? G is 10. This and this will cancel, so this will be 8 seconds. So total time is 8 seconds. Means upward journey 4 seconds, downward journey 4 seconds. So this is first second, second, third, fourth, fifth, sixth, seventh, eighth. Okay. Now guys, as I told you, in these types of questions, you consider downward journey. So here, velocity is 0. initial velocity and acceleration is constant. Don't you think that this in the first second, in the downward journey of first second, this displacement is 5 meters. In the downward journey of second, this will be 15 meters. This is going to be 5x, 25 meters. This is going to be 7x, that is 35 meters. Yes, sir. Now, guys, if I say what is the upward time, that is 4 seconds. What is the downward time? That is 4 seconds. If I say what is h maximum, that is u square divided by 2g. And how much is going to be u square? That is 40 into 40 divided by 20. This and this, 2 ones are 2, 2s are 4. 2 into 40, this is going to be 80 meters. So means total height in this case is going to be 80 meters. Speed after t is equal to 5 seconds. Speed after t is equal to 5 seconds. Now guys, see, it says what is the speed of this object at t is equal to 5 seconds. Listen carefully. Listen carefully. At t is equal to 5 seconds. Guys, we can say we can use v is equal to u plus at. Now guys, use this equation from top to bottom. Not top to bottom, from top to this. Now guys, when you apply this, see, you are supposed to find what is the velocity over here. So consider downward journey. Initial velocity will be 0. So you can say v is equal to initial velocity 0 because you are considering downward journey. Okay, so this will be 0 plus acceleration in this case is 10 and time is 1 second because from this point to this point it is 1 second. So this is the velocity that is 10 meter per second. This is the velocity that is 10 meter per second. And if you ask me what is the velocity at t is equal to 6, so we use say u plus a into t. Here also you will be using, so v is equal to initial velocity is 0 plus acceleration is 10. Okay, and it is saying 6 seconds means in the downward journey this time is 1 plus 1 is 2, so this is 2. So velocity is going to be 20 meter per second. Velocity is going to be 20 meter per second. Velocity is going to be 20 meter per second. Okay, yes. Okay, so basically if they ask you to find the velocity here, now guys, see, let's suppose, see, please, let's suppose they are asking you to find the velocity at t is equal to 5. So you are considering downward journey. Why? Because it makes it simple. So means in the downward journey, this 5 second means 1 second. This 6 second means 2 seconds. This 7 second means 3 seconds. And whatever is the velocity at t is equal to 6 seconds, same is going to be the velocity at t is equal to 2 seconds, but the direction will be upward. That is 20 meter per second. So it is 20 meter per second. Okay. This is the case. Next, distance covered in 6 seconds. Now guys, see, how much is the distance covered in 6 seconds? If this is 35 meters, we say this will be also 35 meters. If this is 25 meters, we say this is also 25 meters. If this is 15 meters, we say this is also 15 meters. If this is 5 meters, this will be 5 meters. Now, distance covered in 6 seconds. In 1 second, 35 plus 25 plus 15 plus 5. Okay. Okay. So total it is going to be 80. Now 80 plus 5 is 85. 85 plus 15 is 100. So I can say this is going to be 100 meters. Displacement in 6 seconds. How much is the displacement in 6 seconds? Guys, at 6 seconds particle is here. Initially it was at the bottom. Now how much is the displacement? Join initial and final point. That is 25 plus 35. So this is going to be 25. This is going to be 25 plus 35. Okay. Okay. That will be 60 meters. Average speed in 7 seconds. Now guys, average speed in 7 seconds. Listen to me very carefully. So from here to here, average speed is total distance upon total time. So from here to here, distance is 80, 85, 100. And this is 125. So total distance in 7 seconds is 125 divided by 7. Then it says average velocity in 5 seconds. Now guys, average velocity means total displacement travel. What is the displacement in 5 seconds? 35 plus 25 plus 15. That is going to be 75. divided by 5. 75 divided by 5. I hope this is crystal and clear. Distance moved in 8 seconds. What is the distance moved in 8 seconds? First, second, third, fourth, fifth, sixth, seventh, eighth. In 8 seconds, it is 35 meters. I need to know in the chats if this is crystal and clear to each and every single student. Guys, tell me in the chats. Is this clear? Is this clear? Oh? Tell me. Now, guys, a ball is thrown upward with a speed of 40 meters per second. Then find the average velocity in the upward journey. Guys, see. It says that you are throwing a ball in the upward direction with a velocity of 40 meters per second. Okay. And this ball reaches the top. Okay. Then it says find the average velocity. Guys, how do you find the average velocity? That is total displacement upon total time. First of all, you need to find the time, upward time. Guys, see, what is time upward? That is u divided by g. That is 40 divided by 10. This and this will cancel, so this is 4 seconds. And how much is this distance? That is maximum height, h max. H max is u square by 2g. So u square is 40 into 40 divided by 20. This and this, 2 ones are 2 twos are 4. This is going to be 80 meters. Now, if I say V average, now what is V average? How much is the total displacement? That is the maximum height, that is 80. How much is the total time from top to bottom? That is 4 seconds. 4 ones are 4 twos are. So this is going to be 20 meters per second. Then it also says speed at half of the maximum height. What is the speed at this point? What is the speed at this point? Second, speed at half of the maximum height. Now, guys, take a look. I have told you the equation over here. Speed at half of the maximum height. Speed at half of the maximum height. Now, guys, see, midpoint velocity. Initial velocity is u, final velocity is v. Okay, what is the midpoint velocity that you guys are supposed to find out when acceleration is constant? Under root of v square plus u square divided by 2. Don't you think that in this particular case, you guys need to use the same formula? In this particular case, so you will be like, sir, v mid is equal to under root of v square plus u square divided by 2. Yes, under root of, what is the value of v? Final velocity at topmost point, what it is? 0. That is 0 square plus, I would say, 40 square. So 40 into 40 divided by, I would say, 2. Now, guys, tell me, this 2 ones are 2 twos are 2 zeros are. Okay. Is this clear? Oh, is this clear? Oh, tell me in the chats. Is this clear? Okay. Okay. Or you can directly say 40 by root 2. 40 by root 2. Don't do this. So it is actually 0 plus 40 square divided by 2. So this is 40 divided by root 2. You can say it something like this. A ball is projected up. Its position at t is equal to 7 and t is equal to 11 seconds is same. Then find the projection, find the velocity of projection and maximum height. See guys. Listen to me very carefully. We have a ball. We have launched this ball. Okay. It is going up. It is going up. Okay. Then it is falling down. Then it is falling down. Cool. It says, let's suppose after t is equal to 1 second, ball is here. After t is equal to 2 seconds, ball is here. After t is equal to 3 seconds, ball is here. At t is equal to 4 seconds, ball is here. At t is equal to 5, ball is here. 6 seconds, 7 seconds, 8 seconds. Could you please tell me what is the total time in this particular journey? Sir, 4 plus 4 is 8 seconds. Now guys see. Now guys see. If you add these two, we say 6 plus 2 is equal to 8 seconds, which is total time. Even if you add these two, we say 7 seconds plus 1 second is equal to 8 seconds, which is total time. So the concept is basically, if you throw an object, if I say the position of the object at t is equal to 1 and 7 is same, then we say if you add 1 and 7, we say they will give you the total time. That will give you the total time. If I say position of the object at 3 and 5 is same, then their addition is going to give you the total time. What does the question say? A ball is projected up. Its position at t is equal to 7 and t is equal to 11 is same. Could you please tell me what is the total time? That is going to be 7 seconds plus 11 seconds. Okay. Okay. Is this clear? So this is going to be 18 seconds is the total time. 18 seconds is the total time. So if the questioner says that position of the ball at 1 second and 7 is same, then 7 plus 1 is the total time of the journey. Okay, so here total time is 18. Now in this case, if total time is 18, what we are supposed to find in this particular case is, we say maximum height and velocity of projection. How do you say maximum height? Or you say time of flight? You say time of flight, that is 2u divided by g. What is the total time? That is 18, okay, is equal to 2 divided by 10 into u. So this is 5 zar. So u will be in this particular case 18 into. So once you get u, okay, you can find the maximum height. So is this clear? Oh? Because maximum height then will be h is equal to u square by 2g. Okay, u square by 2g. So in this particular case, so h max, that is u square by 2g. So what is the value of u? 18 into 5, that is 90. So this will come out to be, that is 90 into 90 divided by 20. 2 into 10 is 20. This and this will cancel. Okay. 2 ones are 245s are. So 45 into, we say 9. Okay. Okay. So basically, once you get the total time of flight, then you apply t is equal to u by g. And from here, you will get the initial velocity. When you get initial velocity, you can find the maximum height in this particular case. Guys, tell me in the chats if this is crystalline clear. Tell me. Tell me, guys, if this is crystalline clear. Now, if air resistance is not ignored, let's suppose you are throwing a ball in the upward direction. We say when the ball is thrown in the upward direction, acceleration due to gravity is downwards and air resistance is also downwards. Because when the ball goes up, air resistance is opposing the ball. Air resistance will not let the ball to go up. So it is opposing the ball. So we said till now, all the cases we were discussing, we were ignoring the air resistance. But if we do not ignore the air resistance, while going up, air resistance is opposing the velocity. See guys, velocity is upward, air resistance is downward. So velocity will decrease. So velocity will decrease and becomes zero in lesser time and becomes zero at lesser time. So we say, guys, if air resistance is opposing the velocity, so velocity will decrease. So if let's suppose we ignore the air resistance, ball will go till here. Okay, it will take more time. So here it will become zero in lesser time. So we say in that case, time upward will be less than u divided by g. And air resistance is ignored. In that case, it is u divided by g. In this case, it is less than u by g. And while falling down, my dear friends, we say when the object is falling down, air resistance will oppose that in the upward direction. Okay. So air resistance is opposite to the velocity. So body will take more time while reaching the ground. So if air resistance is opposing, so body will take more time in reaching the ground. In that case, time downward is greater than u by g. Time downward is greater than u by g. Guys, while the ball goes up, in that case, we say air resistance opposes, so it will become zero in lesser time. So time will be less than u by g. So while it is coming down, in that case, time is greater than u by g because it will take more time in falling down. Is this clear? So what I can say, when air resistance is not ignored, in that case, we say downward time is greater than time up. Downward time is greater than time up. Okay. And when air resistance is ignored, we say upward journey time is equal to the downward time. Okay. I hope this is crystalline clear. I hope this is crystalline clear. Let's talk about the graphs of kinematics. So this is absolutely level up than 2.0 version. Are you asking me or are you saying? Okay. Now, guys, graphs of kinematics. Graphs of kinematics. Listen to me very carefully. Listen to me very carefully. First is position time graph. What is position time graph? Let's suppose you have a car over here. This car is moving. At t is equal to 1 second, car reached over here. X is equal to 1. At t is equal to 2 seconds, car reached here. X is equal to 2. At t is equal to 3 seconds, car reached here. X is equal to 3. At t is equal to 4 seconds, car reached here. X is equal to 4. Now, I am saying, with time, I am saying the car is moving over here. Okay. Now, I am asking you to plot this situation graphically. This is the position, this is time. Make its position time graph. When time is 1, position is 1. When time is 2, position is 2. When time is 3, position is 3. So means it will be a straight line. It will be a straight line. When time is 1, position 1. Time 2, position 2. Now guys, in this particular graph, if I ask you, could you please tell me what is the slope of this graph? You say, sir, slope is simply tan theta. Tan theta is perpendicular by base. Okay. From this triangle, tan theta is perpendicular by base. And on perpendicular, you take this x, and on base, you take t. So you can say delta x by delta t or x by t, whatever you say. Now, what is delta x by delta t? That is velocity. So can I not say, sir, slope of position time graph gives us velocity? Yes. So from now onwards, if somebody asks you to find the velocity from position time graph, you'll find what? Velocity. You'll find what? Velocity. Compare the displacement of car A and car B. Now guys, let's talk about velocity first. This is car B. It is making an angle of, let's suppose, beta. This is car A, it is making an angle of alpha. Okay. So clearly in this particular case, we say alpha is greater than beta. Alpha is greater than beta. Clearly you can say in this particular case, alpha is greater than beta. If this angle alpha is greater than beta, you can say this slope of A is greater than slope of B. Slope of A is greater than slope of B. Yes. So can I not say velocity of car A is greater than velocity of car B? Why? Because in case of position time graph, slope means velocity. Then if I say displacement, guys, see. Then if I say displacement, we say final position. This is position time graph. Final position of car A is this, x final. And final position of car B is this, x final. Initial position of both the cars is same. Initial position is same, final position is same. So don't you think both have got the same displacement? Yes. So we say displacement of car A is equal to displacement of car B. So what does it mean? It means both cars, let's suppose this is the car A. It has covered this 10 meter distance in lesser time. So car B has taken more time in covering the same distance. So that's why displacement is same, but velocity is not same. Displacement is same, but velocity is not same. Let's suppose you have this. Find the ratio of velocity of A and B. This is the graph of car A, this is the graph of car B. Now, if I say what is the velocity of A divided by velocity of B, how will you find out? So velocity means slope. What is the slope of A? This angle is how much? This is 30. Because if this is 45, this will be 15. 45 minus 15, this is 30. So I would say slope means tan theta. So this A is making 30. So tan of 30 divided by B is making 60. Tan of 60. Now, if I say tan 30, it is 1 divided by root 3. If I say tan 60, it is root 3. So root 3 into 3 is, root 3 is 3, 1 by 3. This is the ratio. Now, guys, take a look in this particular case. Which of the following graph represents the uniform motion? Uniform motion means velocity constant. Now, guys, see, this is displacement time graph. Now, see. In this displacement time graph, clearly, we know slope of a straight line is constant. We say slope here, slope here, slope here. It is creating same angle. So slope is constant. If slope is constant, means velocity is constant, uniform motion, correct? In this case, slope is not constant. Why? Because it's a circle. How is it possible that slope is constant? So velocity is not constant. No. In this case, guys, what is the value of slope over here? What is the value of slope over here? 0, because it is parallel to x-axis. If slope is 0, means velocity of this body is 0, means body is at rest. This is the graph of the car which is at rest. Here. Guys. Initially, slope is positive because here, we say this is theta. Theta is less than 90. When theta is less than 90, in that case, slope is positive. When slope is positive, means velocity is positive. Initially, velocity is positive. And here, theta is greater than 90, less than 180. In this case, we say slope is negative. If slope is negative, means velocity is negative. Now, guys, means velocity direction is changing. Okay, so initially slope is positive, then slope is negative. Means initially velocity is positive, then velocity is negative. So velocity is not constant, direction is changing. So what is the answer? Answer is the first one. Answer is the first one. Is this question clear? Please tell me in the chat. So is this question clear? Tell me. Is this clear? That's great. At which point velocity of the particle is maximum? Now guys, this is the displacement time graph. At which point velocity is maximum? Velocity will be maximum where slope is maximum. At this point, I would say slope is 0. At this point, slope is 0, means velocity is 0. Okay. Now, when you compare B and C, I can clearly say, sir, at B, this theta 2, at A, this theta 1. I can say theta 2 is greater than theta 1. So clearly you can say slope at 2 is greater than slope at 1. So you'll be simply saying velocity at 2 is greater than velocity at 1. So velocity VB is maximum. Velocity at point B is maximum. Velocity at point B is maximum. Let's suppose you have this. Find the average speed and average velocity in 8 seconds. See guys. When it comes to the average, when it comes to the speed, average, how will you say? It is total distance traveled. Total distance traveled. See guys. See. How much is the distance traveled? So in first 2 seconds, it is covering 10 meters. Then 4 till 4 seconds, 10 meters. Then you can see over here, see, in first 6 seconds, it is covering 20 meters. And then from 6 to 8, you can see the graph. Again, it is coming back to the original position. So again, 20 plus 20 is 40. So total is 40 meters. So distance is 40 divided by time is 8. So this is 5 meters per second. Because see. In this particular case, from 0 to 6 seconds, you see this is the peak graph. So it is covering 20 meters. Then it is coming back. It is like an object covers 20 meters in 6 seconds. Then it comes back to the original position, covers again 20 meters, but in how much time? Only 2 seconds. How much is the total distance? 20 plus 20 is 40. Total time is 8 seconds. When I say average velocity, guys, see, object covers, you see, object covers 20 meters in first 6 seconds, then comes back. So what is the total displacement? 0. Time is 8, so it will be 0. Now guys, if you take a look at this graph, okay, first take a look at this graph. If this is disposition versus time, in this case, if you see velocity is constant. Why? Because slope in this case is constant. If velocity is constant, slope is constant, means acceleration in this case is how much? 0. Acceleration of this graph is going to be 0. Why? Because velocity is constant, slope is constant, so acceleration is 0. So acceleration is 0. Now, if you take a look at this graph, this is position versus time. In this case, we say slope is variable. Slope is not constant. See, slope at this point is something. Here slope is more. Here slope is more because theta is increasing. Okay. And in this case, at every point, theta is less than 90. Here. So slope is positive, slope is variable because theta is less than 90. And in this case, velocity is positive. So velocity is changing in this case, I would say increasing. Why? Because if you take a look, guys, see, at this point, slope is something. At this point, slope is greater. At this point, slope is greater. So we say slope is increasing, means velocity is increasing. And in this case, we say acceleration is positive and acceleration is constant. Sir, how acceleration is constant? Please make us understand. See guys. Listen carefully. We say this is x versus t, and graph of this is parabola. X is equal to t square. I have told you this in the basic maths. If x is equal to t square, find velocity. Velocity is dx by dt. That's differentiation of this, that will be 2t. Find acceleration, that is differentiation of velocity, dv by dt, that is 2, and 2 is constant. So this acceleration came out to be 2 and it is constant. So acceleration of this kind of position time graph in which x is proportional to t square, we say acceleration is constant. Acceleration is constant. Okay. Yes. 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 And guys, in this particular case, you see over here, this is the case of retardation. This is the case of retardation. Here, what is the slope at this point? What is the slope at this point? Slope is something. Slope is something. At this point, guys, at this point, if you check this theta, it is less than 90. So velocity is positive. At this point, we say velocity is 0. Why? Because at this point, slope is 0. Okay. So in this particular case, guys, don't you think that this is the case of retardation? Why? Because the body is slowing down. Initially, it has some velocity, then its velocity becomes 0. So body, this is the case of retardation. This is the case of retardation. Now tell me, guys, quickly in the chats, is this clear? Is this clear till over here? Everybody? Oh, okay. That's great. Now, guys, which graph has constant acceleration? In this particular case, we say velocity is constant because slope is constant. So acceleration is 0. In this case, we say velocity is 0. Here, acceleration is 0. Slope is 0. In this case, guys, we say acceleration is constant. Recently, we talked about this. In this case, acceleration is variable. Okay. Yes. I hope this is crystal and clear till over here. Now, velocity time graph. Let's suppose we have a car over here. Okay. This car started moving. After t is equal to 1 second, velocity of the car is 1 meter per second. After t is equal to 2 seconds, velocity of the car is 2 meter per second. After t is equal to 3 seconds, velocity of the car is 3 meter per second. Now, I am asking you to plot this situation graphically, plot its velocity time graph. You'll be like, sir, this is velocity, this is time. Its velocity time graph will be the straight line. Its velocity time graph is going to be the straight line, as simple as that. Why? Because when time is 1, velocity is 1. When time is 2, velocity is 2. When time is 3, velocity is 3. And if you ask me slope over here, slope means tan theta. That is perpendicular divided by base, perpendicular by base. What is perpendicular? Delta V. What is base? That is delta T. Delta V by delta T. What is that? That is acceleration. Because delta V by delta T is acceleration. So slope of velocity time graph gives us acceleration. From now onwards, if somebody asks you, what does slope of velocity time graph give? It gives us acceleration. It gives us acceleration. Okay. Now take a look. Area under velocity time graph. Let's suppose this is velocity and this is time. Let's suppose if I ask you to tell me this is the velocity time graph, find this area. Sir, area is simple. Area is simple. You have told us previously in basic mathematics. You'll be directly remembering this. Oh, if this is y and this is x and the graph is something like this. If you ask me what is the area over here, you will be simply saying integration of whatever is on y-axis, y, whatever is on x-axis, that is dx. If let's suppose this is acceleration and this is time, we'll be saying area will be integration of whatever is on y-axis, that is acceleration, whatever is over here, that will be dt. This is going to be the area. Now, see. If I say this is velocity time graph, what is going to be the area in this particular case? Area of velocity time graph will be integration of whatever is on y-axis v, whatever is on x-axis, that is dt, integration of v dt. Directly remember this, directly. Okay. Now guys, what is the integration of v dt? As we know, integration of v dt is displacement. So see, integration VDT. So can I not say this total area will be equals to displacement? So area total will be equals to displacement in velocity time graph. So from velocity time graph, if you want to find the displacement, you find area. Let me show you the question. So two things. Slope of velocity time graph gives us acceleration. And area of velocity time graph gives us displacement. Find the distance and displacement covered by the body. This is the velocity versus time graph. Guys, when I said displacement is going to be this area, upper area, and then this area minus this area. That is A1 minus A2. Sir, why? Because above this x-axis, we consider area as positive. Okay. And below this x-axis, we consider this as negative. Now guys, tell me, whatever is the area over here, 1 by 2, what is base? Base is 2, altitude is 10, minus, what is the area of this? 1 by 2, what is base? 2, altitude is 10. This and this will cancel, displacement is 0. But when we talk about distance is always added. Distance can never be negative. Okay. So what I can say in this particular case, what is the area of this? 1 by 2, base is 2. This is base, altitude is 10. That is 10. And you multiply this with 2 because this area plus this area. Now this 2, so this will come out to be 20 meters. I hope this is crystal and clear. In which graph acceleration is uniform, means acceleration is constant. See guys, velocity versus time graph. We see slope here is positive, okay, and slope at this point is, slope acceleration at this point is 0, means slope at this point is 0. Okay, so here acceleration is positive. Why? Because slope is positive. This is VT graph. In case of velocity versus time graph, slope means acceleration. So here slope is positive. Here slope is 0, acceleration is 0. So here acceleration is not constant. Now see, in this case, straight line, we say here slope is constant. So when slope is constant means acceleration is constant. Okay. In this case, we say velocity is constant because this is the constant graph. So in this case, acceleration will be 0. Okay. Now here, in this case, you see velocity here, this is θ1. Here, this is θ2. We say here slope is increasing. So means here acceleration is increasing. Because velocity time graph slope means acceleration. So which option? Option this. Find the displacement covered from 0 to 2 seconds. This is velocity versus time graph. You are supposed to find displacement from 0 to 2 seconds. When I say displacement from 0 to 2 seconds, you'll find area. Why? Because area of velocity time graph gives displacement from 0 to 2. 1 by 2, base is 2, altitude is 4. 2 and 2 will cancel, so it will be 4 meters. 4 meters is the displacement. Find average acceleration from 0 to 2. Now guys, see. Average acceleration from 0 to 2. What is average acceleration? Change in velocity upon change in time. That is final velocity minus initial velocity upon total time. Now guys, 0 to 2. This is 0, this is 2. So at t is equal to 2 seconds, what is velocity? That is 4, final velocity. Minus, at t is equal to 0, what is initial velocity? 0 upon. Total time is from 0 to 2, that is 2. So 4 by 2 is 2 meter per second square. Then from 2 to 3, average acceleration from 2 to 3. Now guys, see. At t is equal to 3 seconds, what is the acceleration? 0. Minus. At t is equal to 2 seconds, what is the acceleration? 4. Divided by. How much is the final time minus initial time? 3 minus 2. So this is 4, 3 minus 2 is 1. So minus 4 meter per second. How many of you understood this till here? Please tell me in the chats, everybody out there. Guys, I need the signal in the chats, please. Okay. Now, guys, find the average acceleration from 0 to 8 seconds at t is equal to 5. Guys, acceleration average from 0 to 8 seconds. This is velocity time graph. So you say delta v divided by delta t. Okay. Or you say from velocity time graph, you guys are supposed to find slope. What is this delta v by delta t? This is actually slope. Now tell me, this is final velocity minus initial velocity. V final minus V initial upon T final minus T initial upon T final minus T initial. Now, what is final velocity? Final velocity at T is equal to 8 seconds. That is 20. That is 20 minus initial velocity at T is equal to 0. That is 20 upon final time minus initial time. Final time is 8. Initial time is 0. So this will be 0. 20 minus 20 is 0. Then it says average acceleration at t is equal to 5. Acceleration at t is equal to 5. Now guys, see, whatever is the acceleration from 4 to 8 seconds, acceleration of this line, same will be the acceleration at this point. Why? Because straight line. In case of a straight line, whatever is the acceleration at any point, same will be between 2 points. Now acceleration will be final velocity at t is equal to 8 seconds. What is final velocity? 20 minus initial velocity at t is equal to 4 seconds. What is the initial velocity? That is 0 upon final time, that is 8 minus initial time, that is 4. So acceleration will be 20 by 4, that is 5 meter per second. Guys, it was asking what is the acceleration at t is equal to 5. I calculated acceleration between t is 4 to 8, because whatever is the acceleration between 4 to 8, same will be at t is equal to 5. Why? Because slope of this line is constant. Okay, if slope is constant, means acceleration is constant. Okay, a ball is thrown vertically upwards. This is the ball which is thrown vertically upwards, and then it falls down. We have to plot its velocity time graph. See. If you are throwing this ball in the upward direction, you will be considering velocity as positive. At topmost point, velocity is 0. Then it falls down, velocity will become negative. And in this case, acceleration is constant. Acceleration is constant, means slope is constant. Slope of velocity time graph must be constant. Now guys, what do you think the option graph must be? See guys, initially velocity is something. So you cannot start the graph from the origin. No, because this is VT graph. Initially velocity has some value. Then velocity becomes 0. Velocity is 0 here, and velocity is over here positive. Velocity is positive, velocity is 0. Okay, initially velocity is positive and then velocity is 0. Then velocity becomes negative. Then velocity becomes negative. From upper side velocity is positive, from lower side velocity is negative. Then velocity becomes negative. Sir, why cannot we make the graph something like this curved? Here also velocity is positive, here 0, here negative. The reason for that is because slope of this line, straight line, is constant, and slope means acceleration. So that's why we are making in this particular case what we are making, what? A straight line. So option D. So here velocity is positive, here velocity is 0, then velocity is negative, and in this case acceleration is constant because slope is constant. Okay, acceleration time graph. Let's talk about acceleration time graph. See guys, let's suppose there is a car over here. It starts moving. Its acceleration at t is equal to 1 is 1 meter per second square. At t is equal to 2, its acceleration is 2 meter per second square. At t is equal to 3, its acceleration is 3 meter per second square. I am saying plot this situation graphically. Plot this situation graphically. If you plot its acceleration versus time graph, it will be the straight line. Why? Because when time is 1, acceleration is 1. Time is 2, acceleration is 2. Time is 3, acceleration is 3. Now if you find slope over here, slope, you say, sir, slope in this case is tan theta. Tan theta means, sir, perpendicular by base, that is delta A by delta t. And delta A by delta t means jerk. It is not in our syllabus. So slope of acceleration time graph means nothing, you can say. Okay? Yes. Let's talk about area under acceleration time. See guys, let's suppose this is acceleration, this is time. This is the area. Can you tell me what is the value of this area? Integration of whatever is on y-axis, whatever is on x-axis, and dt. This is the first equation. Now guys, we have studied change in velocity is equal to integration a dt. Now see this equation first and second. The right hand side equal, so left hand side will be also equal. So this area will be equals to change in velocity. So from now onwards, area of acceleration time graph will give us change in velocity. Area of acceleration time graph will give us what? Change in velocity. So you'll be directly remembering from now onwards. If you want to find the change in velocity, you can find area of acceleration time graph. Now guys, let's take a look here. If the initial velocity is minus 10 meter per second, so initial velocity of an object is minus 10 meter per second. Then given the graph, then in the given graph, velocity at t is equal to 4 seconds. We are supposed to find final velocity. Guys, see, what kind of graph is given? Acceleration time graph. So when I say in case of acceleration time graph, change in velocity means area. So this is final velocity minus initial velocity, v minus u is equal to area. What is the area of this graph? That is 1 by 2, base is 4, altitude is 10. 2 ones are 2 twos are 4. So v minus u is equal to 20. Now what is the value of u? That is minus 10. So v minus of minus 10 is equal to 20. Minus into minus is plus. And plus, if you take it over here, it will again become minus. V is equal to 20 minus 10. That is 10 meter per second. This is how we can calculate. This is how we can calculate. Okay, take a look. A particle starts from rest. Initial velocity is 0 at t is equal to 0 and moves in a straight line with an acceleration shown below. It moves something like this. The velocity of the particle at t is equal to 3 seconds. Guys, see, we are supposed to find the final velocity at t is equal to 3 seconds. See guys, can I not again use over here? We say area is equal to change in velocity. We say area is equal to change in velocity. Now change in velocity means final velocity minus initial velocity is equal to area. Now you are supposed to find area of this acceleration time graph from 0 to 3. From 0 to 3 means this area. Why? Because it says the velocity of the particle at t is equal to 3 seconds. So we have to say this is area from 0 to 3 seconds. Keep this thing in your mind. So that is going to be v minus u is equal to. Now guys, see, what is the area of upper portion? That is length is 2, breadth is 3. So 2 into 3. Then minus area of this lower portion. Minus area of this lower portion. Area of upper portion minus area of lower portion. Minus, because it is from lower side. That is, this is 2, this is 1, this is 2. 2 into 1. V minus. What is the value of u? U is 0. That is 6 minus 2. That is 4. V is equal to 4 meter per second. Now, I hope this is crystalline clear. I hope this is crystalline clear. Now we have graph convergence. Oh, is this clear? Tell me in the chats. Now guys, graph conversions. Graph conversions. Let's suppose you have got over here displacement time graph. Okay, you are supposed to convert to it velocity time graph. Now guys, what is the information that you can collect from this graph? Sir, one thing, slope of this graph is constant. Slope is constant. And slope of displacement time graph is velocity. Velocity is constant. Now make velocity time graph and its velocity is constant. So in this velocity time graph, we say v is constant. Done. Now guys, see. Displacement time graph. In this case, everybody knows that acceleration is constant. Okay. Everybody knows that acceleration is constant. Okay. Slope is increasing and acceleration is constant means velocity is increasing. Okay. Now, if you make its velocity time graph, it is going to be like this. Why? Because here in this case, we say acceleration is constant. Because slope in this case is constant. The slope of velocity time graph is constant. Okay. Similarly, if you take a look at this graph, what is the slope at this point? Slope at this point is 0, means velocity is 0. Why? Because it is parallel to x-axis. Slope is 0. What is the slope at this point? So this is theta. Theta is greater than 90. So slope in this particular case will be negative. So means velocity is negative. Because when theta is less than 90, slope is positive. Theta is greater than 90, less than 180, slope is negative. Now see, from 0 to negative in this particular case means initially velocity is 0. Finally velocity is negative. Guys, take a look. Initially velocity is 0 means here. Finally it is negative. So graph will be this. Graph will be this. Velocity time graph will be this. Yes. Convert the position xt graph into velocity time graph. See guys, this is position versus time. Could you please tell me at this point, we say value of theta is less than 90. So slope will be positive, means velocity is positive. At this point, we say velocity is 0. Why? Because slope is 0. At this point, we say theta is greater than 90. In this case, slope is negative. So velocity is negative. Now guys, take a look. Velocity initially is positive, then it is 0, then it is negative. Velocity initially is positive here. Okay. Then it is 0. Velocity is 0. Then it is negative. A body is thrown vertically upwards, then it falls down. This is its velocity time graph. This is its position time graph. Okay. And this is acceleration time graph. Because if you compare this and this, it is same position time graph. Recently we converted this. See, this is the conversion. Now see, and acceleration time graph is acceleration is constant and is negative. Acceleration is minus g, that is constant. That's why graph is from lower side. Draw its velocity time graph. This is acceleration time graph. We have to plot its velocity time graph. Can I say in this case acceleration is positive and is constant? And here acceleration is negative and is constant. So if you draw the graph over here, initially acceleration must be positive. Graph must be like this. So here acceleration is positive. Okay, this is velocity versus time. Why? because acceleration must be positive and slope is constant, because in this case slope is constant and positive, means acceleration is constant and positive. And then this, because acceleration is negative, for this we say acceleration is negative because slope for this is negative and constant. Then here we say acceleration is positive, constant. Acceleration is zero. Acceleration is positive, constant. We are supposed to draw its velocity time graph. See guys, I'll show you. Acceleration is positive and constant. Velocity versus time. Means slope must be positive and constant. This slope is positive and constant. Then acceleration must be zero. Means velocity must be constant. So we say here velocity is constant and acceleration is zero. In this case, acceleration is positive and is constant. Why, sir? Because slope of this is positive and constant. Then again, acceleration is positive and constant. So again, acceleration is positive and constant. Oh, is this clear? Oh, is this clear? Please tell me in the chats. We are done with kinematics 1D. We're done with kinematics 1D. Now tell me in the chats, is this clear? Okay. That's great. Now we have kinematics 2D. Now, guys, let's move on to the projectile motion. Projectile motion is actually a two-dimensional motion. Let me just tell you, it is a two-dimensional motion. Let's suppose if I'm throwing an object something like this, it goes in air and then it falls onto the ground. Okay, this is called two-dimensional motion. We say in this particular case, body is moving along x-axis also Body is moving forward also. Let's suppose when the body is here, it has moved in x this much, and it has moved in y this much. Body is going forward also, body is going upward also. Yes. Now, my dear NEET aspirants, since body is moving along x as well as y, we will divide this motion. We say motion in x direction and motion in y direction. Yes, sir. Now, guys, let's suppose if I'm launching this object with a velocity u at an angle of theta, everybody knows that we can resolve the vector in two components. If this is u, this component is going to be u cos theta. This will be horizontal component of initial velocity. This component is going to be u sine theta. This will be uy, vertical component of initial velocity. Now, guys, if I say what is the initial velocity in x direction, you will say, sir, u cos of theta. Simply, I am saying, I am throwing an object in air. It follows the parabolic path with an velocity u at an angle of theta. A vector has two components. If theta is from this side, so this will be u cos, this will be u sine. Initial velocity in x direction is u cos. Initial velocity in y direction is u sine. Now, guys, if I say, is there any force acting on this object in x direction? No, there is no force. In projectile motion, force acting on the x direction is 0. Is there any force acting on the object in y direction? Yes, that is mg. Because if there is an object over here, is there any force acting on this in the downward direction? Yes, mg. If I say acceleration in x direction, you say that is force in x direction divided by mass. This is 0, so acceleration is 0. If I say acceleration in y direction, you say that is mg divided by g. Okay. Sorry, mg divided by m. Okay, that is force in y direction divided by mass. So this will come out to be g, and we consider it minus g. Okay. Then, my dear friends, if I say, let's suppose the body reaches here, this object reaches here. What is the velocity here? That is v. Now, this v will have two components, that is vx, and another component is vy. After some time, what is the velocity of this object in x direction, vx? We'll say, sir, u plus a into t. So we are applying this in x direction. When you have to find the final velocity in x direction, you will be using this equation in x direction only. Final velocity in x direction is equal to initial velocity in x direction plus acceleration into time. So you will be saying, sir, vx is equal to, what is ux? U cos of theta. And what is acceleration in x direction? That is 0. So means whatever is the value of initial velocity in x direction, same will be final velocity in x direction. Yes, horizontal velocity remains the same. If I say what is the final velocity in y direction, you say v is equal to u plus at, but you will be using this equation in y direction. Uy ay into t. Time is always same, okay, in x as well as in y. So this is vy is equal to initial velocity in y direction, u sine theta. Acceleration is minus g into t. This. Let's suppose if I say, sir, the object is here. How much is the displacement done in x direction and how much is the displacement done in y direction? X and y. So you'll be using Sx is equal to uxt plus 1 by 2 axt square. S is equal to ut plus 1 by 2 at square. Now, guys, in this particular case, we say Sx, displacement in x direction is x, is equal ux, initial velocity in x direction is u cos of theta, time is t, 1 by 2 ax is 0. So this is the displacement in x direction. If I say displacement in y direction, you'll be using Sy is equal uyt plus 1 by 2 ayt square. Now, displacement in y direction is y. Initial velocity in y direction, u sine theta. U sine theta. Time is t. Acceleration is minus g. So 1 by 2, because ay is minus g. 1 by 2 gt square. So you can consider this is displacement in y direction. Even my dear NEET aspirants, ladies and gentlemen, now can you find the value of this velocity? This velocity will be, sir, this Vx into I cap plus this Vy into j cap. Because you know Vx and Vy. So this velocity will be, what is Vx? That is u cos theta, u cos of theta into I cap plus what is Vy? Velocity final in y direction. That is u sine of theta minus gt into j cap. Yes. So this is going to be the velocity. Even you can find its magnitude also. That is under root of this square plus this square. Under root of this square plus this square. This is the velocity at any point. Now I need the signal in the chats. Is this clear? I need the signal in the chats. Is this clear? Everybody, guys. Everybody out there. Is this clear? Now it is all mentioned over here in a decent manner. Okay. If an object is thrown with velocity u at an angle theta, this will be initial velocity in x, u cos theta, initial velocity in y, u sine theta. Okay. Ux will be u cos theta, uy will be u sine theta. Okay. Everything, whatever I discussed recently. Okay. That is cool. So velocity at any point, that is also discussed. Okay. One more important thing. Sir, we got this Vx, we got this Vy. Can we find the value of this alpha? This is the angle made by the velocity at any point with the x-axis. So you can say, sir, this tan alpha, it is perpendicular by base Vy divided by Vx. What is the value of Vy? U sine theta minus gt. U sine of theta minus gt. What is the value of Ux? Vx? U cos theta. This is the value of tan alpha. This is the value of tan alpha. Okay. Yes. Now, guys, let's suppose, listen to me very carefully, or I'll directly show you here. Let's suppose if I say you are launching an object. See. I'll show you here. Let's suppose you are launching an object from here to here with velocity u at an angle theta. How much time it is going to take from here to here? That is what we call time of flight. How much time it is going to take from initial point to final point? That is time of flight. How high it can go? That is called maximum height. How far it can go? That is called range. That is called range. Now we need to find the value of maximum height, time of flight, and then range. Okay. First of all, time of flight. What does it say? It is the time taken by a projectile to complete its journey. Now, in order to find time of flight, we use this equation. S is equal to ut plus 1 by 2 at square in y direction. So in y direction means sy is equal to uyt plus 1 by 2 ayt square. Now guys, in this, after putting the values in this displacement in y direction, because if you are launching from initial point to final point displacement, so time of flight, you directly remember it is going to be 2u sine theta by g. U is the initial velocity, sine theta, u sine theta is the vertical component of the velocity divided by g. Okay, or you can call it like this also, 2uy by g. Uy means initial velocity in y direction. Ux means u cos theta. Okay. And you can say in this particular case, time upward, see. So if an object you are launching from here to here, So this is called upward time. It is u sine theta by g. Downward time is also u sine theta by g. You can call it like this. Okay. Now, if I say what is the speed at the maximum point, maximum height? See guys, see. Take a look. Take a look. At this point, at maximum height, this is the vertical component of velocity. This is horizontal component. Always remember this horizontal component remains the same. Vx is equal to ux is equal to u cos of theta. U cos of theta. Okay. And when I say Vy you recently got u sine of theta minus gt. Okay. U sine of theta minus gt. Okay. U sine of theta minus gt. Now, what is this t? T is the time of flight. Sir, what is the time of flight from bottom to top? That is u sine theta by g. So this is u sine of theta minus g into u sine of theta divided by g. This u sine theta, this u sine theta, that is 0. So vertical component of the velocity at topmost point is always 0. At highest point is always 0. At highest point is always 0. Okay. Then if somebody says, what is the maximum height? See. If you are launching an object, what is the maximum height covered by this project? You say maximum height is u square sine square theta by 2g. U sine theta means uy. U sine theta means uy. And if I say horizontal range, guys, horizontal range is going to be simply r is equal to 2u square sine square theta sine theta cos theta by g, or r is equal to u square sine 2 theta divided by g. We can solve all the questions by using this problem. See guys, if an object is launched from this point to this point, time is going to be u square sine square theta by 2g. U sine theta means uy square by 2g. If you say range is going to be u square 2 sine theta, or you can directly write it like this: 2 u sine theta u cos theta divided by g. Or range, another formula is, that is u square sine of 2 theta divided by g. This is also the formula of range, how far it can go. So this formula you can write as 2 u sine theta means uy, u cos theta means ux divided by g. And when it comes to h max, it is going to be u square sorry, this is 2u sine theta by g. Okay, so that is 2uy divided by g. When you say this is u square sine square of theta by 2g, and this is u y square by 2g. These are the formulas. Now tell me, is this clear? Is this clear? Is this clear? Okay. Now, guys, let's move on to the questions. There is a question of JE 2014. If an object is projected with a velocity of, there is an object which is projected. See guys, listen. There is an object which is projected with a velocity of u is equal to alpha I cap plus beta j cap, alpha I cap plus beta j cap. This object is projected with this velocity. Okay. Can I say in this particular case, if I say initial velocity in x direction is alpha, initial velocity in y direction is beta, ux is alpha, ui is beta, because this is the x component of velocity, this is the y component of velocity. Then it says find the time, height, maximum height, time, and range. When I say time, 2uy divided by g. So 2, what is the value of uy? 2 beta divided by g. What is the value of maximum height? H max. That is uy square divided by 2g. Uy square, that is beta square divided by 2g. When I say range, range is 2ux uy divided by g. That is 2. What is the value of ux? Alpha. What is the value of uy? Beta divided by g. Question is the question. At topmost point of a trajectory, the velocity and acceleration are at an angle of. See, guys, if a projectile is launched at topmost point, this is the topmost point. This is the velocity at the topmost point. Sir, what about vertical component? Vertical component at topmost point is 0. There is only one component, that is ux. That is ux. And acceleration is always minus g. What is the angle between velocity and acceleration at topmost point? So theta is equal to 90 degrees. Average velocity in projectile. Average velocity in projectile is initial velocity plus final velocity divided by 2. Okay. Now guys, we say initial velocity is u cos theta into I cap plus u sin theta into j cap. Okay. And final velocity will be u cos theta into I cap minus u sin theta into j cap. Okay. So simply when I say average velocity in this particular case, you'll be saying it is u cos. Okay. Yes. This is the average velocity in projectile motion. If I say change in velocity, it is going to be final velocity minus initial velocity. It is going to be final velocity minus initial velocity. Okay. So final velocity is this, initial velocity is this. So you simply say it is minus 2u sin theta into j cap. 2u, after simplifying this, 2u sin theta into j cap. Okay. Okay. Now guys, let's take a look at this question. See guys what the question is. A ball is projected from a point with a velocity 20 meter per second at an angle of 60 with the horizontal direction. At the highest point B, the velocity is. See guys, it says that an object is launched with a velocity of 20 meter per second at an angle of 60 degrees. Then it says at highest point its velocity is. At highest point there is only one velocity, that is Vx is equal to ux is equal to u cos of theta. At topmost point only one component of velocity is present because Vy is 0. So u is 20 and then we say cos of theta is 60. So this will be 20 into cos 60 is 1 by 2. 2 ones are, this is going to be 10 meter per second. So at topmost point velocity is 10 meter per second. Okay, is this clear? Is this clear? Or is this clear? Tell me in the chats, everybody out there. A bullet, NEET 2023. A bullet is fired from a gun at a speed of 280 meter per second. Okay. A bullet is fired from a gun at a speed of 280 meter per second. 280 meter per second is the initial velocity. At an angle of 30 degree with the horizontal. At an angle of 30 degree with the horizontal. The maximum height attained by it will be. The maximum height attained by it will be. Guys, H max, how high it can go. This u square sine square of theta divided by 2g. What is u square? That is 280 into 280. Okay, sine square of theta. What is sine square of theta? Sine 30. So sine 30 is 1 by 2. Sine square of 30 is 1 by 4. Into 2 into g is, we say, sir, 10. Solve it, it will approximately come out to be 1000 meters. 1000 meters. A projectile is fired at 30 degree from the horizontal with an initial velocity of 40 meter per second. The velocity of the projectile at t is equal to 2 seconds from the start will be. Okay. Now, guys, what does the question say? The question says that you have launched a projectile at an angle of 30 degree with a velocity of 40 meter per second. Okay. Now, guys, please tell me what is the upward time in this particular case. Upward time is u sine theta by g. Upward time means how much time it is going to take till the topmost point. That is u sine theta by g. And total time is 2u sine theta by g. U is 40. Then we say sine of 30 divided by g is 10. This and this will cancel. So 4 into sine 30 is 1 by 2. So this will come out to be 2 seconds. So means from bottom to top, it is going to take how much? 2 seconds. Then it says the velocity of the particle projectile at t is equal to 2 seconds. Oh, it says velocity at t is equal to 2 seconds. Velocity at t is equal to 2 seconds means velocity at top. At t is equal to 2 seconds, it is topmost point. Topmost point. So at topmost point, when it comes to the velocity, that will be u cos of theta. At topmost point, there is only one velocity, that is horizontal velocity. So that will be u is 40. Then we say cos of 30. Cos 30 is root 3 by 2. So that is 40 into root 3 by 2. 2 ones are, 2 20s are. So this is 20 root 3. Is this question clear? Please tell me in the chat. So, is this question clear? Please tell me in the chats. The maximum height reached by a projectile is 64 meters. If the initial velocity is halved, the new maximum height of the projectile will be. See guys, see guys. What is the maximum height? Maximum height is u square sine square of theta divided by 2g. Now guys, see, in this particular case, we said this maximum height is proportional to u square. What does the question say? Question says that the maximum height reached by a projectile is 64 meter. There is a projectile, it is covering the maximum height of 64 meters. When let's suppose speed u1 is u, then it says that if the speed u2 becomes u by 2, if it is halved, what is going to be the maximum height? This is the question. So can I not use h1 divided by h2 will be equals to h1 is proportional to u1 divided by u2 and it is whole square. Yes. What is the value of h1? 64 divided by h2 is equal to u1 by u2. What is the value of u1? That is u upon u divided by 2 whole square. Okay. So this and this will cancel. This 2 will go in the numerator. It will become 2 square is 4. If I say h2 will come out to be, that is going to be 64 divided by 4. That is going to be 16 meters. That is going to be 16 meters. Now see, object is projected with velocity v is equal to 30 I cap plus 40 j cap. Guys, this is the velocity of an object, initial velocity. Object is projected with a velocity of v is equal to 30 I cap plus 40 j cap. So can you tell me what is the value of ux? 30. What is the value of uy? That is 40. Then it says find the angle of projection theta. You guys are supposed to find maximum height, time of flight, range. Let's first find maximum height. Okay. Let's first find maximum height. That is uy square divided by 2g. What is the value of uy? That is 40 into 40 divided by 2g. 2 into 20. This and this will cancel. Oh, sorry, 2 into 10 is 20 in total. This and this will cancel. 2 ones are 2, 2s are 4, 2 zeros are 0, 2 4s are 8. That is 80 meters. When I say time of flight, that is 2uy divided by g. That is 2. What is the value of uy? That is 40. G is, we say 10. This and this will 2 4s are 8 seconds. When I say range, range is going to be 2 ux uy divided by g. So 2. What is the value of ux? 30. What is the value of uy? 40 divided by what is the value of g? G is 10. This and this will cancel. Now guys, 2 4s are 8 into we say sir 30. 240 meters. Okay. Then it says, guys, if it is u, see, this is theta. We know that this is the horizontal component of velocity, that is ux. This is the vertical component of velocity, that is uy. Could you please tell me what is the value of tan theta? That is perpendicular by base, that is uy divided by ux. So you guys will write over here tan theta is equal to what is the value of uy? 40 divided by 30. So means 4 by 3. Now make a triangle. So this is 4, 3, 5. This is 53 degrees. This is a 53-degree triangle. In case of 53-degree triangle, we say tan 53 is 4 by 3. So instead of 4 by 3, what you can write over here? Tan of 53. Tan will cancel, so theta will come out to be 53. Is this clear? Please tell me in the chats. Oh, is this clear? Two objects are thrown up at an angles of 45 degree and 60 degree respectively. Okay. Two objects are thrown up at an angles of 45 degree and 60 degree respectively with the horizontal. If both attain the same maximum height, guys, h1 is equal to h2. You are throwing two objects, this one, this one. This is at an angle of 45, this is at an angle of 60. It says both attain the same vertical height. If both attain the same vertical height, how can we say u1 square sine square of theta 1 divided by 2g is equal to u2 square sine square of theta 2 divided by 2g. This and this will cancel. So u1 divided by u2 whole square is equal to sine of theta 1 divided by sine of theta 2 divided by sine of theta 1 whole square. Guys, u1 divided by u2 whole square is equal to sine of theta 2 divided by sine of theta 1 whole square. So can I not say u1 divided by u2 square will go sine of theta 2, that means sine of 60 upon sine of theta 1, that is sine of 45. So the question says that find the ratio of velocities u1 by u2 we have to find. So u1 divided by u2 will come out. Guys, it says you have got two projectiles at an angle of 45 at an angle of 60. Both are attaining same maximum height. Then it says this velocity is u1, this velocity is u2. You have to find the ratio of u1 and u2. So sine 60 root 3 by 2, sine 45 1 by root 2. So how can you write this? Root 3 by 2 into root 2 divided by 1. Now what you will do in this particular case is, that is root 3 divided by 2 into root 2 divided by 1, multiply with root 2 and divide with root 2. Now root 2 into root 2 is 2, that 2 will cancel with this. So what is the answer? That is root 3 divided by root 2 is the ratio. Root 3 by 2, yes. See guys, I'll tell you something. What is the range? 2ux uy divided by g. What is maximum height? uy square divided by 2g. Okay. This is range and this is maximum height. Now do one thing. Do this h divided by r. Divide both. So this is uy square by 2g divided by 2ux uy divided by g. This g and g will cancel. Uy and square will cancel. What will remain? Uy divided by 2 upon, we said 2 times of ux. We can write it like this. 2 into 2 is 4. Uy divided by 4 times of ux. Now guys, tell me one thing. If you launch a projectile at an angle of, with velocity u at an angle of theta, this will be ux, this will be uy. Could you please tell me what is the value of tan theta? That will be uy divided by ux. Yes. So take a look at this equation. This is h divided by r is equal to uy divided by 4 times of ux. Now instead of uy by ux, can we put tan theta? Yes. H divided by r is equal to tan of theta divided by 4. H will be equals to, take this r over here, r tan of theta divided by 4. This is what we call the relation between horizontal range and maximum height. This is the relation between horizontal range and maximum height. What is the relation between horizontal range and maximum height? r tan theta by 4. Take a look at the question. J 2024. The angle of projection for a projectile to have the same range and maximum height. There is a projectile, its range is exactly equal to the maximum height. Whatever is the range, same as maximum height. We have to find its angle of projection. We have to find the value of theta. See, we say h is equal to r tan of theta divided by 4. You say h is equal to, instead of r, you will be putting h. Tan of theta divided by 4. H and h will cancel. So we say tan theta will be equals to 4. So theta will be equals to tan inverse of 4. Okay. The horizontal range of a projectile is 4 root 3 times its maximum height. Horizontal range of a projectile is 4 root 3 times its maximum height. Range is equal to 4 root 3 times its maximum height. The angle of projection is, what is theta? Guys, see, h is equal to r tan of theta divided by 4. H is equal to, instead of r, 4 root 3 h. Then we say tan theta divided by 4. 4 and 4 will cancel, h and h will cancel. So what is the value of tan theta? 1 by root 3. If you take this root 3 over here. Now, when is the value of tan theta as 1 by root 3? We say tan of 30 degrees. Tan of 60 degrees. Tan 30 or 60? 30. So theta will be equals to 30 degrees. Is this clear? For an object projected from the ground with the speed u, horizontal range is 2 times the maximum height. Okay. A range is equal to 2 times maximum height. The range of the projectile, range of the object is, we are supposed to find range. See, in this question, it says that you are launching a projectile in which range is equal to 2 times maximum height. And then you have to find what is the value of range. Wait, I'll tell you. First and the foremost thing is, we say h is equal to r tan of theta divided by 4. So we say h is equal to, instead of r, you can write 2h divided by tan of theta upon 4. 4, 2 ones are 2, 2s are 4, h and h will cancel. So tan theta came out to be equals to 2. You can say 2 by 1. So what is the value of tan theta? Perpendicular divided by base. Means if you make a triangle over here, this is theta. This perpendicular is 2, this base is 1. What is going to be the hypotenuse? Under root of 2 square plus 1 square, that is root 5. Okay. So from this we got the value of tan theta. Now can you find the value of sine theta? Sine theta is perpendicular upon hypotenuse, 2 by root 5. What is the value of cos theta? That is 1 by root 5. Then my dear friends, if I say range, that is 2ux uy divided by g. So range is equal to 2, value of ux. And we can write it like this also. That is 2. Ux is u sine theta, u cos theta divided by g. Now what is the value of u sine theta? U is u. Instead of sine theta, we can write 2 divided by root 5. Okay. Then cos theta, 1 divided by root 5 divided by g. Now guys, this will be 2 into 2 is 4. It is 4u divided by root 5 into root 5 is 5, 5g. This is the answer in this particular case. Okay. Okay, u into u is u square, because this is u square. U into u is u square. Yes, 4u square by 5g. Oh, understood. Tell me. Yes, we'll take the break. Break till 12:25. Check, check, check. Now, guys, conditions for maximum horizontal range. See, we say, what is the formula of range? U square sine of 2 theta divided by g. Let's suppose, my dear friends, if we keep the initial velocity same for two different projectiles, like let's suppose you are launching this projectile, you are launching this projectile. Initial velocity for both is same. U is same. U is same. Okay. And G is same for both. G is same for both. Yes. So can I not say in that case, we say this range will depend upon, then range only depends upon sine theta. Then this range will depend upon sine theta. Okay. So if range depends upon sine theta, means sine theta itself depends upon theta. Okay. Now, my dear friends, if this range depends upon sine theta, okay. So if you want range to be maximum, then the value of sine theta has to be maximum. If we want range to be maximum, then the value of sine of 2 theta has to be maximum. And what is the maximum value of sine theta? That is 1. So we say sine of 2 theta is equal to 1. Sine of 2 theta is equal to 1. And we say sine of 2 theta is equal to, instead of 1, I can write sine of 90. So 2 theta is equal to sine cancels, 2 theta is equal to 90, theta is equal to 45. So we say this sine theta is maximum when theta is equal to 45. So at 45 degree, we say range is maximum. Now, my dear friends, from now onwards, you are going to remember that if you want the range to be maximum in case of a projectile motion, then you need to put this angle as 45 degrees. You need to keep the angle as 45 degrees. Keep that thing in your mind. Okay. And if you ask me how much is the range, guys, range, maximum range is U square sine of 2 into theta. Instead of theta, you have 45. 2 into 45 is 90. Sine 90 is 1. So maximum range is U square by G. Maximum range is U square by G. Okay. Is this clear? Is this clear? Tell me, guys. Now, guys, if R is the maximum horizontal range of a projectile, then the greatest height attained by it will be, guys. If R is the maximum horizontal range, what is the value of theta? 45. Because when theta is 45, then only range is maximum. So what I can say over here, this range will be equal to, we say as this maximum height is equal to R tan of theta divided by 4. It says if R is the maximum horizontal range, then what is the value of height, greatest height attained by the object? You'll say, sir, this H is equal to R. I can say tan of 45 divided by 4. Okay. So this height is going to be R by 4 in that particular case. Okay. Yes. Now, guys, range for two different angles is same. Remember this point directly. If I say I'm launching a projectile at an angle of theta, and I'm launching another projectile at an angle of 90 minus theta, we say range in both the cases will be same. If I say a range in this particular case is R, we say range in this case will be also R. Range in both the cases will be same. Okay. Range in both the cases will be same. Okay. Like if I say, if the value of theta is 30 degrees, what is the value of 90 minus theta? That is 90 minus 30, that is 60. So whatever is the range at an angle of 30, same will be at an angle of 60. If I say value of theta is 40, what is the 90 minus 40? That is 50. So whatever is the range at 40, same will be at 50. Whatever is the range at 80, same will be at 10. This is what we call range of for two different projectiles. Same. Next is angle of elevation. What is angle of elevation? See guys, let's suppose you are launching a projectile. This is the path of the projectile. Now this is the initial point from which you have launched this particular projectile. This is the initial point. And this is the topmost point. If you join this initial point and topmost point, this angle, this is what we call angle of elevation. See guys, there are two things. This, if you are launching this object with velocity u, this angle is what we call theta. This is called angle of projection. But this is called angle of elevation. And in this particular case, guys, if this is r, don't you think half of this is r by 2? Yes. So can you tell me what is the value of tan alpha? That is h upon r by 2. Perpendicular divided by base. Tan alpha is h upon r by 2. So tan alpha is 2h divided by r, where alpha is the angle of elevation and theta is the angle of projection. Okay. Okay. Now guys, a projectile is fired at an angle of 45 degrees with the horizontal. So theta in this case is given as 45 degrees. It says angle of elevation of the projectile, at its highest point as seen from the point of projection is. You have a projectile. You have launched this projectile at an angle of, I would say, 45 degrees. It says you guys are supposed to find what is the angle of elevation over here. You'll be simply saying, when it comes to the angle of elevation, that is tan alpha is, we say 2h divided by r. Okay, 2h by r. Now guys, in this particular case, we say as, what is the value of h? That is r tan of theta divided by 4. We'll be putting it over here. So this tan of alpha will come out to be, that is r. Instead of tan alpha is equal to, instead of h, it is going to be r tan of theta. What is tan of theta? Tan 45 divided by 4. 2 1s are 2, 2s are 4. Tan 45 is 1 because theta in this case is given as 45. So what is the value of tan alpha? That is going to be r. Tan 45 is 1. So this is going to be r by 2. Okay. Yes. This is going to be r divided by 2. A projectile is fired at an angle of theta, at an angle of 45 with the horizontal. Angle of elevation at the point tan theta by 4. Okay. Oh, ho, 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 ho. I missed this. You have got this r. Guys, see. H is equal to r tan theta by 4. Put it over here. Put this h in this one. So what you can say, tan of alpha is equal to 2 divided by r. Then instead of this h, you'll be putting r tan of 45 divided by 4. 2 1s are 2, 2s are 4. R and R will cancel. So what I can write over here, tan alpha is equal to tan 45 is 1, 1 by 2. So alpha will be tan inverse of 1 by 2. This is the angle of elevation in this case. Equation of trajectory. Equation of trajectory. What does equation of trajectory actually mean? See guys, see guys, see guys. If I say a car is moving according to this, x is equal to t. A car is moving something like this, x is equal to t. Plot this position time graph. Plot this position time graph. You'll be like, sir, its position time graph will be the straight line. Because when time is 1, x is 1. When time is 2, x is 2. When time is 3, x is 3. Yes. Now, if I say y is equal to x, sir, plot this y versus x. So it will be the straight line. If I say y is equal to x square, plot it something like this. Now, my dear friends, listen to me very carefully. If you launch a projectile, it will go something like this. It follows this parabolic path, downward parabolic path. Okay, something like this. If I ask you, what is the equation of this graph, equation of this trajectory? Okay. And it tells you the relation between y and x. It tells us the path of the projectile. What is the path of this projectile? What is the equation of this graph? Equation of this graph is y is equal to x tan theta minus 1 by 2 gx square x square upon u square cos square of theta. Directly remember this. Or you can remember it like this. Okay. Y is equal to x tan theta 1 minus x divided by r. You can keep it like this. You can keep it like this. Because this will, equation of trajectory is nothing but, it is the equation which tells you the path of the projectile. What is the equation of this curve? That is this equation or this equation. Simply, it tells you the relation between y and x. Okay. Okay. See guys, the equation of a projectile is given as this. Y is equal to root 3x minus gx square divided by 2. We have to find the angle of projection. We are supposed to find the value of theta. See guys. What I want you guys to do in this particular case is, I want you guys to make it like this. Y is equal to x tan of theta 1 minus x divided by r. Equation of trajectory. I want you guys to make it like this only. Okay. Now see, how can you make it? You can do one thing. You can take this x tan theta, you can make it like this only by taking this root 3x common. But before that, you need to do one thing. Multiply with root 3 and divide with root 3. Now see, now you can say y is equal to root 3x. Now you can take common. So what remains here? 1 minus. Here root 3x you are taking common. So what remains? We say gx divided by 2 root 3. Gx divided by 2 root 3. Okay. Because root 3x into gx, that is gx square into root 3. Once again. Now if you compare with, we say y is equal to x tan of theta 1 minus x divided by r. Clearly you can say in this particular case, what is the value of range of this projectile? 2 root 3. And what is the, here it is x, here it is x, here is tan theta, here it is 3. So we say value of tan theta is equal to root 3. When is the value of tan theta is root 3? When theta is equal to 60 degrees. So this is it that you were supposed to calculate. The equation of a projectile is something like this. Y is equal to 16x minus x square divided by 4. Now guys, do one thing. Whatever is here, with x, what was in multiplication? Root 3. That's why we multiplied and divided with root 3. What is in multiplication in x? So multiply with 16 and divide with 16. So then compare with. No, do one thing. You can write it like this. Take this 16x common. So it will be 1 minus. What remains over here? That is x divided by 16 into 4 is 64. Now tell me, compare with y is equal to x tan theta 1 minus x divided by r. Now, from this particular question, we are supposed to find range. A crystal clear range is 64 meters. Your range 64. I hope this is crystalline clear. I hope this is crystalline clear. Take a look. Find the height h in the given figure. There is a projectile launched. When projectile reaches here, its coordinates are 5, comma h. So this is x, comma y. X, comma y. You are supposed to tell me what is the value of this h height. See guys, we say as equation of trajectory. What is the equation of trajectory here? What equation does this projectile follow? We say y is equal to x tan theta 1 minus x divided by r. This is the equation of trajectory. Now, what is the value of x over here? 5. So you can say instead of y, what is the value of y? That is h is equal. What is the value of x over here? That is 5. Okay. Then you can say in this particular case, this is tan of theta 1 minus, what is the value of x? X is 5 divided by, what is the value of r? Range is given as 7. So this height will come out to be, that is 5. We say tan of theta 7 minus 5, that is 2 divided by 7. 5 2s are 10. So this is 10 tan of theta divided by 7. This is the value of height. This is the value of height. J 2023. The equation of trajectory is given as the maximum height attained by the projectile is this. The see guys, y is equal to, guys, this is x minus x square by 20. Do one thing, take x common. 1 minus x divided by 20. Okay. And in this particular case, guys, compare with y is equal to x tan theta 1 minus x divided by r. Now clearly x, here it is 1, here it is tan theta. So value of tan theta is 1 and value of range is 20. Okay. Then it says what is the maximum height attained by the projectile. Guys, tan theta you know, r you know. We say h is equal to r tan theta by 4. So what you can say in this particular case, this is, what is the value of r? That is 20. Tan theta is 1 divided by 4. It will come out to be 5 meters. Now guys, take a look. Horizontal projectile. Horizontal projectile is nothing but if you launch an object from certain height, then it follows this path. If you launch an object from certain height, then it follows this path. It is called horizontal projectile. Okay, this is horizontal projectile. When a projectile is launched from certain height, it is called horizontal projectile. Now see, initially if you check over here, the entire velocity is in the horizontal direction because we are throwing the projectile horizontally, completely horizontally. Okay. Let me show you over here. This is the object that you are throwing horizontally initially, something like this. Now guys, here the body moves in the x direction as well as in y direction. Body moves forward as well as as it is coming down. Yes. Now, in this case also we divide it in x direction and y direction. See guys, when I say initial velocity in x direction, that is u. When I say initial velocity in y direction, that is 0. There is no initial velocity in y direction. The velocity is x only. Okay. And my dear friends, when I say acceleration in x, that is 0. When I say acceleration is y, that is minus g. When I say velocity, let's suppose after some time body reaches here. It has velocity v. Here this velocity is vx, this velocity is vy. And let's suppose this angle over here is alpha. So what I can say in this particular case, this vx will be final velocity in x, that is u plus a into t, ax ux. Acceleration in x is 0. Vx is equal to ux. What is the value of ux? That is vx will be equals to u. Vx will be equals to u. Okay. And when I say vy, it is uy plus ay into t. Ay in this case is 0. Oh. Sorry, I made a mistake. Uy in this case is 0. So final velocity in y direction, acceleration, this is minus g into t. You can write it like this. Okay. Okay. Then even you can find this displacement in x direction also. How far it has moved is moving at x. So sx is equal to uxt plus 1 by 2 axt square. So acceleration in x is 0. So sx means x is equal to uxt, that is u into t only directly. Displacement in y, this y. So sy is equal to uyt plus 1 by 2 ayt square. Initial velocity in y direction is 0. This is y is equal to minus 1 by 2. Acceleration in y direction is gt square. Okay. Even you can find the value of this tan alpha also. Tan alpha is this perpendicular, that is vy, this base, that is vx. What is the value of vy? Gt. Base is u, gt by u. All of this is mentioned here. Ux is u, uy is 0. Initial acceleration 0, initial velocity in initial acceleration in y direction is g, minus g. So it is completely discussed over here. Okay. Then guys, in this particular case, if you throw an object, we say horizontally, how much time it is going to take in completing this journey? This time, this is the derivation over here. This time is under root of 2h by g directly. This is the time taken by a projectile, horizontal projectile, that is under root of 2h by g. And clearly, guys, this time does not depend upon initial velocity or mass of an object. So means if you throw a velocity object with u, if you throw another object with 2u, if you throw another object with 3u, we say all will have the same time of flight. If this is taking 10 seconds to here till here, 10, 10, all will take same 10. Then range. Range means how far it can go, This range means initial velocity u into under root of 2h by g. Okay, this is going to be the range. And clearly you can see this also over here. In order to find this time of flight, you use s is equal to ut plus 1 by 2 at square in horizontal direction. So when the object comes down, when it reaches ground, displacement in y direction is in y direction we are applying, that is minus h. Initial velocity in y direction is 0, minus 1 by 2 gt square. From this you got the value of time. Simple. This is the range, horizontal range. And I told you velocity at any point, tan alpha is equal to gt divided by u. Velocity at this point, guys, see, velocity at this point will be final velocity I cap, final velocity j cap, velocity in y, finally j cap. So v is equal to initial velocity in x is ui cap. Okay. Yes, it will be ui cap. Final velocity in y is minus gt j cap. Okay, something like this. Even you can find its magnitude also. That will be under root of u square plus gt square, gt whole square, something like this. Here it is mentioned. Now, guys, this is the velocity with which it strikes the ground. This is called the velocity of hit. Let's suppose this object you are throwing with velocity u, and this will go, and it will strike the ground over here. It will strike the ground with a velocity v. This will have horizontal component vx, that is u, because horizontal component remains the same. It does not change. And vertical component at this point we need to calculate. See guys. How do you find vertical component? Horizontal is same. Vertical is uy minus at, acceleration in y direction. Now guys, uy is 0, remove this. So vy is equal to acceleration in y direction, that is g, and time. How much time it is going to take from here to here? That is under root of 2h by g. Recently we studied. Now multiply with root g and divide with root g. Root g into g is g. So that g will cancel with this g. So it will be vy is equal to under root of 2gh. So here it is going to strike with under root of 2gh. Now, final velocity at this point, it will be vx into I cap, vy into j cap. That is ui cap plus root 2gh j cap. And if we find its magnitude, that will be under root of this square plus this square. This is done. So these are two different things, my dear friends. This is velocity at any point. At any point, horizontal component is u only. Vertical component is gt. But this is velocity of hit. When it strikes the ground with velocity v, this is horizontal component, this is vertical component, that's under root 2gh. These are the two different statements. Now take a look. See guys, what does the question say? A ball is projected with 30 meters per second in a horizontal direction from certain height. Let's suppose this is the height. A ball is projected horizontally with 30 meters per second from certain height and it will fall down. Find the time when it is making 45 degree with the horizontal. Let's suppose here this ball is making 45 degree with the horizontal. Let's suppose here this ball is making 45 degree with the horizontal. We have to find what is the time at this point. How much time the ball has taken from this point to this point. Let's suppose this is v, this will be vx, and this component will be vy. And we know that, sir, tan alpha means tan of 45. It will be this vy by vx. Vy is gt, vx is u. Tan 45 is 1, g is 10, t is t upon u. Initial velocity is 30. This and this will cancel. So t will come out to be 3 seconds. So at t is equal to 3 seconds, it will make 30 degree with the horizontal. 30 degree with the horizontal. A bomber plane moves horizontally with a speed of 500 meters per second. There is a bomber plane It moves with a speed of 500 meter per second. And a bomb is released from it, strikes the ground in 10 seconds. We say a bomb is released from it. So if this is moving with 500 meter per second, this is also moving with the same. It will strike the ground, okay, in 10 seconds. Time is given as 10 seconds. Find the angle at which it strikes the ground. Okay, we are supposed to find the angle at which it strikes the ground. See guys, here it will strike with the velocity v. This component is going to be vx, this component is going to be vy. And when I say, guys, see, velocity of hit recently we studied. In this particular case, when you say velocity of hit, horizontal component is u, vertical component is under root of 2gh. So you say this horizontal component vx is equal to u, that will be 500. And then we say vy, it is under root of 2gh. It is under root of 2, value of g is 10, and height, the speed of this 2gh. What can I do in this one? Okay. We are supposed to put this directly. We say, guys, when it comes to the tan of alpha, it is simply vy divided by vx. That is u divided by gt. Here we need to apply this. Find the angle at which it strikes. Okay. So what I can write over here, tan of alpha is, this u is given as 500. Sorry, it is gt by u. gt divided by u. So g is how much? G is 10. And time also is given as 10. 10 into 10. Divided by this is 500. So this will be 100 divided by, we say 500. This and this will cancel. So tan of alpha is 1 by 5. Directly. Tan of alpha is 1 by 5. Okay. This I'll give you as homework over here. This is a good question. Now guys, take a look. Relative displacement. It is going to take, session will end mostly at 3 a.m. 2 to 3, between 2 to 3. Now guys, take a look. Relative displacement. Let's suppose if I say This is the origin. With respect to the origin, the car has traveled from to point A and then to point B. Car has traveled from point A to point B. If I ask you, what is the displacement of the car with respect to the origin? You say, sir, that is XA. Sir, with respect to the origin, its displacement is XA. When it is A, car A. What is the displacement of car B with respect to the origin? These are two cars, A and B. That is XB. Because here this is XB, this is XA. Now, if I say, what is the displacement of A with respect to B? What is the displacement of this car A with respect to B? Means this displacement. That is basically XA. This is how we write that. Displacement of A with respect to B. That is XA minus XB. Okay, that is XA minus XB. And displacement of B with respect to A. Displacement of B with respect to A. That is XB minus XA. So that is how we write it. That is XB minus XA. XB. Okay. So if I say displacement of this car with respect to this car, you write it like this: XAB. Displacement of A with respect to B. That is XA minus XB. This is what we call relative displacement. What is my displacement with respect to somebody else? What is displacement of that person with respect to somebody else? Okay. Similarly, displacement of B with respect to A. Displacement of B with respect to A. That is XBA. XB minus XA. Now, take a look. Now you have relative velocity. Now you have relative velocity. See guys, what does relative velocity mean? Let's suppose I have got a car over here, it is moved with velocity v. And there's another car over here, it is moving with velocity v. If I say, what is the velocity of B? What is the velocity of this B? With respect to how fast this, how fast this car B is moving, how fast this car B is moving, with respect to, you'll say something like this: velocity of B, VBA, that is velocity of B minus velocity of. Similarly, velocity of car A with respect to B, that is VAB, that is VA minus B. This is called a relative velocity. Sorry. Wait. See, we have relative velocity. Guys. You have got car A, its velocity is VA. You have got car B, its velocity is VB. If I say, what is the velocity of this car B with respect to A, according to this A, you write it like this: velocity of B with respect to A, that is velocity of B minus velocity of A. Similarly, if I say, what is the velocity of this car A with respect to B, you say VAB, that is velocity of A minus velocity of B. This is actually relative law. Relative displacement is what is the displacement of this person with somebody else. Relative velocity is what is the velocity of this person with somebody else, with respect to somebody else. Similarly, relative acceleration. Acceleration of A with respect to B, that is acceleration of A minus acceleration of B. Okay. Yes. Like, take a look over here. Case 1. Let's suppose there is a car which is moving with 5 I cap forward. Car B is moving with 10 I cap. What is the velocity of A with respect to B? You say, sir, that is velocity of A minus velocity of B. So velocity of A is how much? That is 5 minus velocity of B is how much? That is 10. Okay. So that is going to be 5 minus 10 is minus 5. Minus 5, I would say I cap. Okay. Okay. It is obvious. Let's suppose this car is moving with a velocity 10. This car is moving with a velocity 5. Velocity of A with respect to B. According to B, what is the velocity of A? So means here B is observing. So when B is moving faster, it feels like the car which is moving slowly, it is going behind. But in reality, that is also moving in the same direction, but it feels like that is going behind. Velocity of A with respect to B, that is VA minus VB. So that is 10 minus 10, that is 0. So basically, if the two cars have got same velocity, they are moving parallel to each other. We say in that case, they cancel each other. We say net velocity in that case will be 0. VA minus VB will be 0. Then you have got case 3. Here, this car is moving with 10 meter per second. This car is moving with 10 meter per second in the opposite direction. Velocity of A with respect to B. So this is 10, velocity of A. And velocity of B is minus 10. So this is minus of minus 10. This is going to be plus 20 meter per second. So basically, when the two cars cross at that point of time, it feels like they are crossing with a huge speed. Speed gets doubled. It is because of the relative motion. Velocity of A with respect to B, that is 20. Okay. Yes. A train of 150 meter long. A train of 150 meter long. Okay. Is going towards north. Let's suppose we have got a train over here. Let's suppose we have got a train over here. This is a train. This is a train. And this is 150 meters long. It is going towards north. Let's consider this direction is north. Okay. With a speed of 10 meter per second. So velocity of train is 10 meter per second. A bird is flying with 5 meter per second to the track towards south. Means a bird. It is flying opposite. 5 meter per second. This is velocity of bird in the opposite direction, south. Okay. The time taken by the bird to cross the train is how much time this bird is going to take to cross the train from here to here. We are supposed to find the value of time. Now, guys, in order to find the value of time, we said time is actually displacement upon velocity, because velocity is displacement upon time. But velocity here, you guys need to take relative velocity. That is velocity of bird with respect to train. Velocity of bird with respect to train. So that is velocity of bird minus velocity of train. Okay. Because here, this bird is crossing the length of the train. So you have to check what is the velocity of this bird according to the train, with respect to the train. So velocity of bird is minus 5 minus velocity of train is 10, because this is 10 plus 10. Minus 5 minus 10 is minus 15. Okay. Now if I say time, so time is going to be displacement, that is 150. Displacement is 150 divided by, this is 15. Yes or no? 5 3s are 15. 5 3s are 15. 5 zeros are 3 1s are 3 10s are. So this is 10. 10 seconds. Yes or no? Yes. A bus is moving with a speed of 10 meter per second and a car wishes to overtake in 100 seconds. There is a bus. This is moving with a speed of v is equal to 10 meter per second. Okay. A car wishes to overtake in 100 seconds if the bus it has a distance. Okay, there is a car. This car wants to overtake this bus, which is at 1 kilometer. That means 1000 meters. Okay. In I would say in how much time? We say 100 seconds. With what speed should the car chase the bus? What is the speed of the car? That is what we are supposed to find. This is velocity of the bus. This is velocity of the bus. Tell me, guys, solve this question. Tell me. Tell me. Same approach like we used in the previous question. What is that? What is that? Guys, we said time is equal to displacement upon velocity. But velocity we need to use over here relative velocity. How much time it is going to take in order to catch the bus. So see guys, when I say velocity of car with respect to bus, that is going to be velocity of this car minus velocity of bus. Okay, velocity of car with respect to bus. So velocity of car minus velocity of bus, that is 10. This is velocity. Now put it over here. Put it over here. So time in this case is 100 seconds. Distance is 1000 meters upon. And this is over here velocity of car minus we say sir 10. Now 0, 0, 0, 0. So this will be over there. VC minus 10 is equal to 10. So take it over there. Velocity of car must be equal to 20 meter per second. Then only it can cross the bus in 100 seconds. Clear? Okay. This is your homework. This is your homework. These two questions, this one and this one. Okay, one more important thing. See, what does the question say in this particular case? Have you ever seen this escalator which is present in the malls, in the metro stations, in the airports? That escalator in on which if the person stands over here, this escalator takes the person up. Okay, that stair which moves, a moving stair. Yes. Now let's suppose there is a person over here. Okay. Okay. And this escalator is not working. And the distance of this escalator is S. Now the person has to reach the top. How much time it is going to take? How much time it is going to take? Or can I say if the velocity of the person, we say velocity of the person will be distance upon time. Distance is S and time is T1. So what is the value of time from this one? So value of T1 is going to be, that is S upon velocity of person. Yes. Now let's suppose if the person stands over here and escalator is moving. So what is the value of time? How much time it is going to take in reaching the top? We say this T2 in this particular case will be, that is displacement is S, velocity of escalator is VE. Right now escalator is moving and here person is moving. Let's suppose if both are moving, escalator is also moving and person is also moving. So in that particular case, can I not say velocity of person plus velocity of escalator will be equals to S upon, we say sir, time T? Yes or no? Yes. Now, velocity of person plus velocity of escalator. Velocity of person is S by T1. Velocity of escalator is S by T2. So what I can write in this particular case, my dear NEET aspirants, so I can say here S by T1, S by T2, and here it is going to be S by T. S and S will cancel. 1 by T is equal to T1 plus T2 upon T1 into T2. So value of T will come out to be something like Okay, so now this is, read the question. Preeti reached the metro station and found escalator is not working. She walked up by the escalator in time t1. She walked up by the escalator in time t1. Next day, she remains stationary on the moving escalator and takes time t2. Next day, she remains stationary and escalator takes her up in time t2. Next day, both escalator and Preeti walks and takes time t. Next day, both are moving, Preeti as well as escalator, and takes time t. Here it is not time t1, it is time t only. Okay, it is taking time t only. Okay, and then the question says find the relation between t1, t2, t1 and t2. You are supposed to tell me the relation. So relation is this: t1 t2 upon t1 plus t2. Yes, this is the relation actually. Okay, is this clear? Tell me in the chats, everybody out there. Tell me, guys, quickly. Now, guys, let's talk about relative motion in 2 dimensions. Let's talk about relative motion in 2 dimensions, in 2D. See, listen carefully. Let's suppose this is a bird over here. This bird is moving with 5 meter per second at an angle of 37 degree with the horizon. Can I say this bird, it will have horizontal component, that is 5 cos of 37, vertical component 5 sin 37. Sir, cos 37 is 4 by 5. 5 and 5 will cancel, so it will come out to be 4i cap, because this component is in x direction. Sir, sine 37 is 3 by 5. So 5 will cancel, so it will come out to be 3j cap. Now, guys, this bird has horizontal component of velocity is 4, vertical component is 3. So velocity of bird I can write 4i cap plus 3j cap. Yes. Now there is another person over here, A. It has velocity 4i cap. There is another person over here, C. It has velocity 3j cap, vertical direction, and there is tree over here. Let's suppose first I am asking you, what is the velocity of A with respect to the bird? What is velocity of A with respect to bird? Simple relative velocity concept is velocity of A minus velocity of bird. Done, sir. What is velocity of A? That is 4i cap minus what is velocity of B, bird? Sir, that is 4i cap plus 3j cap. 4i cap plus 3j cap. Now, guys, 4 and 4 will cancel. So it will come out to be minus 3j. This is velocity of A with respect to B. That is given over here. Oh, sir. It is amazing. Yes. Yes. Next. If I say what is the velocity of B with respect to A, sir, that is going to be velocity of B minus velocity of A. Velocity of B is this, 4i minus 3j, minus velocity of A is 4i. So 4 cancels 3j. Yes. If I say what is the velocity of B with respect to C, velocity of bird with respect to C, you say, sir, that is velocity of bird, this 4i plus 3j, minus velocity of this C, this and this will cancel 4i. Similarly, you can find velocity of bird with respect to tree. Velocity of bird with respect to tree. Tree is at rest. So velocity of bird is this minus velocity of tree, that is 0. This is velocity of bird minus velocity of tree. This is 0. So this comes out to be 4i cap minus 3j. I hope this is crystalline clear. This is relative velocity in 2D. Like a ship is traveling due east. There is a ship which is traveling due east. Okay. The ship is traveling due east at 10 kilometer per hour. So this is the velocity of ship, 10 kilometer per hour. And I would write over here 10 I cap. Another ship is leading 30 degree, 30 degree. Another ship is leading 30 degree east of north. So this is east, this is north. So it is moving 30 degree east of north, means it is making 30 degree with the north. So this is over here. Another ship heading 30 degree east of north is always due north from the first ship. The speed of the second ship in kilometers is, the speed of the second ship in kilometers is, another ship is heading 30 degree east of north is always due north from the first ship, is always due north from the first ship. Wait, let me see, what is this question? Is always due. This is velocity of ship 1. This is velocity of ship 2. We are supposed to find this. A ship is traveling due east, okay, 10 kilometers per hour. Another ship is this. The speed of the second ship is, we are supposed to find speed of second ship. See, how can we solve this? See guys. If this is ship 1, this is ship 2, don't you think that it will have one component along this? Yes. Don't you think it will have one component along this? Yes. So this will be having velocity of, let's consider it B and let's consider it A. So we say along this it is going to be VB sine 30. Because along this it is VB cos 30. Here it is VB sine 30. Now you tell me one thing. Can I say here? This will be equals to this. So we say VA will be equals to VB sine of 30. So what is the value of VA? VA will be 10. VB in this particular case we are supposed to calculate. This is 1 by 2. So VB in this case will come out to be. Next, a bird is flying at a speed of 40 kilometer per hour in north direction. There is a bird which is flying with 40 kilometer per hour in north direction. This is velocity of bird. A train is moving with a speed of 40 kilometer in west. Train is moving something like this. Velocity of train, it is 40 kilometer per hour in west. Okay, a passenger is sitting in the train, will see the bird moving with the velocity of. Now we are supposed to find what is the velocity of bird with respect to the train, because it says there is a passenger. Guys, bird is moving along north, a train is moving along west. Now inside the train there is a person. With respect to that person, we are supposed to say what is the velocity of bird, means velocity of bird with respect to train. What will be the velocity of bird with respect to train? That is velocity of bird minus velocity of train. Now guys, what is the velocity of bird? That is 40 j cap. 40 j cap minus, what is the velocity of train? It is in the negative x, that is minus 40 I cap, something like this. So this is going to be 40 I cap plus 40 j cap. This is velocity of bird with respect to the train. And if I ask you the magnitude of this velocity of bird with respect to the train, it is going to be under root of 40 square plus 40 square. 40 square. Oh, is this clear? Oh, that is 40 root 2. That is 40 root 2. A car is moving with 30 meter per second along east, and a truck is moving with 40 meter per second at 30-degree north of east with respect. Find the velocity of the truck. Now, guys, same question once again. See, a car is moving with 30 meter per second along east. Another car is moving with 40 meter per second, 30-degree north of east. So 30-degree with east. This is velocity of truck with respect to the car. This is with respect to the car. Velocity of truck with respect to the car. Okay. Now guys, in this particular case, it is the similar question, exactly the similar question. Okay. Now this truck will have two components, one component along this, another component along this. So this is 40 cos 30 because this is 30. So this is 40 and this will be cos 30, 40 root 3 by 2. Okay, that is 20 root 3. And along this side, it is going to be, that is 40 sine 30. So this comes out to be 20 root 3 I cap. This will be 20 j cap. Okay, yes. Now what is the velocity of truck? 20 root 3 I cap plus 20 j cap. Okay, because this is 20 j cap, this is this. Then my dear friends, what is this? Velocity of truck with respect to car. That is velocity of truck minus velocity of car. So that will be something like this. It is given. Now velocity of truck minus velocity of car. Velocity of car is 30 I cap. So now take it over here. So velocity of truck will come out to be like this. Okay. I hope this is clear. I hope this is clear. Okay, this is a good question actually. See, in this particular case, it says velocity of car is given as 30. That is 30. And velocity of truck with respect to car, it is given as 40 and this angle is 30. We are supposed to find what is the velocity of truck. This is the question. What is the velocity of truck? See, if this is the velocity of truck, this will be its one component, this will be its another component. This is 40, so this will be 40 cos of 30. Okay, and this is going to be 40 sine of 30. Sine 30 is 1 by 2, so 40 into 1 by 2. This will be 20 j cap. And when you solve this, this is 40 into root 3 by 2. This will be 20 root 3 I cap. Now what is this velocity of, now see right over here, velocity of truck with respect to car. It is actually 20 root 3 I cap plus 20 j cap. How can you write this? Velocity of truck minus velocity of car is equal to 20 root 3 I cap plus 20 j cap. Now velocity of truck we are supposed to find. So velocity of truck minus velocity of car, that is 30 I cap, minus is equal to 20 root 3 I cap plus 20 j cap. Now take it over there. So velocity of truck will be, that is 20 root 3 I cap plus 20 j cap. Then you say this plus 30 I cap. Now in this particular case, what can you say? 20 root 3 plus 30 I cap plus 20 j cap. This is the answer. Please tell me in the chats if this is crystalline clear. Oh, tell me. Is this crystalline clear till over here? Everybody. Let me know in the chats. This is the last topic. Yes. This is the last topic. River man problem. I hope everything is crystalline clear. Oh, relative motion in 2D, in 1D. Now, guys, see. Rain man problem. River swimmer problem. This is a river man problem also, or we say a river swimmer problem, or river swimmer problem. Take a look, guys. The river swimmer problem means crossing the river in minimum time. Crossing the river in minimum time. Now, guys, see. Listen to me very carefully. This is the first case. River swimmer problem simply means the person has to cross the river. The person has to cross the river. So basically, river is flowing. The person has to cross the river. And in that, we need to discuss some cases that is called river swimmer problem. Now, see. Let's suppose this is the river over here. This is the river flowing over here. Okay. Let me show you over here. This is the river over here. Something like this. Now, this person has to cross the river. Okay. This is the width of the river. That is depth. Width is D. Now, guys, if this person starts swimming with a velocity of swimmer, Vs, and velocity of river is this. When he dives into the water, now he will be having two velocities, his own velocity and velocity due to the river. Okay, because when you dive into the water will take you along with it. Okay, now you will have two velocities, Vr and Vs. And resultant of these two velocities will be Vnet. Okay. Now you wanted to reach exactly at this point opposite, but due to this VR, it will drag you. You will land onto this point. Listen carefully. You wanted to cross the river with Vs, but due to river velocity, you are dragged. So you will be having this net resultant velocity. With this resultant velocity, you will land onto this one. And this is what we call drift. Now, if you ask me, sir, how much time it is going to take in crossing the river? Time is going to be distance upon velocity. Distance is D, velocity. With what velocity you are crossing the river? That is Vs. That's why I am mentioning Vs over here. Because see, due to this velocity, you are being drifted. Due to this velocity, you are crossing the river. That's why time will be distance upon velocity. Now guys. And if you ask me, sir, what is the value of this Vnet? Vnet will be under root of this Vr square plus Vs square. This is the net velocity. And this is the time in which if you cross the river. Third one. Sir, how much is this drift? This is the horizontal distance. So when you say this drift, how do you say distance? Distance is equal to velocity into time. Now distance is equal to, sir, velocity you will be taking this, that is Vr into, sir, time t. Sir, why Vr? Because due to Vr you are being drifted. Due to Vs you are crossing the river. So that's why Vr into time. So this drift, if you see over here, it will be Vr into, instead of time you will be writing D divided by Vs. Done with the first case of river swimmer problem. Nothing else. See, all of this is mentioned over here. Crossing the river in minimum time. If you want to cross the, see, in order to cross the river in minimum time, man must swim perpendicular to the river flow. Man must swim. This is the river flow. Man must swim perpendicular to the river flow. No doubt in this case, drift will be created. Man wanted to reach this point, but he will reach this point. Drift will be created. But time in this case will be minimum. Drift will be created, Man crosses the river due to Vm, and drift will be produced due to Vr. So in order to cross the river in the minimum time, you directly start drifting, you directly start diving perpendicular to the river flow. No doubt you will land onto this point, but time will take minimum. It will take minimum time. And that time is going to be d divided by Vm. Okay. And in this case, drift will be created. Drift is created due to Vr, and you are crossing this river with Vm. So that will be Vr into time t. Okay. And one more point. Drift will be Vr divided by Vm into d. Net velocity will be under root of Vr square plus Vm square. That's it. That's it. That's it. That's it. Let's take a look over here. Let's take a look over here. A river of 4 mile wide flowing at a rate of, there is a river. Okay. Its width, it is 4 miles. Value of d is 4. And it is flowing at a rate of, okay, I would say velocity of a river, it is given as 2 miles per hour. The minimum time taken by the boat to cross the river with a speed, okay, velocity of boat in this particular case, velocity of boat in this particular case is 4 miles per hour. And it says the minimum time to cross the river. Guys, what is the minimum time? Minimum time to cross the river. This is the minimum time. Vr by Vm into d. You simply say that is Vr divided by velocity of man into d. What is the value of Vr? That is 2. What is the value of Vm? That is 4. Vm means velocity of boat. And this d is also 4. This and this will cancel. So time will minimum in this case will be 2. Time will be 2. Is this clear? Okay. What did we calculate? What did we calculate? Drift. Oh, ho, 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 ho. Oh, ho, 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 ho. Sorry. We are supposed to find time. Time will be time. Wait. Oh, time. We are not supposed to calculate drift. Minimum time in this particular case will be Vm. Time is. How do we calculate time? See, this is the minimum time. This is the minimum time. That is d divided by Vm. That is d divided by Vm. D divided by Vm. And what is the value of d? That is 1. Okay, sorry. D is 4. Okay, what is the value of Vm? Velocity of man, that is 4. 4, that is 1 hour. 1 hour it is going to take minimum time. Okay. Even if I say what is going to be the drift in this case? So drift in this case will be that is Vr divided by Vm, okay, into we say d. Vr divided by Vm into d. Yes. Now that is going to be, what is the value of Vr? 2. Vm is 4 and this is 4. This and this will cancel, will be 2 miles. So this drift in this case will be created as 2 miles. This drift. Next, a boat is sent across a river with a velocity of 8 km per hour. Okay. A boat is sent across a river with a velocity of 8 km per hour. This is velocity of boat. It is 8. If the resultant velocity of the boat, this is the resultant velocity of the boat, this is 10. Then the velocity of the river is, this is the velocity of the river. You are supposed to calculate this. We say this net velocity is, this is net, under root of velocity of boat square plus velocity of river square. Now take it over there. This is v net square is equal to velocity of boat square plus velocity of river square. Now net is given as 10 square is equal. Velocity of boat is given as 8 square plus velocity of river square. So this is 100 minus 8 square is 64 is equal to VR square. So this is going to be 36 is equal to VR square. So VR is going to be under root of 36, that will be 6. That will be 6. Next case in this one. Next case in this one. Crossing the river in the shortest time, along the shortest path. See guys, if I say this is the river, if I say this is the river, okay, if I say this is the river, let me just show you here. This is the river. You want to cross the river along the shortest path. Shortest path will be this, directly opposite. This is the shortest path. Now, if you say, sir, I'll start diving something like this. This is the velocity of swimmer. Now, due to the river flow, this is the velocity of river. Due to the river flow, I'll be dragged, I'll be drifted. So I'll reach over here. So this is not the way to do. No doubt in this case, time will be minimum. But I would say, I will not move along the shortest path. So if you want to cross along the shortest path, what you are supposed to do is, you initially move at some angle theta. Okay, so this is Vs. Now this Vs will have two components. We say Vs cos theta and this will be Vs sin theta. And this is velocity of river. Now guys, what if I say, if this Vs sin theta becomes equal to Vr. If this Vs sin theta becomes equal to Vr, we say then this velocity will get cancelled with this velocity. You will be only moving with one velocity, that is Vs cos theta. And you will be moving along the straight direction. Then velocity of man, or we say velocity of swimmer, but then you can say net velocity in that particular case will be Vs cos. You can say it like this. The net velocity in that case will be Vm cos. See, in order to move along the shortest path, man has to move at some angle initially. This person has to move at some angle initially. Okay. Now, if this is moving with velocity of man, this will have two components, Vm cos theta, Vm sin theta. If this component becomes equal to this component, okay, if this is equal to this, then resultant net velocity will be Vm cos theta. That's it. That's it. This is the case when person has to move along the shortest path. In this case, if I say what is the time, how much time it is going to take, sir, time will be, it is crossing due to this. So time will be distance upon Vm cos theta. This is the time. This is the time in this case. This is the time in this case. Okay. And one more thing, angle between man and river flow. If the man is moving at an angle theta, this angle is 90. Angle between man and river flow is 90 plus theta. Yes. And net velocity is Vm cos theta that we have discussed. See now. Stream of river has a velocity of 2 km per hour. There is a stream over here. Okay. It has a velocity of 2 km per hour. Swimmer can swim with 4 km per hour. Find the direction of the swimmer so that he travels straight with respect to the flow. Guys, if the swimmer wants to travel straight with respect to the flow, okay, in that case means along the shortest path. In that case, he has to move at some angle. At some angle, I would say theta. This is velocity of swimmer. Okay, yes. And guys, if this is Vs, this will be Vs cos theta. This will be Vs sin theta. Now guys, see, listen carefully. We are supposed to find the direction of the swimmer so that he travels straight with respect to flow. We are supposed to find this angle, this angle. How much is this angle? See guys. In this case, it says that the person has to travel along the shortest path. If the person has to travel along shortest path, we say then here Vs sine theta must be equals to Vr. Okay. Okay. Yes. And what is the value of velocity of swimmer? That is 4. Swimmer can swim with 4. So this is 4. Sine of theta is equal to Vr is 2. So sine of theta is equal to 1 by 2. 2 ones are 2, 2s are 4. When is the value of sine theta as 1 by 2? When theta is 30. Okay. So now you got this angle as 30. So how can you find the value of alpha? That is 90 plus 30. That will be 120. So total angle is 1. So here the person has to travel straight with respect to the flow. This was J 2019. This is J 2023. The speed of the swimmer is 4 km per hour in still water. The width of the river is 1 kilometer. This is the width of the river. Okay. D is 1 kilometer. Okay. Velocity of swimmer is 4 km per hour. Okay. Velocity of swimmer is, this is velocity of swimmer. It is 4. He reached point 750 meters downstream on the opposite bank. The speed of the river is, he reaches 750 meters downstream on the opposite bank. Now guys, see, the speed of the swimmer is 4 km per hour in still water. The width of the river is 1 kilometer. He reaches a point 750 meter downstream on the opposite bank. He reaches this drift. Drift is given as 750 meters. Okay. Opposite bank. The speed of the water is, this is the velocity of swimmer. Swimmer is 4. Okay. This is the velocity of river. You guys are supposed to tell me the velocity of river. Okay. Yes. Tell me guys, in this particular case, how do we find the velocity of the river? Tell me. See guys, in this case, drift is given. Drift is given. We say drift will be VR divided by VM. VR divided by VM. This drift into D. How much is drift? 0.75 is equal to velocity VR. We are supposed to calculate divided by velocity VM, that is 4, and this drift, this width of the river, that is 1. So VR will be simply 4 into 0.7. 4 into 0.75. So how much it will be? So 4 into, this is 75 divided by 100. Okay. Okay. So this is going to be 20 in this particular case. 4s are, okay, 75 divided by 20 in this particular case. That is going to be 3 km per hour. Okay. But directly. The width of the river is 1 kilometer. The velocity of the boat is 5 km. The boat crosses along the shortest path in 15 meters. The velocity of the river will be. See guys, in this particular case, it says the width of the river is 1 kilometer. This width, D, is 1 kilometer. Okay. The velocity of the boat is 5 kilometers. Velocity of this boat is 5 kilometers. Velocity of boat is 5. The boat crosses the river along the shortest path. Means if it is crossing along the shortest path, it is moving at some angle initially theta. And time it is taking 15 minutes. That is 1 by 4 hours. 15 plus 15 is 30. 30 plus 30 is 1 hour. Find the velocity of the river. We are supposed to find velocity of the river in this particular case. Okay. Now guys, tell me one thing. Tell me one thing. In this particular case, velocity of boat is given. Okay. And D is also given. And time is also given. Tell me, what can you do in this particular case? Okay. Tell me. It is moving along the shortest path. It is moving along the shortest path. Okay. You say time in this case is D upon Vm cos of theta. If you remember this particular equation, when the particle moves along the shortest path, in that case, this is going to be the time taken. That is D upon Vm cos theta. Okay. So time in this case is 1 by 4 is equal to D in this case is 1 upon Vm. Vm is 5 and this is cos of theta. This is cos theta. Okay. Now guys, take this cos theta over here. Cos of theta will be equals to 4 by 5. Cos of theta will be equals to 4 by 5. Now guys, tell me. This is cos theta. That is 4 by 5. Cos theta is equal to 4 by 5. VR. What is the value of Vm? That is 5. Okay. So cos theta is equal to 4 by 5. So base is 4. This is 5. In this particular case. And this is going to be 3. Cos theta is base upon hypotenuse. This is going to be 3. So this will be 37 degrees. 37 degrees. Okay. Now tell me, in this particular case also, we say VR will be equals to, that is VB sine of theta. Because if the particle moves along the shortest path, then this VR will be equals to VB sine theta. So this VR will be equals to this VB. What is the value of velocity? That is 5. Then we say sine of 37. So this will be 5. Sine 37 is 3 by 5. This and this will cancel. So it will come out to be 3 kilometer per hour. 3 kilometer per hour. Is this clear? Next, this J 2021. A person is swimming with a speed of 10 meter per second at an angle of 120 degree with respect to the flow. See guys, this person is swimming at an angle of 120 degree with respect to the flow. So alpha in this case is given as 120 degree. 120 degrees. Okay. So total angle. And this alpha is actually equal to 90 plus theta. So this is 120 is equal to 90 plus theta. Take it over here. 120 minus 90 is 30. So value of theta is 30. So this theta is 30. This is 30. A person is swimming with a speed of 10 meter per second. So velocity of swimmer is 10 meter per second at an 120 degree with respect to the flow, and reaches directly the opposite point, opposite on the other side of the river. It reaches directly on the opposite side, means it is moving along the shortest path. Find the speed of the flow. We are supposed to find the value of VR. Now, in this particular case, as VR will be equals to Vs sine of 30. So value of VR will be equals to, what is the value of Vs? What is the value of Vs? That is 10. Sine 30 is 1 by 2. So that will be 5 meter per second. Is it clear? Oh? Tell me. हाँ वो मॉड्यूल्स ठीक है यार. That is good. 2025. 2025 के मुझे नहीं पता उसमें. No, Unacademy module is very good. Now, guys, Rain Man problem. Rain Man problem is to save yourself from the rain. Okay, like see. Rain Man problem. In this, you have first case when rain is falling vertically downwards. Guys. You need to save yourself from the rain. If the rain is falling vertically downwards, you'll be opening the umbrella opposite to that. You can save yourself. When rain is falling vertically downwards, see, this is the rain which is falling vertically downwards. This is velocity of rain. And there is a man moving over here. This is velocity of man. This is velocity of. Have you ever experienced this? When you move, at that point of time, it feels like rain is hitting your face. So you tilt the umbrella something like this. And when you stop, it feels like rain is hitting your head. So you keep the umbrella vertically, something like this. Okay. Yes. You might have experienced this. You might have experienced this. Okay. So while moving on a bicycle, at that point of time, you need to tilt the umbrella so that you can save your face from the rain. Why does that actually happen? Let me tell you why. If I say, what is the velocity of rain with respect to man? You say, sir, velocity of rain is downward. So this is VR j cap. And I would write over here minus VR j cap. Why? Because it is downward. Then minus velocity of rain with respect to man. Velocity of rain according to the man. Minus velocity of man. Minus velocity of man. Now, I would want you guys to plot this, plot this, plot this. How do you plot this? Minus VR. Minus VR, j cap is downward. Minus Vm is backward. Now, resultant of this one and this one will be velocity of rain with respect to man. Now, man is feeling that. This is a man. He feels that this is the rain which is falling at me at some angle. But in reality, it is falling vertically downwards. So he opens the umbrella opposite to that at an angle of theta. He opens the umbrella opposite to that at an angle of theta. Okay? He opens the umbrella opposite to that at an angle of theta. And if you ask me what is the velocity of rain with respect to man, under root of this VR square plus VM square. VR square plus VM square, its root. And this angle at which you need to tilt the umbrella so that you can save yourself from rain. That is this perpendicular by this base. Okay, let's take a look at the question. Rain is falling with a velocity of 3 meters per second. This is the rain. This is the rain. Velocity of rain is 3 meters per second. And man is moving with 2 meters per second. This is a man. He is moving with 2 meters per second. This is velocity of man. Find the angle theta and velocity of rain with respect to man. Guys, see, what is the velocity of rain with respect to the man? You say it is velocity of rain minus velocity of man. So you simply say velocity of rain is 3 I cap. Sorry. Velocity of rain is minus 3j cap downward, minus velocity of man is 2I cap. If we plot this will be minus 3j cap. This will be minus 2I cap. This is VR. This is VM. And this is going to be VRM. And value of VRM is going to be, its magnitude will be under root of 3 square plus 2 square. That is going to be root 13. And if you need to save yourself from the rain, you need to open the umbrella at this angle. If this angle is theta, you say tan of theta is equal perpendicular by base. That is 2 divided by 3. This is the value of tan theta. Okay. Then you have case 2 in this one. Case 2 is when rain is falling at some angle. Sir, how is it possible? Let me show you how is it possible. Let's suppose rain was falling vertically downwards. And due to this wind, we say this rain is now tilted at an angle theta. Now due to this wind, now rain is falling at an angle of theta. This is VR. If this is VR, this is theta, this will be VR cos theta, this will be VR sin theta. And this is a man which is moving in this particular case, something like this. This is VM. This is a man which is moving something like this, which is VM. Now guys, see, listen to me very carefully. We say if this velocity VM and this VR sin theta becomes equal, if VM becomes equal to the VR sin theta, means horizontal component of this rain becomes equal to the velocity of man. Then in that case, rain appears to fall vertically downwards. Let me make you understand this. See guys, if I say there is a person A, its velocity is 20. There is a person B, its velocity is 20. What is the velocity of A with respect to B? You say 20 minus 20, that is 0. So if the two bodies have got the same velocity in same direction, then their relative velocity is 0. That's what I'm saying. If I say this man and this component has got the same velocity, we say their relative velocity is going to be 0. So they will cancel out each other. So we say if Vm becomes equal to VR sin theta, in that case we say these two will cancel out each other. Then this rain will only have one component of velocity, that is this VR cos theta. So that's why I say rain appears to fall vertically downwards. So velocity of rain with respect to man will be VR cos theta. See guys, if I'm standing over here, rain is falling vertically downwards, that is okay. When I start moving, it feels like rain is falling at an angle, so I tilt my umbrella. Case 1. Case 2 is Rain is already falling at some angle. Now I started moving with certain speed. That speed is matching with the horizontal component of rain speed. If that happens to be the case, then we say these two will cancel out each other. We say then rain will vertically fall with respect to me. It feels for me rain is vertically falling downwards. But in reality, when I stop, rain will be falling at some angle. Again, if I move with the speed, that speed which is matching with this speed, then it feels like it appears rain is falling vertically downwards. This is the point. So velocity of rain with respect to man is VR cos theta. Let's take a look at the question. When a person walks on a straight road with a speed of 10 kilometer per hour, okay? When a person walks, this is a person, walks on a straight road, velocity of man is 10 kilometer per hour. Rain appears to fall vertically downwards. Rain appears to fall vertically downwards. For this man, rain is appearing to fall vertically downwards. In reality, rain is not falling vertically downwards. It's falling at some angle. But when this man moves, rain is falling vertically downwards. Okay. So it is like this. This is velocity of rain in reality. Okay. This is theta. And this is VR sine of theta. This is VR cos of theta. So if rain appears to fall vertically downwards, if rain appears to fall vertically downwards, then this Vm must be equal to, that is VR sine theta. As he stops, it falls at an angle of 30 degrees. As he stops, it falls at an angle of 30 degrees. So theta is 30. So velocity of man is 10 and VR is this, and this will be over here sine of 30. The speed of the rain with respect to the ground is, we are supposed to find speed of the rain with respect to the ground. Okay. Now guys, see, this is sine 30. Sine 30 is 1 by 2. 10 is equal to VR and this is 1 by 2. Take it over there. So VR will come out to be 20. This is the velocity of rain. Now, the speed of the rain with respect to the ground is, that is 20. We are supposed to find this. So yes or no? Tell me. Is this clear? So basically, when it says it appears to fall at an angle, it appears to fall vertically downwards, means this velocity becomes equal to this. Vm becomes equal to this. To a stationary man, rain appears to fall at an angle of 30 degrees. There is a man which is stationary over here. Rain appears to fall at an angle of 30 degrees. 30 degrees. Yes. Okay. So this is velocity of rain with the vertical. As he starts moving with 0.5 meter per second, as he starts moving with 0.5 meter per second, okay, he finds rain is falling vertically downwards. He finds rain is falling vertically downwards. Again, the question of case 2. So this is VR. This is going to be VR sine 30. This is going to be VR cos 30. Okay. As he moves, rain appears to fall vertically downwards. So can I not say in this case also Vm will be VR sine 30? Absolutely, sir. Okay. Okay. And when it comes to the value of Vm, that is 0.5 means 1 by 2. This is VR. Sine 30 is 1 by 2. This and this will cancel. So VR will come out to be equal to 1. Velocity of rain. Then the speed of rain with respect to the moving man is, we are supposed to find velocity of rain with respect to the man. That is VR cos theta. Oh my goodness. See guys, see guys, see guys, see guys, see. See, if rain appears to fall vertically downwards, appears to fall, it is not falling, appears to fall, then Vm is equal to Vr sine theta, velocity of man. Okay, then we say this becomes equal to this. And velocity of rain with respect to man, that is equal to Vr cos theta. Same question is over here. Same question is over here. Velocity of rain with respect to man will be Vr cos theta because Vm is equal to Vr sine theta. Okay, so this will be, what is the value of 1? And then we say cos 30. Cos 30 is root 3 by 2. So this is root 3 by 2. This is the answer, meter per second. This question I am giving you as homework. This is a simple question, not that complicated. This question also I'm giving you as homework. Okay, so that's all. We are done and dusted. Guys, do let me know how was the session, okay? When I end the live stream later on, okay? Do let me know how was the session. Good night, good night, good night. This is enough for NEET 2026. Yes. Yes, Unacademy module is good for question practice. Yes, very good.